What is up, hackers and hackettes? To all of you hackers out there, how's it going? Good midnight. Hope it's going well. All right, let's get into it. Okay. So today I don't really have anything planned. We're just gonna look at calc.exe. We're gonna improve our fuzzer. We're gonna just kind of learn and go with the flow, and whatever bugs come by, we'll take them. So I want to show off Windows PE today. Windows portable environment. I forget what it's called, but it's a really lightweight ISO-based Windows version that's really useful when you're doing lightweight fuzzing. We're gonna see if this is if Windows PE is usable for this calc.exe fuzzing. If it is, that will reduce our overhead, it'll reduce our snapshotting time, our keyframing time, and it will just kind of make our end-to-end process a little bit faster. So I'm going to kind of show what Windows PE is and kind of show how you set that up. So Windows PE is mainly used for our pre-installation environment. It's mainly used for exactly that. It's for like configuring, setting things up. You can kind of use it as like a repair disk as well if you really need to get in there. So to create these like Windows PE images, you need this 80K. I already have the 80K. I should deploying an imaging tools here. So with this 80K, I'm able to do we're gonna go into a WinPE. I'm just gonna make a new folder in here called WinPE, and with the 80K, you actually kind of create these ISOs yourself. It's kind of weird, but all the documentation is surprisingly good. I can just look at create bootable WinPE image, and here, if I just run this command, that's it. I might need to be admin. Nope, doesn't look like it. Oh, maybe I do. Oh, I had the path wrong. Let's see. And we will run this as admin because I think we will need eventually mount this kind of during this process. So we're going to go into our D WinPE folder. We're going to create a copy into D:/WinPE MD64. And that's going to create a copy of all the files that are needed for this media. And in fact, it has like if we look at mount will be empty because that's kind of the mount point where things will get mounted to. If we look at media, this has like kind of all like the boot stuff, and then in here in media sources, I think this has the boot.wim, which is kind of like the compressed archive containing the root partition. Would you be interested in undo tree library for time travel? I was wondering over design. Right now I'm not quite sure what direction I'm gonna head in there. Eventually I will be interested in that, but in the short term, it'll be kind of hard to tell until there's some good adoption and I see what people want and what environment they want to use. But yeah, long term, yeah, there's actually a lot of bugs kind of on the tracker right now that I need to get to before I start implementing more features, sadly. So what I should be able to do is create a WinPE image from here, and I'm gonna make some batch files for this. So I'm gonna make gvim make iso.bat. This is just gonna run this make PE ISO command. D:/WinPE MD64. We're gonna put this to D:/WinPE, and we should be able to just run make ISO. And there we go, we have a bootable Windows PE ISO. So if we take a look at what that ISO looks like in Hyper-V, I'll be able to point this to D WinPE this. And it's just a really lightweight Windows environment, which is fantastic. And this is up to date. This is like a Windows 10 kernel. And look at the boot times. Perfect. It's exactly what you want. It boots up, and then immediately you kind of drop into the shell. I think it has networking and everything too. It doesn't have a calculator, so we're going to have to put calculator on the system. But that's fine. This is just, it's super lightweight. There's no disk requirement, so all I have in here is just this ISO, which is 300 megs, and that means that's the only thing that I have to kind of keep around. Can I have this for my desktop? I wish. I've actually looked into doing some like serious modifications of this to try to create my own like little Windows distro. So it's really cool is we can just shut this down hard since there's nothing persistent. Everything is in memory. It makes it a lot easier to work with kind of a deterministic environment. We don't have to worry about, oh, did I shut it down cleanly? Are these reg keys in the right states? Everything's always in the same state every time. So now what's really cool is that you can mount these. And the way you mount them, I'm just going to look for the command. That is capturing the image. I always kind of just look through the commands. I always forget the right command sequences. Modify an image. Come on. Root to Windows PE. Customize. Here we go. Mount and customize. So what I can do is I can mount this. And I'm going to make another file called mount.bat. And all this is going to do is this takes in the win path. So :/winpe md64. That's going to mount it to this mount path, winpe md64 mount. And that's it. And then that's how you like put stuff in, add files and folders, startup script, add an app, blah, 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 temporary storage. Add updates. Ooh. High performance. And then here's the unmount. So I'm actually going to put... so we're going to make another one, sp dismount.bat, or unmount. I don't know, unmount versus dismount. Kind of hard to pick between those. WinPE, md64 mount, commit that image. So now what I should be able to do is I should be able to do mount.bat. This takes a little bit of time. Like, it's still fast, but it's not instantaneous. So if we look at AMD64 mount, this now has that X directory that we're used to in when we boot up in Windows. So we can kind of change a bunch of things about that environment. And in fact, one thing I could do is I could go find where it calls the WPE init, because that actually like adds a lot to the startup time. So here we go. If we look at this, this is like this is, I guess, just the start net command, and we can see who uses this. Okay. So I'm just gonna delete that from the start net. We're gonna do on mount. Actually, I'm gonna make another file called commit.bat, and this is gonna call on mount.bat, and then make iso.bat. So this will commit that, so we'll create the new Wim file, and then this will also create the ISO. I think, did it not create the ISO? Make ISO, do I need another new line on there? Yes, and then I'm guessing this probably has an override. F, or overriding. So we're gonna put a /F in there, make ISO. I just don't want to see those prompts. Whoop. Do I need this put? Oh, this goes after. I hate when ordering matters, but whatever. ISO and then /F. So now we can just do that, and now we should be able to boot up, and this will go right into the prompt. It will skip the WPE init, and we just will have a really clean environment. There we go. We already have a terminal. It was, what was that? 4 seconds? 3 or 4 seconds? I think you have a task manager. So we have task manager. If we look at the services, oh, that's interesting. It has the old task manager. Huh. If we look at services, we've got like only the bare minimum. Almost no processes running, which is, it's just great. It's so rare to see a Windows system using this little memory, and this is like modern Windows, so all the mitigations and everything should be in here, although they might not have them enabled. Okay, so we'll shut this down. We're gonna do a mount. I want this so much. Yeah, it's just WinPE. You can go grab it. It's free. Yeah, it's completely free, actually. This is, you can get a Windows kernel that you can work on for free. Like, all you need to do is grab the whatever it's called, the ADK, which is like a 1 gig download, but whatever. And you can do this for 32 and 64-bit. It's sweet. It's really cool. We could actually see how much we could constrain this. Let's see if we can boot it on 64 megs. Is that ambitious? Whoa. Hyper-V can't even assign that little memory. Oh, dynamic memory. Okay. We're gonna try 64 megs. See if it plays. Yeah. Needs more RAM. I'm guessing like 256 probably sufficient. Maybe not because it needs our RAM disk. Yeah. Okay. So it's still heavy. 512 should probably do the trick. Yeah. It's just so nice. There we go. Task manager. We're now like hitting that ceiling. So I think 1 gig is the correct amount here. It looks like the RAM disk expands to about 500 megs. Yeah. So if we look now, yeah, now we're using half of memory. This is plenty. Everything looks hunky-dory. No kernel memory being used. It's so lightweight. It's just glorious. It's a great environment. So let's see if we can get that 132 calc. Actually, yeah, what is this? Source of the binaries. Got the binaries from here. How exactly does this project work? I am curious, like, what Win32 calc actually does. What is source code? What is source code? I feel like this is not actually source code. ISS. Oh, is this the installer thing? Yeah. Okay. Language pack, blah, blah, blah. So I don't want the whole setup. I might need to do the setup, so we're going to see. Let's see if we can open this up. Open an archive. Oops. Maybe I can just grab the one that's installed on this machine. Windows, System32, Win32 calc. And let's see if this runs from another directory. The other calc did not, and this one doesn't either. So I think we all need to run that setup, which is a little concerning because setups often don't work in WinPE. Like the utilities needed are usually not there. So we'll take a look at AMD64 mount. We're just gonna put it right here in the root directory, and then we'll do commit. Unmount image commit, unmounting, and then make ISO. I don't know why the commit.bat isn't running the make ISO after unmount. Maybe I have to do like start or something. I don't know. Yeah, there's source code for the new calc. Yeah, the new calc's just boring because it's just all like, I don't even think there's native code in there. So now if we go to X, we should have our 132 calc. Let's see if this works. No. It's native code, but working with the modern GUI lib. Oh, interesting. GitHub. I mean, this would maybe be an interesting pivot. Let me see. It's all gonna be C#, isn't it? If we look. I want the like click for language details. Oh, it is C++. Ooh, okay. Oh, all right. Okay. Okay. Well, that that could be on the menu. Let me see if I can get this old calc working, just because the old calc is the one that's fun. Actually, you know what would be a relatively fun reversing thing is getting that calc.exe to run. Calc.exe won't run. I want to see if there's like someone who has done this. Like, I don't know what this installer does. I guess maybe that's what the source code told us, is what the installer did. ISS. This is going to... Okay, app name this, source directory, blah, blah, blah. 132 calc. Is the installed language. If I look for... I just want to like get that working outside of the Windows folder. Win32 calc. I'm guessing there's going to be a MUI file, an MUI file, and then also probably the actual executable in here. Well, the executable should definitely be in here. How to get the classic calculator. Okay, nice website. Windows 7 classic calculator. That ported the classic calculator to Windows 10. That there's an installer method 2. Calculator plus. Oh, that's like the Windows XP calculator. Ho 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 ho. Interesting. Okay, what do we have in here? Oh, there's like a lot of resource files in here. What is this? What is this? Is this really necessary? So there's a Win32 calc. It's really just these 4 things that I care about. More specifically, these two, the 64-bit ones. And that was in ENUS, I think. So we're gonna see. I think we tried this before. Dev. I just don't know like what it would be setting up in registry or registering in a way that it wouldn't like just putting them in the same spot. So we can put in System32. We can put the Win32 calc. And then it was in ENUS, if I'm not mistaken. Is that gonna search again? ENUS, Win32 calc, MUI, okay. Commit. Make ISO. When in doubt, run depends on it. Yeah. Hey! That works for me. Perfect. So now we have the calculator running in this really lightweight VM that should have like no overhead to our fuzzing. And this will just kind of reduce some of the noise that we see when we're fuzzing and hopefully kind of speed up some of the fuzzing performance that we get. So we're also going to want to throw in the agent in here that we use for snapshotting. So we'll grab... Isn't this so cool that you can like mount this image and just like change stuff in it? Dev, Tico, Fuzz Franzia, actually James Bond. I'm just going to make sure this has been built recently. Cargo clean. Cargo build release. What? What? What happened here? Did someone change this? Get blame source main. Well, that's all me. Get log star. What? What? I don't know what broke. Oh, did I add a, yep, I added another field here. Get status. Oh, I need to remove those files too. Okay, cargo build. Release. Yep. I think I made a slight change to there, and then I'm just gonna go into box source del tags plugins del example socket plugin cargo.lock example socket plugin target get status These are just the build files. What? Armor SQ, okay. Del. These. Probably should paste. Oh my god, come on. Damn file pathing. Get status. Get diff. Get commit. Get pull actually. Get status. Get commit. Get log. I think I'm gonna make a new branch at this point. Get status. Get checkout B. Calc fuzz. Get status. Get commit. Fixed James Bond. Push. Yep. Okay. Okay, we are in business. So we built the release build of this, and we got the right cargo stuff. So we're just gonna whack this in the root directory here. We'll get rid of the setup. And then we'll make that ISO. Nice, okay. So we should have Win32 calc in here, and we should have James Bond in the root directory. James Bond. Looks like that's running just fine. Win32 calc.exe. Nice, okay. So now we can take a snapshot. I'm gonna make a copy of that file. Ooh, you know what? I actually want to enable page heap. The last fuzzers that we deployed, we didn't have page heap on, and we're getting to the point that we no longer care about the ways things can crash. We're more interested in finding the root bugs and then root causing them. So let's see. I don't know if G-flags run standalone, so I'm gonna see if I can copy the G-flags binary into there. 10 debuggers x64 G-flags. I'm gonna grab G-flags in the G-flags UI. So I'm not 100% sure if G-flags can work in this context. I don't even actually know if there's page heap support in Windows PE. I could see them stripping that out. Okay. Commit. Make ISO. Yeah, I've gotten some cool things working in WinPE. I've like hacked things up and copied and pasted registry keys to like actually get like full-blown applications running in here. It's just fun. G flags looks good. G flags I win32 calc.exe plus HPA. Okay, G flags win32 calc.exe. Or I current flags is that win32 calc.exe. I'm gonna assume that that is working. So that looks good. We're gonna have to rerun that command when we boot it in box, because obviously we lose all those settings, which is great because we have such a clean environment that we're doing all of this work in, and I love that. I love having a clean environment. So here we're gonna call this WinPE MD64 with win3 calc and G flags. Okay, and I'm gonna put this in our Twitch fuzz calc folder right here, and now that will just kind of live there forever. So what we're gonna do is we're gonna boot up box. We're gonna get box built locally. Box build armdir sq box build. We'll just python build.py. We need to be in a C window. And we're just gonna quickly build that that box. Make sure we're latest and up to date with any commits we've made. I hate how slow configuration is on Windows. I think it's mainly because of Defender. Let me see. Get MP preference. Set MP preference exclusion path C:/ add MP preference D:/. There we go. So we should have the C drive and D drive entirely excluded from real-time scanning. So that will make everything a lot faster. Okay, now we're just gonna go in and take a snapshot here. So we'll do this box win7. We're just gonna grab kind of these things, and this will be a box. This will be WinPE calc. Paste these in here. And then in this case, we can grab, the only thing we need is a CD-ROM. CD-ROM, Twitch fuzz calc, and then this path. That should get us everything we need. I don't think we need to specify a mode. Status inserted. You know, we can just grab all these things, just make sure we do it correctly. Okay, so we should be able to boot this up in box WinPE calc, type run that bat. And I want to do this with that box browser. We don't need VX share, we're not using that right now. Good. Okay, couldn't find box build. That makes sense. We can just hard code some of these paths. Box build. Oh, that's in the actual run. We'll just put d:/dev tkfuzz run. Okay, box browser disabled, 302 meg ISO. We'll see how fast this boots up. It'll be a lot nicer than actual Windows 10, and it'll be nice to be working in Windows 10 instead of Windows 7. We'll just have like better support for some of the stuff that we have in TKO, like the module or the process name stuff. Okay. Looks good. Obviously, it takes a lot longer with full emulation, but it's still this will boot in probably like a minute, whereas full Windows takes like an hour to boot in box. Windows 7 takes like 10 minutes. Crazy how much bloat has been added. It's really a shame. Such a good kernel. Really good kernel. Come on. Making me regret disabling Boxer Visor. But I just like, sometimes I question switching between the hypervisor and this mode. What's really nice about using an ISO is you don't have to worry about any like persistent registry keys with hardware information. This is like everything in WinPE is generalized such that it can boot on any system, whereas Windows itself kind of caches some information about the system and might make some assumptions about drivers and devices. That used to be a big problem in Windows 7. If you've ever moved like a Windows 7 platter between machines, you'd find like, oh, it doesn't boot at all, it just blue screens during the boot process. I actually haven't seen that on Windows 10. Windows 10 seems a lot more resilient to moving around disks between hardware, probably because of virtual machines. They need that ability to move VHDs around a lot. All right, WinPE shell. Here we go. We'll see how quickly this hits idle as well. Okay, still haven't really hit idle yet. And it looks like, there we are. We're now idle. Really nice. So, and there's no defender, there's no real-time scanning, there's no firewalls, there's none of that crap that can get in the way of fuzzing. So if we had a clock open right now, we'd see that we're going like 30 times faster. We're doing 30 seconds per second. And this is really important because the next step we're gonna wanna do in our fuzzer is we're gonna wanna have our fuzzer randomly put sleeps in to potentially wait at random points for GUI rendering updates, and by having a much more idle system, we can ensure that even if we put in 1 second sleeps, that the time will breeze by in the box execution window. Like right now, this is emulating 32 or 3.2 billion instructions per second, and this is basically running 32 times faster than the 100 million that I'm saying is happening per second. So if we like pulled up a task manager, we'll probably see need to capture the mouse here. There we go. We'll see that this stuff's gonna update really fast because we're just so idle, which is really cool. So I love seeing that. Close that out, and we're back to idle. So it looks like everything goes idle really fast in this environment, which I love to see. So yeah, it's like immediately after doing an action, things go idle. So we can do gflags I, win32 calc.exe plus HPA. Oops. There we go. And see how it kind of slowed down for a second while it was processing that? We can launch win32 calc now. Obviously, it's slow while it's loading those resources for the first time. And then everything's back up to speed. All good and proper. So, and I'm going to switch some of these menus around. I just want to get all of these menus warmed up and make sure that all these assets and pages are paged in. I can also do this programmatically once we get TKO up and running on this snapshot, but it's just kind of nice to enumerate some of these options and just make sure that all these resources get loaded. Yeah, like this one's really expensive to open. Unless I misclicked it. No, I think it's just taking its sweet time. There we go. So then if we switch back to basic, that was pretty fast. And if we go back into it, we'll see if it takes long again. Nope, that time it's a lot faster. So that's what I kind of mean by like warming up your application, is like getting these sorts of things, getting these sorts of resources loaded up. So effectively what I probably should do is I should let the fuzzer run for a while and then kill calculator and then reload a new calculator instance. But we're just getting everything warmed up here manually. And all of these options, if we turn on like history, looks good. Okay. And then help. This one will be really expensive. Oh, you know what? Help just might not work at all anymore. They just might not have like the required stuff. So about calculator, we got that open. It's interesting. It doesn't seem like the system wants to go idle when this is open here. This must have like a really inefficient rendering where it's probably rendering all the time. Whereas normal calc, this goes idle. So looks good. We're gonna set everything into standard mode, turn off all of the configurable options. Okay, so now it's warmed up. I just want to double check. Going into unit conversion, it's now faster than the initial. Okay, so this looks really good. And I'm gonna do is I'm gonna try and move this down to the bottom of the screen. Not that it really matters. CLS, and then we'll run agent.exe. Oops. James Bond. All right. Everything's idle. Calc's good. Calc's ready. There we go. So we're taking a snapshot, and the snapshot will be much faster than what we're used to, since it's a 1 gig VM. It's just going to be so much better. Snapshot done. So now if we look, we should have a snapshot folder here. Everything looks good. Oh, you know what? That's why it took so long. We're gonna go through that whole process once again. This time we're not gonna use 8 gigs of RAM. It's just unnecessary amounts of RAM. So my bad. I forgot that we set that up with 8 gigs of RAM. So how's everyone doing today? Ooh. I'm invited to be a Twitch affiliate. Holy shit. I just got an email that I can now be a Twitch affiliate. Well, look at that. Popping those 20 consistent viewers. Oh, Twitch wants my big ad money now. Oh, shit. Let me see if I can put that in play. Where is that? Where would that option be? Twitch actually has like a really cool like dashboard and everything for creators, which is kind of cool. Like achievements, what is it? Path to partner. Partner, they want you to stream on 12 different days in a month and then average 75 viewers. And it looks like right now I'm averaging about 30 viewers, which is pretty incredible. I'm used to having like 5 viewers, so anything over 10 to me is like, holy shit. Especially since I'm not really going out of my way to make entertaining content. I'm just like streaming real work. Wow. Wow. That's kind of cool. Payout registration. So I just have to set out all that up and like tax stuff. I'll maybe do that tonight. And then I think with affiliate, people can subscribe, which is kind of cool. I could maybe make like whatever one emote I get allocated for having such a small viewer base. But you know what? If I can have a Twitch emote, I'm happy with that. That's pretty cool. You know, I'm glad to have people around watching this sort of stuff. I think this sort of work is really entertaining. So I'm really glad that I haven't really had to have gone out of my way to try and make something more entertaining than it actually is, and people are still interested in it, which is really cool. Come on. Can't believe I took that with 8 gigs. It's just like so unnecessary for calc fuzzing. Okay, we're almost there. We'll do G flags I win32 calc.exe plus HPA. Get that page heap enabled before we forget. That is now good. System is idle. Love it. All right. Okay. And now we're just going to switch these modes again, kind of warm it up. Good. This one will go a little bit faster because I know roughly what to do. Stats. This is surprisingly responsive for Box. Box is not the most responsive application out there. Yeah, opening this menu up for the first time is really slow, and I don't think I warmed this up on our original keyframe. So these fuzz cases might be a little bit better than what we had before. Date calculation. Worksheets. I don't think these really have any special resources. I don't think going through these does any difference. But these are actually loading really fast now, which I like to see. Scientific, we'll put it in history mode quick. Turn on a digit grouping. If anything, this just reduces the amount of things that have to get paged in over the disk, or over the CD-ROM in this case, which is probably really slow for emulation. Okay, about calc, looks good. Close that. And we're gonna turn all of this stuff off. Turn off history. And go into basic mode. And I think we're good. I think this is a good looking calc. And then I'm gonna move this down a bit. Okay. Move this down a bit. Clear that. And we'll run James Bond. Everything's idle, everything's good. Here we go. Taking a snapshot. There we go. Now it was like 1 second to take the snapshot. So much nicer. So much nicer. So now we'll go into and TKO fuzz, Franzia. And I've been trying to run it in a different directory now. So Franzia runners, Armder calc star, or del calc star. You know what? I don't think I need anything in here actually, except for run. Run reminds me how to. Run reminds me how to run this. Yep. So this will do that, and then we'll do this should work just fine. Okay, we'll do a convert. We'll pass it the path of this. And we'll just put this WinPE calc 1 GB warmed will be the name of this one. Just a little bit more descriptive of a name. Okay. Uh-oh. Couldn't find the file. Really? Because it's right there. Set rust backtrace equal to 1. What's the issue? Run convert here. Oh, I need to set fake fs path is equal to dev tco fuzz franzia fake fs. Hey Byte Swap, thank you for following. Welcome to the stream. Hope you're having fun. Hope you're having a good day. Okay, now we should be able to do this, and now we can keyframe it to calc. Kuhari, welcome. Thank you for following. We're gonna do keyframe this as calc. Okay, and now I can do a cargo on start calc. So now we actually have the now we have this task list that you guys have never seen before. We don't have this implemented for we don't have this functionality implemented correctly for Windows 7. So when we go public, when we open source the TKO fuzz stuff, we're going to try and make sure that we have like Windows 7 through Windows 10 supported really well as like Ubuntu latest, because we really want to make sure that we have some nice Enlightenment features like that coming out the gates. So then I made this plugin optional, which is a new feature that someone on the team added, and I actually don't even know how to use it. Basically, I set my plugin as optional, and I think that is what is recommended, but I don't know how to dash and then options. Our command line stuff is so broken. I actually set up a meeting like a week out to fix a lot of this. I don't know how to enable. How do I use optional? As the author of the tool, I don't know how to use it. It's never a good sign. As one of the authors of the tool, I should say. RG optional. How does that work? Add a procedure here, make it optional, and add it to source settings. Okay, I added it in here. Do I have to make dash features? Okay. So I can do dash features calc fuzz. Nice. Okay, that's not too bad. Obviously, I don't need help anymore. So this should now hopefully re-keyframe. And it looks like it probably did. Those crashes we can ignore. Not a big deal. Right? Is that generating a calc stepped? Yep, so now we have a calc stepped, and now we can run start calc stepped. Sweet. And there we go. We got a crash in calc. Sweet. Which is exactly what we expect. So it looks like our fuzzer just automatically ported all the way over to this new snapshot. There's really nothing we have to do. So we can close out some of these files and folders. Now everything's kind of set up correctly. So what I'm going to do is I'm going to deploy this out. And then we're going to start working on we'll do a start whistle export fake fs path is equal to mount d dev tko fuzz franzia fake fs, and then whatever that humongous command was, this manifest path mount d dev tko fuzz franzia cargo toml. Okay, should be good here. Then server, nice. So server calc stepped. Okay, and let's just delete those coverage files. ls rm calc step.coverage star. And now we have a server up and running. And we'll just putty into archive. And we should be able to go into Tico Fuzz Franzia, get poll, get checkout calc fuzz, get poll. Okay. Go into brawler, clear, cargo run, release. This should be good. Build that noodle. I like that name. I'm really happy with that. And then gamey.bfa.lk 1234. And that should come online. And we should be doing distributed fuzzing. So, nice. And I think we have all the timeouts and everything set in there. So we can see where our CPU time is being spent, which is really cool. So we can actually see a significant amount of CPU time is spent in fuzzer. Unknown image name, I'm gonna guess that's calc. So basically, we're not able to page in memory if it's paged out to disk because that's an operating system level construct. We don't have that knowledge of where to find. We don't know where to find things on disk. So effectively, if we're not able to read that memory, we just print unknown image name, which I'm gonna hazard in this case is probably a calc. Conhost is using a lot here, which kind of sucks. Okay. And now we can go into our Franzia runners. Take a look at our crashes. Haven't seen any crashes yet in calc, which is sad. But everything should be deployed out. These fuzz cases haven't completed yet. Are these still paging and things? Oh, is it because I don't have... Oh, I didn't... I was so confused. Dash features. Yeah, calc fuzz. I was deploying it without the fuzzer. Does not have these features. And then this then? Okay. I was like, how is that not crashing? And why are these fuzz cases so long? That makes a lot more sense. Okay. Now we actually have those up and running. And I'm going to kill these quick. I'm going to reset that coverage state. Run this with calc fuzz, workers online, spin up these. Whew, we did it. Finally. Okay. So now I'll have these crashes coming. Okay, we do see Win32 calc, and yep, Win32 calc is at the top of CPU usage, exactly what we want to see. We want to see as much CPU usage as possible. So we have page heap enabled as well. It's hard to say whether or not that page heap is working yet until we see some crashes. So let's take a look at this one. This is a read user. This is reading from this. So that's interesting. We'll probably want to go through and repro a couple of these. Bunch of crashes in the kernel. Not a big deal. So the bigger issue is probably the amount of spew. 64 cases. I'm curious why that kernel is so busy. Now they're rolling over to some new fuzz cases. Oh, I need to set the... Oh, yeah, I need to, yep. So, in my fuzzer, I need to update the CR3. So, this folder will go into TKO Fuzz Franzia, gvim, plugins, calc fuzz, source. And then once we get this up and running in this new environment, we're gonna make our fuzzer much better. Yeah, this is on a different server. Yep. So in this case, I have a CR3. I'm actually going to look for any OX. Anything that's OX could potentially be a hard-coded address, and it looks like just this one. We can go grab this here, and we know that this is the CR3 for the calculator application we're running, and we're actually going to say calc CR3, and we'll do const calc CR3 usize equal to this, the CR3 of the calc we're fuzzing. Okay, so this should be a lot better. It's at U64. No problem. Okay, up and running. Load all that coverage, and now we probably won't see as many kernel crashes. In fact, I want to delete all the coverage again. Now we're in a better state, and hopefully I won't see any of those kernel I mean, we're still going to see some kernel crashes. Is this headless Windows? No, this is something called snapshot fuzzing. So effectively what we did is we took a VM that we ran in Box, and we booted up, I can kind of show you, I'll show you in Hyper-V just because it's a little bit faster. So we took this WinPE image and we booted it up inside of Box, which is a full system emulator, very similar to QEMU, but it's not a hypervisor. It is indeed an emulator, and we booted up this version of Windows. This is called Windows PE. It's free. You can go get it. It's for mainly configuration, doing like configuration of setup environments for enterprise deployment sort of crap. So, but you're able to like mount and change this image. It's just on an ISO, which means there's no disk, which reduces the overhead and all of this crap we kind of have. And all we did is we just put Win32 calc in here, and this is what we're fuzzing. We're actually fuzzing in this environment. So we don't have it rendering to the screen because we don't need it to. That's happening kind of behind the scenes. There's just no reason to show what those windows are actually doing. So we have, in this case, we have 64 fuzz workers online, and our performance actually looks not too great. It doesn't look nearly as good as what we used to get on the other image. But it's hard to say why that is. That's kind of the tough part with snapshot fuzzing. You know, this number might actually climb. They might still be warming up those VMs. But it's also possible that there are some things that are getting paged in very frequently. And here we have all the crashes coming in. So if I filter for .star crash, these are all the unique crashes that we have so far in Calculator. So what I'm going to do is I'm going to bring some more servers online. We'll grab Fileland. We'll bring this online here. What does he have? Git. I think I probably have this. Yep. Grab Brawler from Archivey. Brawler gamey.bfa.lk 1234, and this should bring up another 256 cores, and we'll get the real perf going. Is rendering slower on WinPE? It could be. That could totally be the case. Also keep in mind we turned on page heap, which could potentially make allocations much slower. So, in fact, I think a 5x from page heap is totally reasonable. So we've got these workers online. So we now have 320 workers, 320 cores fuzzing this up. Is it a local server or a third party? It's a local server. It's hosted in another room, a couple steps away from where I'm sitting right now. Okay, here we have our first non-canon access. So my guess is that this non-canon access, this is probably going to be a C0, C0, C0 access. 256 cores, is that a single 8-core CPU? Nope, it's just a one CPU server. It's a Xeon Phi. So it's a single Xeon Phi 7210. So it's a 64 core with 4-way hyperthreading. So it's 256 hardware threads. All right, let's get reproducing environment set up as well. We're gonna do this dev make dir Franzia repro, and then we'll take Franzia runners run.bat, take this command -- features calc fuzz. We'll pass it the path of the Franzia runners calc fuzzed. Oops, calc stepped. And then I should be able to cargo features that -- repro on the calc step binary. We're gonna reproduce. We actually have 2 non-cannons, which is really good. Love to see non-cannons. We're gonna take a look at this one quick. -kd net kd net host, kd net serve. I think host 127.0.0.1.3333 kd k net port 3333. KDNet serve, KDNet net. What is it? How do I not know what that is? gvim plugins, KDNet source, lib commands, con. There we go. KDNet connection to there. And this will connect in. Oops. Do I need another one of those? Cannot find calc stepped. Maybe this doesn't work from a different directory yet. I mean, it's not a big deal. So I'll just go into Franzia runners. We'll make a copy of the calc stepped mem and state files. And then we'll just do this. And then up here. Ooh. Is there a faster way to caret? Yeah, there is. Okay. We're going to repro using calc stepped copy. Uh-oh. Uh-oh. Well, there's a KDNet bug. That's KD crashing. What? Reading from null. Copy X state. Oh my god, really? Is it gonna repro? Yeah, it is. Come on, Katie. We got a couple of those non-cannons now. I really want to look at these. I'd really like to look at them. But really? What is this in? This is in a null DRF in copy X state to legacy context. Get context state. How to debug a kernel debugger? Yeah, this is a bit annoying. I can probably hack something up here where I will not send a message of some certain type. That's kind of annoying. Let me see. Receive. Oops. Drain break-in. Yep. There's also receive packet. Who calls this? I just need to see like what state it is in. So we'll see rx packet this response. Hopefully we have debug implemented on that object, and it looks like we do. So we got a control packet. Byte count that. Packet ID 124. So if we got a control packet, check the type. Acknowledge. Okay. We're just updating that. What do I usually use my server for? Just fuzzing. Mainly fuzzing. Sometimes I'll do like random research and sciencey stuff. I'll do like random Monte Carlo sims or like neural net stuff. But typically fuzzing is what I use it for. Acknowledge. So we got all of these things. I feel like I've run into this bug before, and I'm trying to remember what the fix was. Connect live, get target context extended, get context state. Let's take a look in our code and see where we have context. Oops, that's calc fuzz. Context. For an unenlightened guest. And then for an enlightened guest. Write context on break. DR0, E flags, MXCSR. Suspend execution. Process state change. So we're gonna send a state change. And do we have these anywhere else? Nope. So this is return to state change packet that's sent on initial connection when a break-in occurs. In this case, I'm guessing that some field just gets misaligned. Include segments, program counter, number of parameters. Case special. Are we getting any read control space commands? Doop de doop. State manipulate. Acknowledge. Control packet. Packet leader. State manipulate. What do we do in this case? Parse packet state. Okay. And I guess all of these are part of the manipulate API. Okay. We're gonna see if any of these get hit. Get context ex. Rx packets that. 1576 L. It'd be really nice if the debugger wasn't crashing. Get context ex, and this is get context ex here. So that looks like ballpark where there could be an issue. So let's get context ex. What if we just return a little success from there? Let's see what happens. Seems to keep trying forever, but it's not crashing. So, well, that's kind of a pain. And this does crash. And I guess it's copying from a non-existent thing. Get segreg descriptor. Let me see if I do seg. If I don't report segments, what happens? Does it actually try and do that? Yep. Okay. Well, that's really annoying. Huh. What do I do here? I don't have symbols. I'm gonna quickly look at the source code for this. I'm gonna see if there's something obvious for why this is happening. And hopefully there's some like quick workaround that I can hack in. So this is going to... It's gonna get the KX state legacy pointer. Let's take a look at the source for this one. Okay. Get current machine is state x context flags. Then we're gonna copy it. So let me see. Px state context is AVX feature enabled. Okay. Let me see. I might be able to spoof that out. I might be able to just say that there's not AVX supported here. I don't know exactly where that information would get reported up. That would be in like a... Oh, it's probably getting from the PCRs. So it's definitely not from here. Yeah, it's gonna get that information from the target itself. So get context ex. Let me see what this takes. I might just be able to implement get context ex, or at least zero it out or something of the sorts. Get context ex. This is going to get target context ex. Let's see where we're crashing again. I just want to see this call stack. So we are in. I just don't know what this wire format looks like. This code is actually exceptionally hard to read. Sanitize that. Blah, blah, blah. Make it canon. So I'm guessing it's gonna... Yeah, it's definitely gonna send get context ex. Then calls get target context ex. And... what does this return? Maybe I can just zero some stuff out. Turn status is success. MS. How does this work? Base address here. Address space. Actual bytes read. Set context. Yep, it's parsing all that stuff. Return status is 0. So when I do this, it just fails, right? If I do this, it like infinitely loops. Maybe it will eventually work. Will it give up? No. Write the updated context. Parse packet state. Time traveled. What is X? Is that just the raw bytes? Well, luckily we're getting crashes in the meantime. 1, 2, 3 non-cannons. Couple read users. Looking good. If we look at our fuzz workers. Oh, it looks like they're all stuck. Interesting. Yeah, it looks like the fuzz workers are getting stuck. I might need to set an iCount timeout. I'll look at that in a second. I'm gonna. Man, I just wish this. I just wish this didn't crash. What a pain. I feel like I had a workaround for this at some point, and I don't remember what it was. Get context ex. Do this. And I'm just gonna print out. Hopefully that underscore I have formatting on. Oh, we have to do this. Oops. Are these the bytes? Ref. We'll see what it's sending us. Byte count 1232. Bytes copied 0. And then down here, how do I respond to one of these things? Read control space. When that happens, I get a ref mute. And then I update these fields. Byte count. Okay. What is this sending to? X dot payload. Is X of a different type here? Let's search for where this code is. Oh. Why does everything always crash? Playing the same song as a League streamer? They're probably listening to the exact same playlist. Read control. Oh, read control space. Okay. Plugins kdnet source kdfifi. We'll just put this over here. Read control space. Okay, and then this is a get context ex structure. Offset byte count bytes copied. I gotta remember how all this code works. I don't think I can just update those in place, can I? Return status is equal to 0. Don't send a response. Set that as failed. Then at the very end, we're gonna serialize the MS structure. Are we matching on MS right here? Manipulate state. Yes. Okay. So it looks like this is requesting 1232 bytes. So maybe I just set it. Let's just see what happens. Where was it at? Get context ex ref mute x. We'll just do x dot bytes copied is equal to x dot byte count. Okay. I mean, it's not working correctly because this context ex is definitely not right, but okay, so the context ex structure. So this is expecting a context ex. What is context ex? I'm gonna look up the source code for this one as well. P context Reinterpret cast as a cross-platform context. Come on, give me the header, give me the header, give me the header. NT-debug. XD6 context. AMD 64 context. What if I just, get context frame, read unaligned. Where is this? Sorry, I'm looking at another monitor to see if I can find the source code for this to figure out what the shape of this context structure is. Get target context is equal to, come on. I want this not in dump, not in target. Here. I need to see what the call frame is again here. Get context 64. Oops. Get context ex. We're gonna not update that, and then we'll set this to like status unsuccessful. Is that what we called it? Yep. So this will cause the crash. I just want to see the call stack here. I think what I might do is I might build a custom version of KD with this bug patched. And then I wouldn't have to worry about it. This might be a little bit easier than trying to figure out what this looks like. So copy xdate to legacy context. That's gonna get the xstate context pointer. It's gonna do a mem copy. Update the legacy portion. Copy xstate to context. I just like don't want this code to execute at all. I just want it to not do this. If it's i386 or if it's AMD 64 and the context ex is not a null pointer. What if I try like a -1 or something here? Maybe I can get it to fail in a different way, and failing in a different way would maybe get me a win here. Well, that's just wrong. What if I set offset? Oh, is it using offset to find the offset in here? If I do bytes copied is equal to x.byte count, x.offset is equal to x.byte count. Maybe this will... What if this like out of bounds copies? Son of a bitch. Because that gets reserialized out, not 0. Code's just non-stop, pretty nutty. Always in the zone. You know, it varies. I go through phases here and there. I've been in a coding mood this week. I don't think this is a fair representation of how I typically work. Wonder how old he is. Yeah, I'm 26. What's the distinction between enlightened and unenlightened? In this so typically, so I don't really know. I didn't write this code. I wrote the initial version of this code, but I don't know what it currently looks like. So enlightened typically refers to us having an understanding of the shape of the operating system structures. And when we have knowledge of kind of how the operating system lays out, that sort of stuff, we call that enlightened. Let me see what happens if I try different return codes here. So that one doesn't work. 2 and then 0. If we just leave these, I'm just trying to find some combination of these flags that gives me a win. So that one doesn't work. The problem is I don't actually have the protocol specification for this. So I don't actually know what it's doing at all. Status unsuccessful. I don't know. I don't know if I'm going to be able to figure this out. I might just have to write a patched version of KD, which I might have sitting around. KD. Nope. Reverse engineering the protocol is part of the fun. Yeah, I mean, that's true. I'm just trying to find in source where this is implemented. So all of this stuff is in C++, and anyone who's ever looked at C++ knows that it's basically worse than machine code, even if you have source, because it's just unreadable. It's just absolutely unreadable. Everything goes into a function pointer and then disappears into a void. Get target context, okay. And then get target context ex. If the current machine is null, if the context is null, if the machine type is one of those, otherwise we go into there. I just don't know I have no idea what format this is expecting over the wire. I have no idea. How do I serialize this? When I serialize this, maybe I need to serialize, I'm gonna try this. For this in 0.bytes copied. For this and that, I'm gonna write an OX41U8. And we're gonna see if we get some 4-1s. Return status 0. So offset is 0. Byte count or bytes copied is equal to the byte count. We're gonna see if this gets us some 4-1s in there. X.bytes copied. Okay, well that we did it. We did it. we got PC. Woo! Okay. So this is obviously some sort of a context structure. Data is after this enum. Set context, get context, struct manipulate API, and see they use this. I'm guessing it's going to be very similar to this structure. And I'm curious if what happens if I just send out that context? Get context ex. Let me see if I have. The problem is I've never actually found in their code base where they implement these sorts of things. Ooh, this looks good. Read memory, set context. Context ex. ulong, okay. Context ex, 3 ulongs, an offset, a byte count, and bytes copied. Okay. And then the full context record follows that. Okay. So, yeah, we're doing some hardcore reversing by just reading the source. So I'm guessing that here I could probably get context ex. So we're gonna have a deserialization thing. So basically, it will always send you a command. So I should have a deserialize. Yep, and then here I'm gonna do context. It's gonna be equal to a none. And what do we do for the context structure? Get context here. And this has a context field. So this is placed after the message. So I'm gonna hope that this, and we're gonna drive default on this. Yeah. I guess we don't need to on this structure. And I put it on the wrong one. So we're gonna do get context ex. When we go to deserialize a get context ex, we're gonna do context default. Okay. And then we're gonna have to kind of figure out what the padding is. We're probably just gonna fuzz our way to the padding. Got some clipboard issues. I'm pasting all over the place. Yeah, these fuzz workers are stuck. Okay, so that has given us the context, which is great. Now, when I go to serialize it, write the updated context to the context frame. What does this do? Writes the current register state and context frame when a break occurs. Acquired from mini dumps. Okay. Oh, that's on a set context. So on get context. Oh, you know what? Get context. When we deserialize a get context, what does that look like? A normal get context. Okay, so just default. So in this case, we're gonna do get context ex. We're just gonna need to copy this. All this serialization crap. In fact, we're gonna have this as like, you know, we're gonna make a copy for now. We're gonna get it to work, and then we're gonna figure it out. So while ret_len is not equal to that, we're gonna pad it out. I don't know if that padding is required in this mode. We're probably gonna see register state like skewed. Okay, so now that's in like a weird spot. Let's see if we have any register state in this case. Oh, you know, we're not filling in the register state in here. So get context. This will read unaligned the context frame. Get context frame here. So here we're gonna do bytes copied. We'll set this equal to 0. See what happens in this case. Get unenlightened context this. Get set context. Why doesn't this just say context? That makes no sense. S context.context context G. Okay. 1360 is gonna take a mutable reference to context. And then 1412, this is also gonna take a mutable reference to context. Okay, we'll see if this fills anything in. Okay, it's not happy about that, so bytes copied will set, I don't know, to the x.bytes requested. Was it? Bytes copied, or byte count. So we'll return this back. Come on. Ah, son of a bitch. We're back to crashing. God damn it. Are we crashing in the same spot? I hate C. Yep, null deref. Okay. Do we just need to write more bytes? While ret.len is not equal to while the ret_len is not equal to x.bytes copied. We need ret.push ox41. Maybe it's not happy with the actual size. Yep, as U32. Oh my god. Like, isn't this what we were doing when we saw the 4 1s? Let's just see what happens. I think this is what gave us the 4 1s, right? Okay. So that gives us 4 1s. What if we just immediately data after this enum? I think we do need to do that. Then we're gonna push the context structure. Send this. This crashes, right? Yep, that crashes. If we set the bytes copied to 0, what happens? It infinitely loops. Okay, cool, great, love to see it. What if we set it equal to 1? Ooh. Okay, so we're gonna set. Is that using uninitialized heap data? If I set bytes copied equal to 1, like, does this change it if I set it equal to 100? Do I get a different register state? Okay, 100 doesn't work. 10. What is this? Yeah, now it's different. Oh my god. Oh my god. Is it not initializing those things? You gotta be kidding me. Let me get rid of this. Bad alignment detected. Okay, okay. I think we do need to do that alignment because the context structure follows. But why would it not be picking it up? Maybe I need to set maybe bytes copied I need to set equal to the size of the context structure. Standard mem size of val of x.context. That's not necessarily the serialized size, but might be ballpark close enough. 1404 is U32. Oh my god, I just want to look at the bugs. Killing me here. Okay. We're gonna get these guys up and running since those, we need to set a timeout in our plugin there. Inject. We can do if we're in fuzz mode. Franzia dot set timeout some, I don't know, 100 million instructions. Actually, we'll do 1 billion instructions. I'll take, that's like 10 seconds. Set fuzz timeout? Or is it just dot timeout? Fuzz timeout, okay. Okay. Bring these servers up again. Come on. Online, online. Text file, text file. Text file busy. Okay. All right, bring these online. Oops. Filled it down like corpus. I'm just gonna take all these offline, reset, set this up, connect in this guy. Good. Connect in this guy. I don't know why this didn't come online. Try them again. Now it worked. Okay. All right. So this says context.exe structure. Full context record follows. Response is a get context message with a full context record following. For get context. And then, so I'm gonna try and find where in code they actually access that context record. It's really frustrating. I didn't want this to be a dev stream. Where do they use this? Oh, of course they don't, because they type def everything 50 times because it's Windows. Like, who actually uses this? There's not a single xref to this structure? I'm calling bullshit. What is this? Eh. Okay, so those workers are up. And then we just don't want to see them stall out this time. Okay, so we're starting to see some hit a timeout. One worker died. Who died? And why? Is there a panic in here somewhere? Unhandled sig sev. Uh-oh. Uh-oh. Not gonna worry about it. Let's sweep that one under the rug. Debug context. I don't know why xrefs do not work at all in this code browser. It's really annoying. How are these crashing? Oh my god. Nothing works today. Oh my god. What on earth is happening? What is going on today? Unhandled sig sev, accessing that. What on earth is happening? What would cause that address to get accessed? Do I have a core dump? U limit C unlimited. Is that when they like hit a timeout and reset? Maybe I have like a weird case in timeouts. Yeah, I can't find where they have this structure at all in the KD code. This is really annoying. I'm just gonna download the whole code base. Where is this used? Here. This. Nope, not there. What? What? Like, I don't know why it has an offset and a byte count and bytes copied. Is the offset into like a certain field in the context? Context. Is it an offset of like one of these fields? Not sure. Wait, are these ones not crashing this time? Oh, none have hit a timeout yet. We'll see if they start crashing when they hit timeouts. Are these ones hitting timeouts? Not yet. This server just looks stuck. Vector register gets set context. The context is placed after the message. Okay, it seems like whenever we hit a timeout, we sig-sav. What's up, random dude, Hex64 or X64? How's it going? I do have core now. Woo! So that should mean I should be able to do gdb tko.exe core. Well, that's not right. Okay, so the core file is corrupt. Oh my god. What is happening? What is happening? I can't even get core dumps to work today. What is this? Are these able to hit timeouts? No. Those haven't hit timeouts yet. How do things fuck up this bad? I have no idea. The KD crashes. Core dumps are broken, so I can't use GDB. Like, I'm dying. All right, I'm gonna build a custom version of KD with that bug patched out. So I'm just gonna patch that bug out and build KD. I might even have that built somewhere. Okay, then what's going on here? Like, can I even look at PC? X10i PC. X10XG RSP. How is an add RSP fail? Oh my god. I don't even know what to trust anymore. Everything's breaking. Ah! It seems like it's an issue on timeouts. Let me see if I can like really crank on that timeout and see if I can get this to crash in a very tight loop. Then I probably can, if I just set timeout to 100, we'll see if this immediately gets those panics. If it does, then we'll be able to at least repro the bug in a fast manner. Because waiting 5 minutes between repros is impossible. Oh, that's the repro. Where's this? Where's the server? Here. Connect, grab that. Oh, I don't even have a dev environment set up on this machine. Oh no. Oh, I do. Okay. Okay. Target name, Katie. Okay. Katie stub. Katie 64. Hopefully I'll be able to go build this. Run as admin. Oh, we got some ECC errors. That's nice. Okay. Did these not connect? Text file busy? TKO is still running? Oh my god. Nothing works. Ah. What is going on? I need to add more RAM to my other machine. Oh. Okay, what have we done today that has worked? So we launched TKO, that crashes. We try to repro a bug, that crashes KD. We try to look at our crash in GDB and the core dump's corrupted. For some reason we can't kill TKO. It gets zombied. It's quite a day today. Calc is on. Yeah, someone really doesn't want me to hack Calc today. We gotta wait for the server to boot. This server has long boot times. Honestly, I bet the server isn't even rebooting. I bet that process is zombied and the kernel's not able to kill it either. I'm probably gonna need to go physically power that on and off. We'll give it a bit. I think it takes like probably like 2 minutes for the server to boot. Sucks. Having a lot of RAM makes everything so slow. You'd think everything is faster with more RAM, but nope. Nope. All right, let's run this locally. Frenzy runners, calc stepped. We'll just run start. Oh, nice, nice. Okay, so it does crash immediately. Hey, we got code execution. Yay. What's interesting is that it crashes in the exact same way. That's kind of cool. There's some issue with the timeout then. The timeout has some bug, so I'll just have to figure that out quick. That'll be easy since we can repro that locally and we can get a debugger on it. Okay, we got that up. And where was I going? I need to CMD. I'm gonna build a KD on the side here that's patched out. Source. Okay. Hopefully everything is gonna work here. Hopefully I'm gonna be able to build a KD. It can be a pain to sometimes get some of this stuff to build. What do you mean machine has less than 16 gigs of RAM? What? What? Oh, is that the dynamic memory crap? Yeah, it is. Well, gotta shut that down. Okay. So let's see where we are in here. So we're about to call RCX plus 8. Seven, 4168. Okay. Source libtk or shared. SP shared libtko source lib. And it's basically an issue with timeout. Set a fuzz timeout. Key new fuzz case on a timeout. Let's just see if we get rid of the actual queuing of a new fuzz case. Let's see if this works. I suspect this will work, because the queuing of a new fuzz case is the only thing that actually would do anything here. Okay, good. So I think like something's not getting reset correctly here. Queue new fuzz case. Reset reason timeout. But why would we only see this on a timeout issue? Recovering case, it's not. That's gonna call keyload keyframe. Just gonna set the requested keyframe. Is it because we do it in these after callbacks? Is that the issue? I'm just gonna comment this out. This should work because it won't actually load the keyframe. Why would I not be able to load a keyframe in an arbitrary state? Let's see if load keyframe prints load kf this path. All right, turn off this dynamic memory stuff. I don't even know why that's default. Load kf none. That's fine. If we go load kf is none. Here we're gonna print if the original keyframe is none, assert that the path is some. Otherwise, set up that. Get access to the memory backing. That should be good. Set the memory backing type. Drop the memory backing. And then load everything from the keyframe. Via mute decommit. So that will decommit all the memory. What if I don't call decommit? This might crash in another way, but I'm curious if this will still crash. Yes. Okay, that's good. Glad to see that. Then deserialize gets called. That we decommit again, so I guess we can go up to here and get rid of that. Here we're gonna decommit memory. Otherwise, clear the diffs. Oh. Is that broken? Clear the diffs. Get state file, which passed in. Instructions executed. I wonder if that timeout case is causing us. No, that should be fine. We'll just return into a different state. Icon breakpoint. Okay, VM's booted now. Set in kernel coverage version. Update that diff. Shared memory. So load keyframe should succeed. Print keyframe is loaded. We should get to there, I think. Okay, we get to keyframe is loaded. And somehow memory is like in a different state? Which makes no sense, at least to me. Oops. Yeah. Gonna do a git pull. Okay. So the issue we're running into is, okay, keyframe is loaded, and If guest is sum, we're gonna sync it. I'm just gonna print this. Self.regs. It's probably sufficient here. Okay, let's take a look. Everything looks good here, so we're gonna do self.unix. Unix state doesn't implement that. .vm. Okay, that doesn't have it, so shared fake VM source. Mageweave and oops. I'm guessing it's probably some issue with our diffs. I did put some debug stuff in here, but I don't think that is an issue. So where is it? Fakevm.regs. .host GPRs, guest GPRs. We're gonna grab the guest GPRs. I'm gonna print those out. Holy shit, I might actually have a built version of KD over here. I think I do. I just tried to pull down the latest source, and it's like, oh, you all have commit stashed. And I looked at the commit, and it's like a null check in KD. So I just gotta find it. Where's that file? Where's the file? Objects. Yep. Star.exe. Uh-oh. There's no star.exe there. Well, I should have a patch for that, so I'm not actually gonna have to even write a patch. Unspecified error. Oh my god. You kidding me? Come on. Copy this to patch. Just a patch. Oh my god. I gotta manually convert all of these path delimiters. Why does Windows have to do stupid pathing? Okay. Get reset hard. My favorite command, get reset hard. The get me the fuck out. Okay, guest dates. All those look good. So these are all the registers that we're gonna execute in the fake VM, and all of them look correct. So that makes me believe that that is fine. The only thing that would make sense then would be paging. We decommit the entire snapshot, so mageweave MMU. So here we're gonna say print paging in this virtual address and not OXFFF. Okay. Kiwi rip. That is getting RCX from this. That is... This is the syscall, the syscall pointer. That's the only place. Yeah, yeah, because we're doing jump not equal. Otherwise, we're gonna load this. So, for some reason, the syscall field is getting not updated. Oh, where do we write that in? Here. Print updating trampoline. And we added another print here. I think for some reason updating trampoline is not getting called in this case. It is. Oh, it's not. Keyframe is loaded. And then we're not updating that trampoline. So I gotta go figure that out. Let me make this patch quick over here. I'm gonna do a copy of /patch. Copy that to there. Git diff. Looks fantastic. CD into here. BP. Oops. Free. Unspecified error. That was unexpected. Oh my god. Building Windows code is so fucking hard. It never works. It is obvious that the whole build system is hacks on hacks on hacks on hacks on hacks. So we got to keyframe is loaded. Updating trampoline. How do we be executing the VM? Print LCF is this. Self.libc in Franzia. Is that not getting serialized out correctly? That would be the only thing that would make sense. Keyframe is loaded. Wait. Oh my god. This can cause a new keyframe to get loaded. So we need to do this. Basically, if this is where the callback occurs, then I think it's possible for things to get like completely busted. So QNew fuzz case. So, oh yeah. Check for a timeout. QNew a fuzz case. That would then cause, we would then return out. Let me see, print fuzz case may be queued. I think we fixed the bug here. Yeah, so LCF is that, blah, blah, blah. So keyframe is loaded when we see that. So fuzz case may be queued. Then we see the keyframe loaded. So basically it's possible to have this QNew fuzz case on a timeout. Okay, and then that wouldn't happen until after callbacks. Yeah, so what do we have? If I undo everything, good. QNew fuzz case, because of a timeout. Here. And then effectively, I just need to call the after callbacks. Make sure the new keyframe gets loaded. This handles deferred deferred keyframe loads, which is now safe to do. But we should be fine now. This should work. So, yeah. Git status. Oops. I need to actually get this merged into master right now. This is actually a pretty breaking bug that people probably complain about within the next 8 hours. So, and the James Bond fix, which is good. Git status, git commit am, or git diff. What did we change here? Calcs here 3, we updated those. That doesn't matter. The KD stuff, we're just gonna do git checkout, git status, git checkout. These, we're gonna revert all of our KD work because it was not good. I will figure that out another day. Git diff. Okay, some changes in calc. We made guest GPRs public, which it shouldn't be, just for debugging. Git diff. We put in the after callbacks and that, and git status, git commit, and fixed timeout crashes. Git push. I'm just gonna make sure I get that merged in quick. I also need to figure out why. Git status, git reset. We're making progress. We're fixing all of these bugs. I'm not too surprised that a bug like this shows up. Pull requests. I'm just gonna do create a pull request. Fixed bug in fixed build bug in James Bond. Fixed timeout crash due to not applying syscall address. Okay. And I think I need to make a work item for this. Oops. Crashes on a call from if a fuzz timeout occurs. Doop. This PR create what's this? Where's the edit? How do I edit my PR? Okay. I need to add a work item. Done. Prove. Complete. Don't delete calc fuzz. Okay. We're shipping it. Okay, now I just need to get the... Now the issue is... I've completely like bricked my Windows build environment, which happens all the time. Seems to happen pretty easily, which is annoying. Unspecified at this time. Okay. Okay. Yes. Yes. Delete all those. We want to keep that patch. Oh. Maybe I have a build. I might I found a KD binary in a random folder. Who knows? Who knows if this is the patched version? Fucking please. 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 Please, please, please. Please, there's just a folder called AMD64 in a documents folder, and it has KD in there. Come on. Oh, I need this. I need this. I need this so bad. Come on. Okay. Given this has private PDBs, I'm gonna hazard to say that this is probably the patched one. I'm gonna delete the PDBs so we don't end up getting those showing up on stream. Okay, star.pdb. Okay, nice. Everything's on the up and up. KD net port 3333. Okay. Where's that repro? Where's the repro? Is this where we did it? Come on, did I patch it? You son of a bitch. Please. Please work. God damn it. Ha! Ha! Ah! Is this not the patched version? No! 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 Oh! Oh my god. Oh, I know I would have had that at some point. I feel like I maybe deleted it. I feel like I almost remember deleting this. No. I definitely don't have it. Ah. Killing me. Deleted calc. KDNet integration tests. Ooh. Ooh. What's this? What's this? What's this? What's this? What's this? I like that. Yeah, what is this? What is this? Is this the one? Is this a working version of KD? Yeah! Woo! Yay! Oh, we don't have to rebuild Katie. Oh my god. And we fixed the other bug, and it wasn't like a... So what was nice about this fix that we just did on this timeout, this after callbacks thing, what I like about this bug fix is that this bug fix is like definitely it. It isn't like we changed a couple things around and then it's like, oh, it works. This made sense. And then the KD one made sense. Okay. Now we get to see how this crashes. For the first time, we get to see what this crash looks like. Did I have features set? I feel like this is not right. Features calc fuzz, calc stepped, KDNet connection, this. Why is that not reproing? Maybe it's just a really long one. James Bond. We've all been there, yeah. Trying to find random binaries on your disk. I mean, it worked. We got it. Okay. How long is this repro? And I'm not seeing calc on here. I wonder if it's like taking a really long time for those messages to get sent to the window. We are seeing like a really big perf issue with this specific snapshot. So we can go and figure that out. Oh my god, I have a fucking timeout of like 1, don't I? Fake VM. We definitely fixed that bug. Plugins, calc fuzz, source, timeout. Yeah. Okay, it's a rough night. I need to refill my glass of wine. Okay, everything's on the up and up. Calc.exe, 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 CPU time. Maybe. Oh, it's because we need to change this. Calc stepped. We're gonna just say if dot unwrap dot contains. If this does not contain calc stepped, because we're using calc stepped copy. Dot unwrap dot contains if this does not contain calc stepped, and then we're gonna do the same thing here. Otherwise, else if this dot unwrap dot contains if this contains calc stepped, then we do these injection stuff. If the keyframe name is if the keyframe name dot unwrap dot contains, if it doesn't contain that and it's not exactly equal to calc, then we exit. First try. Okay, Win32 calc at the top. Nice. Will our repro? After all these variables have changed? We can always restart the fuzzer with some new state as well. But it's a long fuzz case. It's a really long fuzz case. Win32 calc CPU time's kind of dropping. Oh, it went back up. Okay, so calc is still running. Holy shit, what is this fuzz case? Oh, maybe this is just really slow because of the auto keyframing stuff. I don't have an IPS counter. Let me, source lib, sb source, KDNet, oops, sp shared libtko source auto keyframing. I'm just gonna set this to none very temporarily. I will definitely need to remember I did that. I'm guessing it's the auto keyframing is probably like dramatically impacting performance. We'll see how long this one takes to repro. Yeah, I think doing that every million instructions is probably ambitious. Maybe it's just a really long fuzz case. So this is one reason having timeouts on your fuzz cases can be useful, because you can, by having timeouts on your fuzz cases, you can kind of make sure that, and there we go. Oh, wait. Oh, this is the, so we hit a break. Yeah, there we go. It's the CO access. So having timeouts on your fuzz cases, like really tight timeouts, kind of makes sure that, it kind of makes sure that your repros are fast. So I'm actually gonna put this back in, and I wanna see if it's still slower. I think that was just a long, or just a really long keyframe, or a really long repro. Why is deleting files on Windows so slow? I'm deleting a directory right now, and it's taking like a half hour to delete 100,000 files in a folder. Okay. Getting that repro. Yeah, I don't know how much slower it is. I'll have to do some benchmarking on this stuff eventually, but I think the time travel stuff is worth having. Man, these fuzz cases are way too long. There it is. Yep, okay. So everything works fine. Everything's perfect. Get diff, get status. Oops. Okay. Get status. Okay, just those changes in that file, that's good. So now I can do set timeout. We just deleted, or fuzz timeout. We're gonna set it equal to 10 million. That's actually probably ambitious. 100 million. This is like 1 second inside the guess. That's actually probably way too low, but it means that any crashes that we find are going to be like ridiculously fast repro. Dev, TKO fuzz, and we'll delete the coverage, and then we'll go into Franzia runners, delete all of the crashes, and then now we should be able to bring servers online, and this time they won't crash. What is going on here? TKO fuzz, brawler cargo run release, gamey.bfl. Okay, 1 2 3 4. Okay, connected in. Good. That is online. We can now bring these guys online too. Doop. Okay. All 320 workers online. Coverage looking good. We got crashes coming in. Oh, we do have crashes. Okay. So we might be able to do this tight of a timeout. I mean, hey, if that lets us get tighter and like more directed fuzz cases in there, then that's better. Because it means that all of these will repro almost instantaneously. And the more you constrain kind of the timing of your fuzzer, like a faster to repro bug typically is easier to repro because it's less complex state-wise. This timeout might be too aggressively short, but we'll keep our eyes on it. This was our repro one, yeah. So, yeah, I do think this is going to be too short of a timeout. You can see that we're killing almost all of our fuzz cases due to timeouts. Getting about 5 fuzz cases per second. clean. So yeah, I think if we up that a bit, if we up it to 1 billion, that'll hopefully get us like a wider range. We could also look at directly harnessing calc, where we wouldn't actually be sending messages to another window. We could maybe just like literally hack in the send message loop in calc to like really get our iter counts up. Okay, so I think this timeout is just too short because by now we normally have more crashes. It could just be a complete coincidence that we haven't seen them yet, but I think it's more likely that we're not allowing it to get into a state where it can kind of have those things come up. So I'm gonna move the server windows, the 2 server windows over to a different monitor because we don't really have to visibly see those. We'll have the status here. And then I'm just gonna update the fuzz timeout. We're gonna put this to 1 billion, which is now like 10 seconds of guessed execution time. That should be more than enough to exercise, I think, every state that we're gonna end up seeing in calc. So we're gonna bring some workers online. Got 64 online, and we'll bring an extra 256 online. Here comes the 256. Oops. It's not a big deal. It seems like sometimes they fail panicked. I don't know why, like, sometimes it fails when I bring on all 256, but it's not that big of a deal. So we've got all of those online now. And now we should hopefully start seeing more exotic crashes in here. I think we should be able to see everything in 10 seconds of CPU time, or in 10 seconds of wall clock time. We should be able to exercise, I think, everything. I mean, I guess we have that like 60-second timeout in the guess. It's really hard to like make decisions on these sorts of things. So the 256, those are online and spitting out cases already. In fact, the numbers that I care about are like these statistics down here. This is saying that most are ending due to hitting an end condition. Oh, actually, most of them are exiting due to a crash. But basically, when I see that none of them are ending due to a timeout, that means we're not interjecting into the fuzzing process. Basically, we want the timeouts to be rare. We want the timeouts to be a last catch of like prevent some VMs that like went off some really stray path. So we want this timeout number to basically always be 0, but we want the timeout to be as low as possible while that maintains 0. That means like once every maybe hour, we'll have one that like really corrupts the machine, ends up in a state where it actually wants to time out, and the timeout is there to just kind of keep an eye on things and make sure that things don't go too crazy. So here we're seeing a couple more crashes coming in. Everything looks good. Yeah, we just hit a timeout. Actually, we're hitting a couple timeouts. We're probably going to see a lot of timeouts happen here, actually. Yeah. So given all of the timeouts are coming in kind of at the same time, that likely means that 34 VMs kind of got stuck, and those timeouts killed them. I don't know, maybe 1 billion is too high. I think if we take a look at the performance, we're getting like 1 fuzz case a second. I think for some reason exited with that. Process exited with that. Let's see if we changed our agent at all, which I think we might have. Dev TKO fuzz. Twitch fuzz calc. So this is the binary that we're using, or this one. Inject ID sequence. And let's see if we made any changes here. Send out commands. This is the clipboard grooming stuff, which we don't use anymore. We don't generate any of these clipboard events. So we get all the commands. We set up a thread that sleeps attached to that window, and then this is where we rekeyframe. Honestly, I could maybe get rid of some of these prints. These prints are potentially causing some slowdowns, but let's check in on our crashes. And in fact, I think I'm going to actually want to put the faulting address in crash file names. I'm going to want to set that option because that will give us a lot higher of a glance value. And when we have page heap enabled, the amount of different addresses that we're going to see are going to be a lot lower, so we won't end up getting kind of that spew that we were getting before. So this is in Franzia runners. I'm going to get rid of this. So Franzia runners crashes. Here we have all our crashes. Okay, these look good. I'm going to kill these workers quick. I'm going to drop that timeout down again. I think we can actually get away with that tighter timeout. We're going to put this back to 100 mil on fuzz timeouts. And then I also want a VM exit. There's one thing that I noticed. Shared libtko source. I noticed that there was kind of an issue here with the way in the plugin stuff. Shared or plugins. Crash handler. So when we have the crash on CR3, because we added the reset Q new fuzz case CR3 crash, are we just not seeing those? Yeah, like in this list, why are those not showing up? Why are those not showing up in this list? E plugins or E source lib power off reset reasons. Oh, okay. CR3 crash. Let's check out reset reason. This is in here. Timeout, end condition, triple fault, reboot, OS panic, CR3 crash, and power off. Okay, that should fix that. That was just a visual bug. That wasn't actually a record-keeping issue, which is good to see. Set the fuzz timeout a little bit stricter. And then, faulting address and file name. We're going to set this to true. This will enable that the faulting address shows up in the crash file names so that these crash files will become a little bit more verbose and we'll just get that information that we want. So we can spin these servers up again and we'll get everything online. And I'm going to delete the coverage stuff so they start fresh. I always like purging my coverage database. I actually usually don't use persistent coverage. I really like when we lost a couple of those servers. We're going to get some spew. It's fine. Okay, connected in. Looks good. Okay. Yeah. And now we're just waiting for some crashes. So, yep. So now we have this printing the stats of kind of those different fields. CR3 crash. We'll probably see a couple going into that bucket. So, yep, CR3 crash. Good. So that's nice. Font driver host. The CPU usage actually looks really good. It looks like we're hitting calc pretty hard. All I want to make sure is that the non-canonical, I want to see the non-canonical accesses show up in here with the 100 mil timeout, which I think they will. We're hitting a lot of timeout cases, but that's fine. I think a lot of situations calc is freezing up on us, and the timeouts are kind of the only way that we're actually going to reset the VM in a timely manner. So I think 100 mil is fine. It is only like 1 wall clock second. I don't know. We'll see. If the nested crashes show up, then we're fine. If they don't, then we'll end up figuring that out. But we're hitting our timeouts, we're hitting our CR3 crashes, we're hitting end conditions, which is the application exiting, which means it sends all of the commands to the calculator window, and calculator processed all of them. So everything looks good. We could also look at doing a binary patch on calculator to remove some of those animations, which would be really interesting. These streams have inspired me to use Rust again. That's good. That's healthy. I love hearing that. Okay, so we have a moving window of 60 seconds on this. So these fuzz cases, so this is the number of instructions per second that we're running. Which actually, remember that the Xeon Phi's cores are really, 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 really weak. So what we can say is we're running 490 million instructions per second divided by 320 workers, 1.53 million per core. God, that's so bad. I think on the... They're probably running at about 5 mil per second per core on the Xeon Phi, and then on the AMD machine, the Archive machine, they're probably running at like 10 mil instructions per second. On my host computer, they would run at about 100 mil instructions per second. It's just that AMD machine is really slow, and the Intel machine is not designed for this sort of work. But hey, fuzz cases are fuzz cases. And that's why we have a timeout here in number of instructions executed and not in host time, because host time means that the reproducibility could vary from computer to computer depending on the emulation speed. So that's kind of something we have to do. So I'm not seeing those crashes. I think there's a chance that we do need to bump that up to a bill. That means we'll be running like 0.5 fuzz cases per second. I don't know if the rendering is slower. Like when I'm looking at the stats here, it's showing that we're healthily spending most of our time in calc, which is good. If we're spending our time in calc, then we're fuzzing. Okay. So I'm gonna take a quick bio break. I'm gonna refill my wine, and I will be back in like 5 minutes. And we're gonna go and we're gonna improve our fuzzer, and we're gonna add a couple things to our fuzzer, a couple like sleeps and chance of exiting the application. So I will be right back. See you guys soon. 24/7 lo-fi hip-hop beats to chill and write memory-safe programs to. Love it. Love it. I'm going to quickly fix the text box on here. For some reason, the chat box is kind of broken for this, so I'm going to throw up the chat box. We have that always show messages. Yeah. Okay. Oh, I need to change the... I guess I need to edit the size directly. Yeah, we got this figured out before, and then we ended up running into the issue where we had like a... one second. I'm trying to figure out the size of this. 900 pixels? 950? 1000? Looks good. Okay, and I think that should be lined up. Test. Why did you choose the just chatting? Do you get more viewers from this? Honestly, yeah, pretty much. So just chatting is just a little bit more active place. Like there's the science and technology section, but no one really uses that. So it's kind of empty. It's not a category that someone would scroll through and browse. Like someone could scroll through just chatting, and yeah, I'm gonna be really far down in the list, but someone might see this stream and be interested. Yeah, there used to be a programming section, which I would use, but just chatting, I don't know, like there are a bunch of other programmers who use just chatting. It seems to just be where people kind of do stuff where they're just kind of talking and doing work. Science and technology is just, I view it as more for like broadcasts and like documentaries and stuff. But I don't really care. Like, I don't really care about the category. It is an active decision of mine, mainly just because I think it's just chatting is a more lively section. Like, if we were to hit 100 viewers, we would be like not super far down in just chatting, and then we'd probably find people. Like, people would probably find this stream just through that, which would be really cool. Because I'm guessing that everyone that finds this stream right now is probably directly through Twitter or a reference. So, so we're gonna up this timeout. We're gonna set this to a bill, which is good. And we're gonna kill all of the workers. We'll get the server up and running once all the workers have decided to finally exit. Okay, looks good. Okay, and we're spinning those up. And you should have the other workers coming online shortly. Looks like everyone is checked in. Everyone is happy. So we've got these all up and fuzzing in that new mode. And we can keep this over here. So now we'll see all the other crashes. Yeah, there was the live overflow posted a thing on livestream fail. But yeah. That's actually really cool. I'm glad that you found this stream through like a channel like that, a different way of finding it, like a more organic way of finding it. I think that's really cool. I've been streaming at like really weird times. I think right now it's like really the only people who could watch are probably in Europe. Everyone in the US is asleep. It is 6 a.m. on the East Coast and it's 3 a.m. on the West Coast. But I bet I bet at like 6 o'clock there'll be like a jump in people. I don't know how common Twitch is in Europe. Is Twitch a big thing in Europe? At least in the US, Twitch is like the only way that you watch streamers. It's huge. Okay, Russia here. That's awesome. Got everyone from all over the place. That's really cool. Lines up perfectly with my work schedule at EU. Yeah, I'm definitely an EU-friendly streamer. Okay, so... Hello, my name's Gamoza, and today we're going to actually start doing calc.exe fuzzing again. So let's take a look at what we're currently doing. Oh fuck! And my font's bad. I'm so sorry, guys. To me this font, the H10, like this font, or actually I don't know if this is what we had, but to me this font is big. So I view this as like, oh my god, like, holy shit, this font is huge. So I think like this is great for streaming. So the one I usually use is like this, which allows me to go 4 wide on a standard 1080p monitor with 80 columns. So I usually will do like a 4:3 layout, which allows me to have 12 files open, which is really nice. So yeah, I will often forget. You know what? This computer is pretty much only used for making WoW add-ons, playing games, and streaming. So I can go and I can just set my vimrc. CD program files, vimrc. We'll set GFN is terminal H16. Does anyone have a font they really like? Is there a font people would like to see? Another good font is Lucida Console. I think you set an underscore in Vim. Yeah. So like this one's really nice. Really smooth. This is a true type font, whereas terminal is a bitmap font. So bitmap has sharp edges. It's pixel based, whereas this has like the nice anti-aliasing. Do you prefer this? It's a terrible way to manage a vimrc. What do you mean? It's fine. Works great. What do you guys prefer? This font? use the home. Yeah, I don't do that on Windows. This font actually looks really clean. This font looks gorgeous. To be honest, like this almost makes the monitor look like a higher resolution screen than what it is. We're gonna try this. It's an even bigger font, which is fine. Okay. Anti-alias is Pog. Yeah, the TTF is super. I'm actually really surprised because I'm used to using bitmap fonts in Vim because of issues with rendering, but this looks just fantastic. Like, this looks so nice. I do wish it does seem like it seems like the letters are like really short but pretty wide, which is kind of weird, but not a big deal. Yeah, it looks clean. So there was a time when GVim had broken rendering on Windows 10 because of reasons. Yeah, I remember like scrolling around, you'd get like artifacts, and I might end up seeing that, and if I see artifacts, I'll probably switch back to the other font, but this looks really nice. And I'm guessing this is now like phone friendly because this is a huge font. Like, I cannot fit much on the screen with this font. Okay, so now we can take a look at our fuzzer. So basically, if you haven't been to the stream before, effectively right now what we're doing is we're fuzzing calculator. We're trying to find bugs in the calculator application. And when I say calculator, I mean the old school calculator that shipped with Windows 7. This one that we know and love. So what we're doing is we're currently sending random commands to it to interact with certain GUI elements, but we're not yet interacting with typing in things for text. We're not closing it. We need an ability to close it. Why? Why are we doing this? For fun. So ultimately we're doing this because we want to find bugs. We want to find crashes. So when you run an application and you get the dialogue that pops up like this program has unexpectedly exited and you see like some crash gibberish on the screen, that's exactly what we're searching for. Our goal is to find bugs. And the goal of those bugs is to potentially find a bug that is controllable in a way that we can get code execution in calc, so we could take control of the calculator application. So we're basically, think of it like playing a game, like the games that have like exploits in them. Our goal is to like do something really fast with calculator that causes us to get full control over the calculator application, or more specifically, anything that your user account is doing, which is where it can get scary. But in this case, it's not actually a security risk because the calculator app doesn't give you any permissions. The only thing that might be risky about this is that technically it would allow you to execute code in the context of an application which has been signed by Microsoft, but that, like, you can do that with DLL injection on like a billion different processes, so it's just not a big deal. So the little fuzzer that we have, we've set up like a bunch of Windows VMs. So we have 320 Windows VMs running right now that are opening calculator, randomly interacting with them, and then closing calculator. Or in this case, they're actually not closing calculator, they're usually just crashing it. So the application that we wrote to do this is in this folder, inject ID sequence. And this program basically goes through and it spins up a thread. This will cause it to exit itself after a certain amount of time. Here we allocate room for some commands that are going to come in from outside. We attach to the calculator window. We make sure that the commands field actually gets populated. This is just to make sure that all of the pages are paged in for this 1 meg of memory, or this is actually 4 megs of memory. Then we call into the basically the hypervisor, the emulator, to tell it, hey, we're ready to fuzz. And then it's going to fill in this command buffer, which we're going to get the number of commands from, and we're going to start using those commands to do things. So right now, when we get a command, we just send a command to that window. So if we take a look at kind of what this is capable of doing, we can look at another application, which is a local one, and I'm going to see if I can do GFN 14, 12, 14 is acceptable. The 16 is a little bit extreme. And let me go edit my global vimrc. Set this to 14, much better. Okay. I just often do multi-user things on Windows, so having a vimrc that's global is actually really useful, because I'll end up creating a lot of accounts for like different games or different applications or like different testing of things, so I just throw them in the global one. No one else uses this computer, so it doesn't hurt anyone. On Linux, I use the home path, but it's just so convenient on Windows, and I always forget where it's put on Windows. It's like in users, your pleb, and then like .vim. the VM is completely deterministic? Yes, it is. So the VM will always reproduce everything exactly every time to the cycle or instruction level. Are there some special sauce tools to do this? Yes. I'm using a tool called TKO Fuzz, which is a full system fuzzer kind of built on top of the Box emulator project, which is similar to QEMU. And basically, I wrote an emulator for Unix, basically that emulates a Unix environment like all of the standard Unix syscalls, and then in that, we run Box, and even on Windows. So like right now when we're fuzzing on Windows, I actually am running Box inside of a Unix emulator. So Box thinks it's on Unix, and it's performing syscalls, and the syscalls are going to me instead of the kernel. So I'm making sure that Box never actually gets access to the kernel, and thus I control all of the outside entropy that Box gets, and thus if I can emulate Unix deterministically, for example, making sure time steps in certain ways and all those things, that makes Box deterministic, not at a CPU level because things get scheduled around, but at an execution and register state level, everything's deterministic. And then that means that the guest inherits the determinism from the Box process itself, and thus the guest itself is deterministic. It was a really creative way to make Box deterministic. Box is actually pretty close to deterministic by itself, but there are a couple issues that it had, and we wrote some tests that determined that basically the costs of fixing all of the non-determinism issues in Box and the discomfort in knowing that there could be more was not worth it compared to just writing this Unix emulator that took, I think, like a day. It was like an 8 or 9 hour project to get Box up and running in this fake environment. So, and it was a lot more fun. To be honest, it was a lot more fun. Otherwise, I would have just been like learning how Box works and fixing bugs, which, come on, that's not fun. Okay, so this is the fuzzer that we have inside of the guest, and we can go peek at the live version of the fuzzer. Dev Twitch fuzz calc. Oops, cd Twitch fuzz calc inject ID live repro, and then this is the one that we run locally. And what I'm gonna do is I'm gonna get rid of the window paste stuff, going to send commands, gonna get rid of everything here, and this is going to allow us to reproduce bugs that we got from, we're gonna get rid of this too. So this is going to allow us to reproduce kind of the issues that we get outside of the emulator. So in this case, we're going to take a single argument, which is the repro command, which is the file that contains all of the commands to send to Box. We're going to read that file. We're going to basically parse it into a vector of 32-bit integers. We're going to delete the registry keys associated with calc. That will cause basically calculator to always start in the same state, that like clean, fresh started state. We're going to spawn calculator, attach to it, or wait until the calculator window shows up. Once it has shown up, we're going to send all the commands to it in order. So what we can do is we can take a crash from our crashes folder and try and repro it live. Now, everything inside of the VMs can deterministically reproduce. So we have a way to reproduce all of those issues if we want to. However, reproducing them live has the added benefit of seeing the different ways that they can potentially crash, or just viewing them from a slightly different perspective. So if we look at Frenzy Runners crashes, here are all the crashes that we have in calc. So we have a couple non-canonical reads. We have 2 non-canonical reads. Both of these are uninitialized memory reads. I know that because the C0, C0, C0 pattern is what page heap fills into the heap when an allocation was performed and nothing has been loaded into it yet. So I know that both of these bugs are accessing memory or accessing a pointer that's uninitialized. And that means that if we were to find an object that would fit inside in the size of the pool that this allocation was performed in, we could actually get control of this pointer, and that would allow us to cause calculator to read memory that we told it to, rather than that it intended to access. So all of these crashes are the same. They're just slightly different addresses that they can access. Same with these ones. These are all the same. We have a null deref. We have 2 crashes that kind of don't make any sense. Another null deref here. Another one that doesn't make sense. You know what? That's actually, this might be a stack one. No, we added stack enlightenment. So if these were close to stack, they would say under stack. And we haven't seen any of the stack overrun bugs yet. So let's see if we can get this one to reproduce live. So we'll do a cargo run to spin up our live debugger. This will do dev franzia runners. Oops, decon/dev franzia runners. Calc stepped crashes. Probably should have typed it out. And this. So we can see if this wants to reproduce. And this one crashed with a null deref. So what we want to do is we want to make sure that page heap is enabled. G flags I 132 calc.exe. It is enabled, which means that this does potentially crash in different ways based on timing. And this is something that I was kind of concerned with. We're not able to get the same crash, so we can't see necessarily what state this runs in. But what we can do is we can load up the crash instead in this repro, which is going to use the exact same box environment that our fuzzers are running in. And I need to just here we'll set this as calc stepped crashes, and we just need a KD session open, which we have here. So KD is just a debugger for Windows. We're gonna set up this KD session. We're all good. We're gonna connect in, and we're gonna see what happens. So this will break in initially. We're gonna tell it to continue execution. And now we're just waiting a bit. And I don't know if bang heap works from a kernel debugger perspective, which might make it a little harder to see kind of the state of things. Okay, so if I reload symbols, we'll now see where we are. We're in this calculator switch history. We are accessing a C0, C0, C0. If we take a look at what we're about to do, we're about to pass that in and look up a dialog item based on this. And if we take a look at get dialog item, we can see what this is passing in. And this will allow us to kind of see what we're getting control of. In this case, it's going to deref RDX plus 8, which is going to give it, this is a handle to a dialog item. So basically it's trying to get a dialog item, but instead it's accessing some uninitialized memory that hasn't been set up. So I can try and see if we can see where that allocation was performed. Bang heap performs differently in a kernel debugger. I don't know if this is going to work in a convenient way. Hopefully it does. It's spinning. It's thinking. It's trying its best. Come on. It's possible that maybe there's something that we don't implement in KD that's causing it to get stuck here in a loop, but if I remember correctly, this is something that happens pretty commonly. Yeah. Read memory error on that. I'm guessing that this stuff might be paged out. Yeah. So this is not able to actually walk the heap on this address because it's paged out. Some of the metadata, some of the heap metadata is paged out. That kind of sucks. But it's not that big of a deal. So effectively, we know that this function, it's possible in this situation to try and access something out of this RDX structure that is uninitialized. So what we can do is, I'm going to shut down this VM. What we can do is we can pop open IDA. So we're going to boot up our IDA VM here. And when we have IDA open, we can take a look at this function, so we can see where it's crashing. And mainly what I want to do is, I think I moved the hard drive location. IDA. Oh, this. So IDA is going to show us kind of like what this code looks like, and we're going to try to figure out roughly what's going on. So we have Win32 calc. Do we have the PDB for it? Yep, we do. So we're going to open Win32 calc.exe. Let's restore the packed base. You know, this doesn't look like it has symbols. Oh, it does. Okay. So what I can do is I can look at this address, and IDA's probably not going to have the same formatting, which makes this kind of annoying. And I actually don't know a good way of copying and pasting things. What I typically do is I do RIP minus Win32 calc, actually a DB, to grab this address. And then I just kind of manually jump to it. So I'll grab that. Oops. OX this. For some reason that failed. Oh, it's this one's loaded at 1.4. So OX 1.4, 1.2.3.4, 1.2.3. So this will show us where we are, and that looks good. So this is showing us that at this point, RDX can be completely uninitialized. So that means this RAX plus 18 field is uninitialized, and we can double check RAX. So we can see at RAX plus 18 hex, we'll see that this field is uninitialized. There are also some fields around it that are uninitialized. So this is at 18, then again at 28, it's uninitialized. So what I want to do is I want to look around things that are dereferring RAX. So I'm going to kind of zoom out to see approximately who's using RAX. These ones are clobbering it. So RAX kind of is last used. It gets moved into R15. So it's preserved in R15, which it passed, it's passed to a send message. Is it? Oh, it's, this is the return value. My bad. So RAX is not used after this point in the scope. We know that RDX is completely clobbered at this point, but it's only being used as a handle to a dialog item. So that isn't the most interesting crash to me. Because I don't think that's particularly useful. If we get arbitrary access to a handle to a function, I don't think there's really much that we can do with that. That would maybe cause us to get a different dialog item, and then we would show window on an item that we're not supposed to. So there are potential, like, really weird interactions that could occur there. So what I can do is I can grab, first let's refresh our calc, our crashes folder. So what's interesting is that whenever I see a crash that has had a different address, or like addresses like this always makes me wonder how could this possibly happen? How could you access memory in these locations? Like, why is this one zeroed out? And it looks like kind of uninitialized memory that's being used, but if it were uninitialized memory, then we would see the C0, C0, C0 pattern. So what's likely is that these maybe are a type confusion. In fact, I don't know if we've ever seen this bug before at 4232. So we have two of these non-canon accesses, which are super high priority. Basically, anything that is in full capital letters in these crashes, in the file names of these crashes, is usually something of importance. So for example, the ones that have user in caps means that it's actually trying to dereference an address that looks valid. It looks like something that is a reasonable address. In the case of one of these where it's dereffing OX28, this is like basically a null deref. It's expecting something to be present, but instead it's zeroed out, which is a common primitive in C and C++. So in those cases, we just basically don't really care about these. It's very unlikely that we could get any execution control through a null deref. It is possible kind of on older systems, but that's not really a thing anymore, with some exceptions. So we have kind of these different non-canon accesses. I want to take a look at this offset for the other one. So we're currently looking at add 8, and I want to look at this one. It looks like this is in a very similar place. It's actually dereffing a rax plus 18 to get this pointer. This makes me believe that it's exactly the same bug. It's the same field in the same structure that's probably having an issue. And in this case, it's update history results. And yeah. So why would it be accessing an uninitialized field? That's where it gets kind of tricky in trying to figure out whether or not that's a big issue or not. So what we want to do is we want to slightly modify our fuzzer. So these results look really good. I'm going to dive into these results pretty soon. But before I spend an hour trying to root cause and figure out what causes some of these bugs, I would prefer to make sure that we have a fuzzer up and running that we're happy with. I could spend probably 30 minutes and we could dramatically improve our fuzzer to cause us to potentially find more interesting bugs than the ones we have. And then while the fuzzer runs in the background, we could start analyzing what we get. So basically right now, the only ones that look interesting to me are this one, because I've never seen it before, and then the two non-canon accesses, which don't necessarily look controllable, but I'm pretty sure that the ramifications... So bugs in software are kind of like a paint chip. Of like, once you get the first paint chip, the first fleck of paint off of whatever surface, let's say it's a car, once that first chip comes off, the rest of the paint starts chipping away really fast because it has kind of that catalyst, that initial point. And that's very much so how software behaves. Once you find an initial bug, it's very easy to then find bugs around there and then use that bug to kind of invalidate assumptions in other parts of the code, which causes new bugs to get unlocked and new bugs to get unlocked and so on and so forth. So you get this kind of effect where just getting your foot in the door on bugs causes you to find so much. And it's actually really common for me to patch bugs as I find them. So I'll make binary patches for things as I find them. One, that confirms that you've root caused them correctly. If you're able to patch a bug in a binary, you likely have a really good understanding of what that bug is. Maybe not the ramifications of that bug, but you at least understand what that bug is, and that's really cool. So, okay, we're gonna hop over. We're gonna take a look at our fuzzer. In this case, the inject ID sequence thing. So we had some like clipboard stuff in here. We're actually not going to use the clipboard anymore. I don't really like that. That was allocating in the global heap, but we need our grooms in the local heap. So what we want to do is we want to add support for sleeps. We want an ability for for our fuzzer to cool off, to take a break, to not do anything for a while, and that will allow potential like rendering updates in the calculator application to occur. So right now we're not really allowing calculator to render, which means that we're probably sending commands super fast, which is causing it to get stuck and spin in states that we don't necessarily care about. So What I think I'm going to do here is I'm going to overload some of these commands so we can either implement like a serialize and deserialize to actually send a stream of commands into this application, or we can just kind of hack it in. It's a fuzzer. It doesn't matter too much. So what I'm going to do is I'm going to say if the command, which is just the 32-bit integer, is 5555. So if a command comes in and the top 4 nibbles, the top 16 bits of that command are equal to 5555, then what we're going to want to do is we're going to want to sleep for the time specified in the bottom 16 bits. So sleep time in millis, this is going to be equal to the command and oxfffff. I know I can cast that to U16, I'm just doing this. And then I'm going to do a standard process sleep for standard time duration. I'm just not worrying about namespace stuff because this is throwaway code. From millis, sleep time in millis. So this means that we can now have our fuzzer, our mutator, and generator randomly generate these commands that match this command type, which would then cause us to sleep for a little bit of time in our application instead of sending a command to the window. So let's take a look at how that behaves. Let's make sure this can build. Oops. We're gonna go back, inject ID sequence, cargo run. Okay, this needs to be a U64, so we'll cast this up. And sleep's not found. Thread sleep. Okay, so now we have a way of sleeping. In the situation that a command comes in like this, we'll sleep for the bottom 16 bits. That allows us to sleep for up to 65 seconds. That's more than we'll ever use, so we're fine. Now, the next thing we want to add is keyboard inputs. And to demonstrate why we need keyboard inputs, I'm going to go back over to the live repro. And what we're going to do is instead of actually reproing in the live repro, which I have open already, so instead of sending the stream of commands, I'm going to send just kind of random commands here. So we'll do primary window.command rng.rand mod 128. Actually, 256 is probably better in this case. Let mute RNG is RNG new. So this will create a new random number generator. And we'll just need to give a random file name. It has to be a file name that actually exists and will parse correctly. I could just comment all this stuff out. We're going to comment out all of this. And instead, this application is now just going to, we need the RNG though. Okay, so what we're gonna do is we're gonna send random commands to this window, and then this will just be a loop. We'll loop forever. And blah, 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 this, and RNG. Okay, we're really struggling here. It's fighting us. Okay, so this is waiting for calculator to show up. Once calculator shows up, it's gonna send random key presses to it, or random interactions to it. We see that it just crashes immediately. Nothing too surprising there. So we're gonna put a standard time sleep, standard thread sleep, standard time duration from millis. We'll put a 250 millisecond sleep in here, and this will hopefully, we'll put another sleep after we found the calculator window of 1 second. So this will hopefully give us a view of like what's happening. So here it typed a 4, it hit pi, it hit a memory button, and it's kind of just doing random interactions with it. So in our fuzzer, it's doing these as fast as possible. So having these sleeps in here is kind of useful. So this should also be able to switch modes. And a mode switch would basically cause it to go into like one of the programmer modes or the statistics mode, which opens up new attack surface for bugs. So looks like that ended up getting stuck, ended up crashing on process keypad inputs. Okay, see what happens here. And I'm just trying to see roughly the limitations of this. So assuming we're sending random commands to this, how often does it not, oh, I need to open calc manually. So I want to see, like, are there any interactions that it's not doing that probably would be really useful? And the biggest thing is going to be key presses. For key presses to work, we have to find all of the dialogues that we can potentially send key presses to. So we're going to want a random chance of enumerating all of the windows. So if I did this, I'll be able to see primary window dot enum child windows. And I don't think that's what I called it. Enumerate sub windows. So this will give me a list of all of the buttons and things that are on the calculator application. And basically from these, I can find the identifiers, which tells me how to interact with those things, so I don't end up interacting with things that aren't on the screen. But the problem is, when I need to get this window listing, I need to wait for the window to actually finish rendering. So I think what I'm going to do is I'm going to have a random chance of sleeping for, let's say, 1 second, which sounds like a long time, but since we're in an emulator, that 1 second can actually go by really fast. So we don't actually have to really worry about sleeping for a long time anymore. So I think what we're going to do is we're going to have a random chance of sleeping for about a second, enumerating the windows, so hopefully everything's rendered after that second has elapsed. And then we're going to try to send key presses to some random elements inside of those windows. So to do this is kind of difficult because enumerate some windows will return different things in different states, and that means that it's hard to give a programmatic stream of operations to perform if the window is changing. If this comes back and says, oh, there are 15 windows, how do I know that from my generator perspective to tell it to do those things? So I think the best thing to do will be to do modulo arithmetic. So basically, I will generate a random number for something to interact with and a key press, and it will perform that mod the length of this list. Hi, can you hack MapleStory? Yes. Yes, I can. I have many bugs in MapleStory implementations and servers, and many cheats. I actually have probably some of the best cheats from MapleStory in the world. But I'm not going to do that on stream because I get banned for it. Where can I learn about it? Can you send me those? Nope, I'm not going to share them. I don't think cheating is friendly to communities of games, and I think it really hurts communities. It's like, to me, cheating is something that I do as more of a programming project, and when I cheat, I make sure that I have things that cause the cheat to exit the second someone shows up on screen. I don't want to give myself an edge. I don't want others to get an edge. The goal is more of the programming and reversing challenge. I'm sorry, there are so many different ways to learn that don't involve having world-class MapleStory cheats. So I would recommend going down those different paths. I'm not going to release my MapleStory cheats. They're basically perfect. They're actually just perfect. So because the cheats that I have are custom clients that communicate with the server, so there's no anti-cheat locally because there's literally not a MapleStory client. And I had them like automatically log on. They would jump around. I would have all of them running. They would all like go to different screens, farm stuff, bring them back to a central location, drop them off so I could mule them. I actually had some pretty sophisticated things. Those MapleStory cheats were quite Probably the best cheats I've ever written for a game. They also were not cheap to write. I probably spent like 500 hours working on them. Okay, so all right, here we go. So you got that working. That will eventually exit out. Oops. I think I just minimized that. Okay, good. Okay, so I'm gonna have a random chance of sleeping, enumerating the sub-windows. Sub-windows is equal to this. And then I want to send a key press to one of those windows. So I'll do let selection is equal to sub-windows rt.rand mod sub-windows.len. Print cell. Okay, so this is just gonna print a random element. What do you mean you can't? Oh, we'll just unwrap here. This should be fine. We'll open up calculator. This will just print a random thing on the window. If I close this, yep, that eventually fails. So that's not a big deal. Not a problem. Okay. Okay. So we have a random thing, and we want to send a key press to it, and I think we have the code to that in win bindings. Let's check in on our fuzzers. Looking good. Running about 0.8 fuzz cases per second. We've run about 2,000 fuzz cases. Looks nice. J People, thank you for following. Welcome to the party. There's also a soix underscore who followed, and a Molly68 who followed. So thank you all for following. Welcome to the stream. Hope you're having fun. Hope you're having a good evening, day, midday, lunch. Okay. So we're printing those random things, and then let's see what we have. I think we have a key press, a key, right? We did write this code, press key, and that's gonna be on a window. So we'll do cell.press key. Yeah, I don't know if you can see these like blue rendering artifacts, but there is still like a Vim bug with these fonts. It's pretty subtle, so it's not a big issue, so I'm not losing sleep over it. rt.rand mod a key, we'll just say mod 256. So send a random key to that window. And I don't think this will cause interaction issues with okay, so that typed a 908. Sometimes it gets hung up. Well, that's strange. What causes that? What causes that? So we know that the AO one hangs, and that basically means that the message is, well, that kind of sucks. I think that's fine. It looks like the frequency that it gets hung up on things are pretty low. So now what I want to do is I want to open up unit conversion, and I want to see if it's interacting with some of these fields. And it looks like it is. I want to see it type something in one of these enter value fields. Come on. It's selecting things from those lists, which is good. That looks fantastic. Representations, thank you for following. And Renny W, Ren IIW, thank you so much for following. Slightly off topic. How are you making disk reads and writes deterministic? So basically the disk is a differencing disk. So whenever I go to reset the VM, I actually end up resetting the state of the disk back to the original state that I had. And that's it. Basically, all of the writes that happen. So in my like Unix emulator, I actually don't have any way of writing to physical disk. All the writes actually go to like a memory back differencing location. Maya Cat, thank you for following. So I did post a couple of videos of my MapleStory cheats, but from the videos you wouldn't really be able to learn too much about what I did. So one thing that's kind of throwing me off here is it seems like I'm interacting with almost every single button, but for some reason I'm never typing into the from field or the to field. And I'm not quite sure how that's possible. So let's take a look at, let's bring up spy. Okay, and we have these things, blah, blah, blah. So, and we're gonna spy on this. And we'll see that this is an E2 control. And all I wanna see is whether or not we're sending commands to the E2 control, and we are. So we are trying to send key presses to the E2 field. And for some reason that's not causing a key press. So what I'm gonna do is I'm gonna make this mod 10 plus OX30, and that's basically going to convert this to a this is going to make this a random number from 0 to 9. Weird, we're not seeing those. Now we're not seeing any interactions with that window. Let's see. Oh, you can actually type in those windows by using the buttons? Huh. So what I'm gonna do is I'm gonna say if cell is not equal to, or if cell dot class ID is not equal to sum OXE2. Ooh, that S looks like a lowercase s. That's kind of confusing. And this is class, or what do I call this field? 324B2L. Thank you for following. That might also be a B2I. I'm not sure. I can't really tell based on this font. I'm guessing it's a B2I, actually. Thank you for following. Hope your day is going great. We're having a lot of fun here. Started off kind of rough, but now we're back into the fuzzing fun stuff. Why does this look frozen? Okay, it's not. So basically, I want to see this like type numbers into that E2 field, and it doesn't seem to be doing that. And that's really strange. So what I might actually do is I might have a random chance of sending like a set, maybe I'll have a chance of maybe just setting the field directly to a certain string or value. I think that's WM set text. WM set text, pointer to a null terminated string that is the window text. So we're gonna see if we can do this. This might actually cause us to crash pretty hard. We're gonna make a new thing called set text, null terminated string. And I'm guessing that set text, that will, okay, so that will be wide characters. So we'll do set text attempts to send a set text, or a WM set text message to the window. And then here we'll add this. Set text is equal to OX OOOC. Sets the text for a window, and then this might get really crashy really fast, so we'll do string to UTF-16 set text. Let text is going to be equal to this of input. This will just be a string. And then we'll pass this a pointer as pointer to that as usize, and then set text. And here I'm just gonna set text to 4 zeros. Okay, so that did fill in fields with zeros. That looked really good. Now, does that cause the values to get updated? So I want to make sure that that causes, I want to make sure that that actually causes the computation to occur, and it does. So 12 BTUs. If I do this and change this to 16, I think we'll see the computation occur. Looks good. Okay, so set text does indeed work. Okay, so now we have set text, and I really like that. So, okay, so I'm gonna make some notes here of what I wanna do, because I wanna have a random chance of key presses. Come on, pen. Random key presses. Random sleeps. And then chance of exiting, which is, we want to send a WM close. Close. I think I have a command for that. I do. Here, if I have this, this might actually cause everything to get really corrupted. Yeah. Yep. It basically sets everything to 16. That's fine. That's not a big deal. No problem. No problem. In fact, that's preferred. I like it. Yeah. Yep. Everything becomes a 16. 16. Everything's a 16 today. Here we can do a format. And we'll set it to this rng.rand mod 1000. Yep, and we'll just put an ampersand up front. We should be good. And there we go. We just have kind of text jiggling around, doing random stuff. But as long as these fields are updating and those computations are happening, I'm happy. And then these still enter things there. Okay. This rendering's really weird. Like, why do some of these render in, like, much different ways? Like, these don't clear themselves? I mean, doesn't really matter. Not just a standard calculator, and let's get some digit grouping. Let's go into some more complex modes. I think scientific with history. Probably about as deep as we're gonna get. Maybe like the, there we go. See what happens here. Looks good. We've got like all these fields updating. Okay. Yeah, the Windows 10 isn't the Windows 10 calculator isn't an app container. Pretty much all of the like universal API, like the Metro style apps, those sorts of things are almost all in app containers now. Because that's just like, that's almost become standard. Like, you're making a project, you put it in an app container. That's kind of pushed down by a lot of security people at Microsoft, which is really good. It's the right thing to do. So I don't know how to select these calendar events. That's another thing that will be interesting. So if we do, if rng.rand mod2 is equal to 0, set text, otherwise, we're going to send a command. Otherwise, if rng.rand mod2 is equal to 0, else. I know this is like not actually and then this key press. I know that this is not like good random number distributions, but this is just a test. rg.rand mod 256. And I might actually want to try to see what some of the like Unicode key presses do. Key press, one word. Isn't it key press or press? Press under key. You would do that past me, you asshole. Okay, so this is doing a lot of stuff. But this should be stressing a little bit more code. Enter data to calculate. It seems to get stuck sometimes unless I give it focus. So what if I do primary window? Isn't there like a WM set focus? It wouldn't hurt to have a random chance of sending the focus as well. This takes the handle to the window. Okay. Where do you send this to? I guess you send it to a parent window. Sets focus on a window. Set focus. This is going to be equal to 7. Set text. Well, this will be set focus. Attempts to send a set focus message, and that doesn't take a string, and it takes set focus. The first one is the window. Wind should be a window. We'll do wind. Glad I get to say wind again now that we're back into calc. Okay, so that's going to be setting focus on like random different things. It's filling in some history fields. That's good. Love it. So sometimes it gets stuck, but I don't actually know what's causing that to get stuck. What's the difference between what you're doing now and finding bugs in MapleStory and exploring MapleStory to see how it works? So MapleStory, when you're writing cheats, you're typically not looking for bugs. You're typically trying to figure out how things work such that you can design cheats that inject and hook and figure things out about the application. Ooh, we got a selection window on the calendar. I like it. But yeah, when you're looking to write cheats, you're usually like finding kind of behaviors of, you're trying to figure out more like how the application works so that you can find out where to hook. Whereas when you're looking for bugs, you're trying to crash things and you're trying to do that. You're really never looking for bugs in an actual when you're doing game cheats. It's possible if you're trying to like actually pop the server, but now you're committing felonies, so usually not worth it. Like, I would say getting an extra 20 gold in a game is usually not worth prison time. So I would recommend that if you're doing cheats, make sure you're always doing it client side. Don't try and attack the server. That's just silly. Even on private servers, just not worth it. Popping server for 20 gold. I'm sure people have done some really dumb things in the past. Okay, so we're gonna grab the set text and the set focus things. We're gonna add them to our inject sequence program. So now these are going to, we're gonna get rid of this print as well. And woot. I'm putting a woot in here. This is just a print such that I will be able to visibly confirm that this version of the application is the one that is running inside of the guest. We're gonna get some set text and set focus. We're gonna have to grab these fields out of here. Whack them in here. Cargo build. Looks good. And now I just need to have some special commands and how they work. So we have the sleep. We're gonna have, this one is going to be set text. Actually, this command is gonna take a window index from the command, and that's gonna be as a U size. So if the command is that, we're gonna get a window index. We're gonna perform, we're gonna sleep for a second. Then we're going to get the sub windows. Then we're going to select from those sub windows based on window index mod subwindows.len. So basically try and do that, and then we'll say if subwindows.len is equal to 0, continue. So this is going to be wait for potential GUI updates. Oops, updates, potential GUI updates. Get the sub window list. Select a random sub window. Okay, so now we've selected a sub window, and now we want to do an interaction on that, like a further interaction. So to do this, I need to figure out what interaction to make. So instead, window index is gonna become that, and then we're gonna have let action is gonna be equal to the command and OXF shift to the right by 1624. So this will get this part. It'll get this nibble. Once we have this, we're gonna say match action. We're gonna say if the action is 0, then we're gonna do I don't know, we'll send a close to it. Yeah, we'll do selection.close. Then in this case, we'll do a selection dot. In this case, we'll do a selection dot. We already are doing commands, so we don't have to worry about those. Actually, we're not sending commands to subwindows, so we're gonna do that. I might need to change this format to actually be 64-bit. I need more information in these commands. Maybe I should just deserialize them. That might be the way to go. And then we can use noodle. So we could bring in noodle, and then we could implement some enums for different actions to take. We're just gonna get something working quick, and then we'll polish it up even more. So this we're gonna send a. In this case, I could maybe consume another command off the command stream. Yeah, I don't really like that. So we'll have a chance of closing. We'll have a chance of doing set focus, and this will do primary window dot set focus on the selection. Oops, cell. Maybe we do it on cell. I don't know which one we do, and when we don't know which one to do, you just make it a random chance, and then problems are solved. And then we'll also have a set text. This will do a selection dot set text, and this will take a for the text it's gonna set. Yeah, we actually really might need to do a stream of commands, because we don't. There's no way that we'd be able to get a number in here in a meaningful way. I'm just gonna do set text 1 2 3 4 temporarily. Set text, set focus, and then and then here we can just do match action mod 4. 0 1 2 3, good, and then this panic invalid action. Oh, we need key presses for. That's going to be a different command. So this will be else if the command is that. Otherwise, if the command is 7, then we're going to get the key press. We'll get the window index from there, and we'll get the key from there. Shift by 16. We shift that by 24? Wait. No. FFOO. Then we shift this by 8. This one 8. This should be 20, right? Right? Yeah, it should be 20. I'm just double checking. F F F O or F O O O. Right shift by 20. Shit. What am I doing? It's 12. F O O O. Right shift by 12. There we go. We did it. We know how to do math. In this case, we shift by 8. In this case, we shift by 12. So here we'll get the window index. I mean, honestly, this can be this shift 8. So this will get the key. In this case, what's a command? It's just a random index of like a button on the screen to press. That's it. So we actually don't really know what that is at the given time. So we're going to select a random window. Select the random window by the window index. And then we're going to do as a usize. And here we'll do selection dot press key. Okay, remove the parens, fine. 0, 1, 2, 3. Set focus on a random selected window. Set some text on a randomly selected window. Here we're gonna get an action shift 8. This is gonna be command this. Key is equal to that, shift 8. Okay, that should be good. Build release. If we do a cargo clean, we're gonna tear down the server. This should fail to build. Good. Cargo clean. Yep. So we actually like broke all of our repro by doing this. Not if we make a copy of the keyframe. So I'm gonna make a copy of because the binary is embedded in these. So I'm gonna say decent run. I'm gonna paste those into there. I'm gonna grab these 3 and these 2. Okay, decent run. We've made a copy of kind of all that information so we can reproduce those if we need to. And now we just build this release. Cargo, this should now run, but we want to actually re-keyframe it. So Franzia runners, which we might actually have a window open for it. Maybe not. We're gonna grab this, and we're gonna say the command is going to be to do a keyframe, and we just gotta grab the file name from fakefs, dev, Franzia, actually TKO fuzz, Franzia fakefs, winpe calc, nice. We're gonna keyframe that to calc. Our keyframes are so much easier now, so much faster now. And then start calc. That'll cause it to get re-keyframed. Good. So now we can spin up the server, and all of our modifications will ship out. But now we need to have a random chance of generating these events. F repro. We got the repro. We made a copy. But last second thinking. Not that it's a big deal. I think every bug that we have, we can easily, we can just get back again. So here we have calc fuzz. Ooh, before the fancy console H14. So now what I want to do is in the generate routine, I want to have a random chance of, what are these doing? Input cell, that's mutation. So during the generation, that's just gonna push a random command. So what we'll do, if let cell is equal to franzia.rand mod 3, if let sum, or if, we'll just do match cell 0, the 0th case, the 1th case, and the tooth case. So what do we need to make? We need to make a 555. So this is, we're actually gonna go up to 4 here. So this is gonna be a sleep command. Input.extend from slice. This or franzia.rand mod and oxfff. And we're gonna cut that down. This will be up to, what do we want? I think up to like 2 seconds. It's probably fine here. .2 LE bytes. So we'll serialize that out. So send a sleep command up to that many seconds. This is going to be a key press command. Okay. And you know what? We probably don't want to sleep in the key press command case. That's just going to be a little too pricey for my desires. Where's my window here? This one. Okay, cell pattern, yep, not covered, yeah. So we're gonna send a key press command. This is gonna input, extend from slice, basically the same code, except this time it's gonna be this, and then we're gonna OR in, honestly, just rand mod and oxfff is sufficient here. As U32, as U32. That will cause that to get masked down, so it's just the bottom 4 bits, or the bottom 16 bits are completely random. And then we finally have our third command, which is going to be this one. This is what, this is like random action. And to do this, we need an action and a window index, and the action is modded, so it doesn't really matter. So this one is the exact same code, actually. It'll pick a random window and a random thing. Okay, put some semis in here. We don't have any weights yet, which will potentially hurt things, and then here we'll have a panic invalid generation. And then let's see what we're doing for feedback. I think we grab an input from the input corpus. Known IDs, random mutation. Oh, we're not doing any good feedback there yet, but I just want to get this up and running, make sure everything looks good. So calc stepped, we're gonna get this deployed out, spin up my servers. Okay, so 64 workers online. And I just want to see, I want to see like one of them return out, because we put woot in there. So effectively, we just want to see a woot. A woot will know it's running the latest version. And I think we did everything in here correct. Sleep, we send a 5555 or this rand. Okay, so I do see woots, so we're good. 5555 or up to 2K. Millis looks good. And then 5557. That's good. And then this one is the exact same thing. So we're just providing entropy in a stream. And let's see. Are we getting any new coverage? Oh, did we purge the coverage database? Oh, yeah, we moved the coverage file. So mainly what we'll do is we'll see how this performs for coverage compared to the other ones. And we're going to get some graphs up in a second because we need to be able to compare kind of apples to apples. Where are we looking? Franzia runners, calc step crashes, star.crash. All right. Okay. Looks good. Exit with -15. Means some things are getting the sleeps. I think we're putting the sleeps in too frequently. Maybe. We'll see. Actually, we have an MSVCRT crash that I don't think we've seen before. So, I'm going to take... we actually see a couple of them. So, we might be hitting new bugs. So I'm going to take a quick break. I'm going to just start some rice and set up the oven so I can get some cooking going. And I will be right back. Did we do it? Did it work? When you work with client server, do you manually copy, build, start up the binaries on one big CPU box? Yeah, that's pretty standard. Let's see. Work with client server. Manually copy, build, start up the binaries on the big CPU box. I mean, it varies. Like in this case, I kind of have deployment. Usually if I'm like working on a relatively long-term project, I'll figure out a way of doing some sort of deployment or something so I can get all of this spun up. But yeah, it definitely varies. So we have MSVCRT crashes. These, these crashes, since they're crashing on a page boundary, these are almost guaranteed to be heap overflows. So we can see we're in MSVCRT. This is probably going to be a memcopy reading out of bounds. So let's take a look at what those are. I don't think we've ever actually seen MSVCRT crashes. Let's take a look at our old crash logs here. Decent run. Crashes. Yeah, there's nothing MSVCRT. So we basically, with our new terrible fuzzer, have hit like a completely different crash. And that's why it's important to kind of work and churn on your fuzzers. If you're not modifying your fuzzers, you're gonna miss out on a lot of things. So let's see. Yeah, no MSVCRTs in this list. So that means what we're gonna want to do is we want to make a copy. Get rid of all these things. Make a copy of these two files, and then we're gonna go and repro one of these bugs. And here we go. Here we're gonna do. Come on. Calc stepped crashes. We know what the non-canon access is, so I guess we don't want to do that one. Calc stepped crashes this. We'll take a look at. These are all kind of in the same location. That makes sense. This one's actually really interesting. That's like a big out of bounds, but all of these look like out of bounds reads. Pretty standard. Pretty standard. Let's get that KDNet up and running. Here we go. Off to the repros. And there we go. And we're in WCS cat. Wow. Add equation to history. Huh. DBR8. Okay. Well, that's, yeah, if we look at R-1, that's valid. Yeah. So effectively, this is some sort of out of bounds read on this. WCS cat. What is that? That is, WCS cat. No, I don't want to go to that as a website. Wide character concatenation, string concatenation. Basically, this is like not null terminated, probably. No, I'm actually. That's really strange. Where's it starting? Check for scroll buttons. Update and fire. Huh. Process command. Add operand to history. Add equation size to history window. Store and fire. I'm guessing this is due to our like renaming of windows. Probably when we rename a window, I'm guessing it's like storing something that it's not used to storing. Maybe it only ever expects that you have a number in there, and we're like putting a string in there maybe. If we go back 20. Process command. Process keypad input. Yeah, I don't know. Honestly, I don't know what this is doing here. It seems to crash a lot. Huh. So, grabbing from R8. Check for scroll buttons. Is that your server running? Yeah, this is. I actually don't have the other one up. I can pull the other one online. There we go. We'll bring 256 more cores on. Okay, check for scroll buttons. 2 lines displayed. Fire event, store, okay. Add equation SZ. Add operand to history. So this is like putting stuff in the history list. And then this is doing like a string concatenation. Well, if a string concatenation is reading out of bounds, that also means it's probably going to write out of bounds. RCX plus R8. L300. I just want to see if this is close to the end of an allocation. Not quite. Like, if we're causing an out of bounds in a string concatenation, we likely could corrupt massive amounts of memory. Unless it allocates a huge buffer. Where is this at? Where's RCX? Is that on the stack? 461AC, 9C, 950? Oh boy, that's on the stack. I see. I see. Okay. Okay, I think we're gonna have to probably have another keyframe that is without page heap. So we're gonna spin up another session. I think we might want to see what some of these look like without page heap on. Yeah, it's likely a stack buffer overflow in this case. I mean, at this point, we're like kind of cheating because we're like sending window titles. I don't know. I think messages are still fair game. Sending messages to windows. I think that's fair game. Like, your application shouldn't crash based on an external message you receive from an application. We're not like doing memory injection. We're just sending a message along. So let's go take a new snapshot with this stuff off, with page heap off. Set Twitch fuzz calc. We have the WinPE calc. Gonna boot this bad boy up. The Rust kid you wrote is what the server's running. Fuzzer like WinAFL. Yeah, it's pretty much everything. Pretty much everything in this loop. The server deployment, the scaling, the fuzzers are all written in Rust, and they're all written by me. So like the whole of everything is kind of done by me in this case. Obviously, there's some third-party stuff, or there's not third-party. There's stuff that I work on the TKO Fuzz project with my team. But the foundational stuff of TKO Fuzz is largely me. I just work on the internals. I don't really do much of the fancy stuff. My stuff is usually boring. No rendering. No interfaces. All my stuff is always kind of behind the scenes performance. But this stuff is so fun. I can't wait to see what these crashes look like. Oh my god. I'm pretty sure we're gonna have like a stack cookie smash here. We can actually see what this one is. Like this one, like why would it be jumping completely out of bounds? This one makes no sense to me because why would you be reading from memory in the middle of a page that doesn't exist, that still is valid and is not uninitialized? That to me looks like an arbitrary offset into something. So we'll see how this one repros. Ooh, this one's a little slower. Okay, this is in the same location. And yeah, this is just in the middle of a page completely. That's fucked. It's the same thing. Check for scroll buttons. Update 2-line display. Fire, storm fire, change mode, clean calculator mode, process keypad inputs, keypad input, process command, complete history line. Okay. Well, that's that's broken. Okay, we're gonna do this. We don't want to set G flags this time. 132 calc.exe. Open up this calculator. We're gonna do need a little bit of mouse interaction here. Put it in a programmer mode. We'll put in unit conversion. Pop up the about. Gonna close this. Gonna switch back to standard mode. Turn off all these options and settings, and we'll take a or a snapshot here. So we'll okay. Then we'll move this down a little bit. Okay, and now I should be able to run James Bond. And that will take our snapshot for us. Nice, done. Okay. So now I can say WinPE calc no page heap. And we're just gonna have to make some keyframes. Where was our keyframe making window? One of these we made keyframes in. Probably this one. We'll do this keyframe, or actually convert. First we gotta do conversion. We'll do this, no page heap. Oops. Yep, need a full path. Duh. And set fakefs path is equal to d:/dev tcofuzz franzia fakefs. Boom. Conversion successful. Now we can do a keyframe. This is gonna be calc no ph. We're gonna have to call it calc temporarily. We'll call it calc no ph, and we'll fix our stuff over here. Keyframe. Here we just need this. Calc no ph. And then we need to change our calc fuzz. Calc. If it's equal to that, or it's equal to that, calc no ph. Anywhere else? Here, or calc no ph. If it's that, or it's that. And then in this case, if it's that, if the keyframe name does not contain calc in this case, just return this or that. Okay, so this should now work. Oop, that's gonna make a calc stepped. We'll actually just make a different if statement. Calc no ph, calc step no ph. Okay. Took snapshot. Did that overwrite itself? Calc stepped. Oh, that was the keyframe. Yep, that was fine. And then we can do start calc no ph. And this should create a calc step no ph file. Nice. Okay, so now no writes yet. I think we're gonna see some real bugs here in a second. If we do calc stepped no ph, we'll get rid of these. They're easy to get back. Oops. Start this. Run this. All right, and we got a crash already. Oh, this is gonna be calc step no ph crashes. Oh, that's nice. Get a different folder for it. Bring some other cores online. Oh, we have a different, yeah. We have a different CR3 now. This. CR3. Oops. CR3. We're just temporarily gonna swap it. We're gonna say this is page heap. No page heap. Now we're booking it. W Smalley, thank you for following. Welcome to the party. How's it going? You can just Google everything. Page heap. Where do you learn this? You learn it by just doing it. That's it. You just literally learn it by doing it a lot. Oops, I want to scroll this in. Okay, better. All right, let's see what we get. I think we might get a GS cookie failure here. We'll probably see a stack smash. Good, and you? I'm doing great. I'm just getting my my food going right now. I've got some rice in the rice cooker. Happy about that. I'm gonna making like a Dijon mustard chicken, breaded chicken thing that I'm just gonna put over a bed of rice. Really simple. Be nice if there's a good book or website that wraps most of this stuff. So here's the thing. Whenever you're wondering why there isn't a good book or a good website that teaches you all of these things, it probably takes at least 4,000 to 5,000 hours to get a decent grasp of like security research. You can't publish a book that takes 5,000 hours to read. You can't publish a video that takes 5,000 hours to watch. Ultimately, a lot of it is just experience and just getting in weird situations where like things break and things don't work and everything's crashing and falling apart. It just takes that experience of seeing those things. There's like the IDA Pro book will get you a good start for reversing. It's not perfect, but it will get you a good start going. Shellcoder's Handbook is going to get you some good basis on like exploit writing. But once again, eventually you have to like just be comfortable not knowing things. Most reverse engineering is being comfortable not knowing things and figuring them out yourself. Like to be a good reverse engineer or a good security researcher, you need to be able to adapt to situations that nobody has ever seen before, which means that you can't have books to teach you these things because they're just every situation, every day, you see something new. You see a new exploit, you see a new crash. a weird corruption in a different way, or you have something that has symbols or doesn't have symbols, or has strings, or is embedded, or runs on some mainframe, or runs on a CPU you don't have a disassembler for. There's just like an infinite amount of things that kind of come up when doing security research. And you just have to be able to adapt and be comfortable not knowing, and kind of have like a rough idea of like a general thing that might work, and then it won't work, and then you'll learn from it. Like, most security research is making mistakes. Like right now, we just took a keyframe without page heap enabled. We're expecting to see some gnarly crashes in some weird ways, and we're seeing nothing, and the crashes look like ass. And now I'm gonna like make some decisions based off this, to maybe go back to page heap mode, or maybe to change how my fuzzer is working, or maybe I'm gonna double check to make sure I didn't make a mistake and I didn't screw something up. What are your thoughts to the iBootROM exploit? I think it's fantastic. It's a wonderful bug. Big fan. Good research. I haven't looked into the exploit itself. I'm guessing the exploit will probably not be too great, but that's standard. Like, public exploits are never really high quality, but the bug itself and the write-ups have been really impressive so far. And I'm sure at this point it's probably been like put in Cydia and all the different things, such that it's like given a nice UI, and it probably has polish now. Learn memory man. Let's see. Not talking about the crash, but the page heap pools and stuff. Once again, it's all specific to an OS. Do you want to learn Windows heaps? Do you want to learn JE-malloc heaps? Do you want to learn Linux heaps? Do you want to learn Firefox heaps? Do you want to learn Chrome heaps? Custom heaps and boot ROMs? Do you want to learn heaps? And it's all over the place. There is no heap book. There are heap papers on specific heaps. So like if you Google like Windows 10 LFH heap, you'll be able to find some like slides from someone's talk at a security conference talking through how like the low fragmentation heap looks on Windows. But at the end of the day, all heaps are pretty different. While the concepts are relatively similar, there's not a good one-stop shop for kind of learning those things. If you want to learn like the Windows stuff, I would just go pick up the Windows internals book. It's pretty much the best way that you can start. But to be honest, and I don't mean to sound rude here, but to be honest, every time you ask what book should I read, what things should I do, you should just do something. I see this all of the time with people who are new to the industry, and they're always looking for like, okay, what should I read? And they spend all of their time asking people what they should read, what they should do, all of these different things. And at the end of the day, a lot of these people never actually end up doing anything, because they're looking for the free lunch. They're looking for the book that tells them how everything works. And at the end of the day, there aren't any good books in security research. There aren't any good generic solutions to any of the problems that you see in security research. The only situation where I would end up picking up a book would be if I'm looking for a specific problem. Of like, I would pick up the IDA Pro book if I'm trying to get really good at specifically IDA. And not reversing, not reading between the lines, but like specifically the IDA content. Or I'd read Windows internals. Actually, Windows internals is not really a readable book. Windows internals is more of like a reference book of, hey, I need to figure out how this thing works in the kernel. Flip through the pages, get to the right chapter, and read specifically that chapter. But almost every educational resource in security research is pretty much always a reference material. And thus, the best thing you can do is just do stuff. Like, then the next time you feel yourself saying or wanting to ask someone what book or what thing to read, don't ask that, and instead go to some random CTF website, download a binary, grab R2 or Ghidra or Pirate IDA or do whatever you need, and just open it up and start looking at it. Because that will get you so much further, so much faster than pretty much any other solution. There's the trainings out there are, you get what you put in. Like, if you go to a good training, even if it's by like a top tier researcher, if you pay $5,000 to get the top tier black hat whiz bang training course, you're only going to get out of that course what you put in with focus and attempts. You know, if like, plenty of people go into training courses and come out not learning a single thing. They might like maybe have some idea of something that they could reference in the future, but the amount that people learn in trainings and those sorts of things is pretty low compared to what you would get if you just went out and explored and learned. I don't know. I mean, I'm not saying trainings are bad. Trainings are really good if you are already relatively familiar with the concepts that you're going into a training for. And I think you can get in really good situations there where it's like, I don't necessarily know the internals of some certain embedded device, so I could go to a training on that embedded device. But if I didn't understand a similar device or like an analogous device somewhere else, it'd be very difficult for me to kind of make that leap into a different space. But yeah, at the end of the day, there's just, the only solution is to just hack. Just do it. Do CTFs. Find a binary that you want to fuzz, like calc. Like, look at this shit. We've got so many crashes in a calculator, in a calculator that's been around for 30 years. And it's like the worst fuzzer we've ever written. It's the most basic thing. I tried CTF, but I haven't solved one yet. You could try and find like easier CTF challenges. You could try like different approaches. You could maybe try cheating on a couple. Like, it's not cheating. Like, go grab a CTF problem, find a write-up for that CTF problem, and read along. Kind of like go through the steps of the blog. Try and reproduce it. So like, if you find someone blogged about, oh, I did some whiz-bang CTF problem, you could read that blog, and let's say the blog has like screenshots of IDA or whatever. Try to reproduce those screenshots. Try to get to those same steps and see what they have done, but try and do it relatively organically. So, I don't know, like, follow along with things like that. To be honest, I've never really read books in security research. I've never been to a training in security research. I have never had a formal certification for security research. I've never gotten an education in security research. But what I have done is I've spent 10 years, probably more than that now, probably like 15 years, just doing stuff and getting comfortable with these things. And the knowledge that you get and the experiences you gain make it so easy. Like, you can be the most studied reverse engineer out there. And if you understand, like, you could read all the books and read every white paper and read all the academic research and go to every talk and go to every training and do all of these things. But at the end of the day, you're probably not going to be a good security researcher because you don't have the experience in real life scenarios. Every single scenario in a book, every single scenario in a training, in a book, and all these things are contrived. They're contrived because someone's presenting them to you. And in real security research, things are not presented to you. It just happens, and you have to, like, deal with the hand you're played. In this case, like, if we had to, like, our life depended on landing an exploit in calc, we would have to find some way to make one of these things work for us. And we would have to go figure out probably what every single one of these are, do at the end of the day, like root cause them down, go through all of the different steps, how the different ways they can fail, think about different ways the calculator app maybe could fail in different situations. It's a puzzle. Security research is one gigantic puzzle, and it's fucking amazing. It's so fun. Like, that is why I think security research is amazing, because every day it's different, and everyone likes to say that about their job, of like, every day it's a different thing. I go in and I get a different task and whatever. But with security research, it really is every day is different. You come in and you look at your crash results and you see a crash and you're like, I have no idea how that works. It's some weird obscure race condition with some network interaction. I don't know. And you just get to figure it out. And it's like, I think the best analogy for security research in like a different field is like archaeology. You go to a dig site, it's massive, it's like 10 square kilometers, and you get out your little toothbrush and you just scrape at some rocks, and then you hope that maybe you see something that you recognize that then allows you to like focus more on that area. It's amazing. It's so open. Security research is still so in its infancy. It's a joke. Like, I would say there are no good security researchers out there. There are people who are relatively better than other people, but I would say so far the security research industry is so new and so rapidly developing and changing that we still haven't had a good security researcher. We haven't had a Babe Ruth of security research because it hasn't been around long enough. It hasn't been formalized. It hasn't been studied enough. And what's so cool is if you get into security research right now, you will likely see the security like industry change from the inside out. Like, all of this stuff is so temporary. In 5 years, everything's going to be different. In 5 years, people probably won't say AFL. You probably won't hear AFL anymore because it will be replaced with something different or better or all these things. But yeah, that's my mini rant on security research and the best way to get in the door. So I tried to extract Windows PE images without installing the ADK, found a gigabyte of AVI files referenced in the installer. A gigabyte of videos of someone playing football. Huh. Is that like just a generic video that like ships or something with Windows? We have a couple of these MSV CRT crashes. I'm just waiting to see what these are. You can look at it on the bad side because it's rapidly changing. You need to put a lot of effort into it. Honestly, I don't want to sugarcoat it. Security research is not a good industry for people who want to rest and invest. For people who want to get into a company, prove themselves over 2 years, and then coast until retirement, security is not a good industry for that. There's a lot of money in security. There are a lot of people getting paid way too much money for the value that they actually provide for the work they do. So there definitely are exploitative ways to make money in security research, no pun intended. But at the end of the day, security research is brutally cutthroat. Like, the standards are set by, like, the worst security researchers out there are still exceptionally good at what they do compared to like a bad developer. Like, a bad developer can probably go a year without like writing any code, or like they write buggy code, or it's like completely useless code to whatever company they're at. Where security researchers, you're kind of always on the line. And a lot of the reason for that is security research doesn't provide any value. Like, no one makes money from security research. What you do is you prevent losses. So defensive security research is pretty much entirely you try to find a bug before someone else finds a bug and makes your company look bad, which then causes you to lose trust or lose kind of your foothold in an industry. And when you're in kind of a cost sink like that, it makes it very difficult because basically every day your boss is trying to like figure out what you do. You know, it's tough. So I'm new to reversing. Do you think I should stick to assembly until I master it before I start doing any reversing sessions? I don't think so. So that question's kind of hard to answer because it really depends on the way you learn, and I know it's cliche to say everyone learns in a different way, but I typically, the way I approach problems is I normally just go into them head first and I start working on them. So what I would do is I would learn assembly by doing reversing. I would immediately grab a CTF challenge, and I would, or whatever binary you want to do, maybe a crack me, honestly, grab some old software from 1998 and try and crack it. Like, try and figure out how to make a keygen for it. But what I would do is I would probably just go into it, start reading the code, and you wouldn't know the assembly. Like, you wouldn't know what the lines do. And every time something comes up that you don't understand, try to figure it out. You see, like, oh, I don't know what this weird instruction is. Learn how to read reference material. I think that's a really important thing, is to understand how to read the actual source material. I've met a lot of people in my career who can't read the Intel manual. They have no ability to actually read what the instructions are, or how they're encoded, or what they do from the source of that information itself, the Intel manual. I know a lot of people who can only use like third-party things like books or blogs that have that information. It's really important to learn how to read that technical documentation. You don't read it like a book. It is a reference, but you have to learn like how they word things and how they diagram things and how they lay things out such that you can quickly reference those. Like, if you were to ask me something about like an Intel processor, I probably can't answer it off the top of my head because I probably won't know the technical details of it, but I probably within 2 minutes could find the like section in the Intel manual that covers that topic. So like referencing source material when you're learning, I think is really healthy. So if you're opening up a CrackMe application in IDA, you come across an instruction you've never seen before, try and look up in the Intel manual, look up what the instruction does, try and read through it and get comfortable with that. Because the source material at the end of the day is the ground truth, even though it has mistakes. Like, the Intel manual is riddled with mistakes. It's still the best source of information. But yeah, I think just tackling problems when you come across issues, go and try and find the like creator of that documentation. I'm having a hard time understanding all the mappings of registers that is going on the low-level language. Okay, what sorts of questions do you have on x86? Maybe I could answer some. If you are talking about x86. I just kind of assume everyone's doing x86, which is not always the case. We're just waiting for crash results, and I've got a good glass of wine here. I'm having fun. So we're going to take a peek at maybe a couple of these. Although, I don't think we're going to learn anything new. I think this is actually going all the way off the end of the heap, which is kind of crazy. Move EDI, push EBP. Okay. So it looks like things like this still confuse you. What confuses you about it? Is it the different instructions themselves? Is it why they use the registers they use? Is it what those instructions are doing themselves? Don't know why they contain. Basically, what it looks like you posted is a function prologue, because it's saving the stack into EBP. It's making a copy EBP, and then the move EDI looks like basically like a slot, so someone can go in and post and fill in a jump instruction so they can hot patch it. I'd like to do a project like what you're doing with this fuzzer, but can't really think of a realistic target. I definitely don't think I'm ready to tackle calc. Any suggestions for a noob? So, one of the beautiful things about trying to find bugs in software is you can always just grab ancient software. So if you have, yeah, exactly. If you have access to source, it's a lot easier because you can build and you can walk through. Although, I would encourage you to look at targets that you don't have source for, because a lot of security research, you either won't have source, or if you do have source, it'll be limited, or you won't be able to build it. And all those things can be really difficult. I would go grab a Windows 95 ISO, install it in a VM, and take a random thing out of Windows 95 and try and fuzz it. That might be a little bit tough because it might be hard to get Windows 95 up and running. But a beautiful thing is that 10 years ago, all software was so bad that if you just get any legacy code, almost any fuzzer would just pour bugs out of it. You could grab an old image parser, you could grab an old PDF parser. If you go grab like Adobe Reader from 2004, I'm pretty sure you could make a one-line Python script that would find crashing bugs in it. Like, take a PDF, randomly flip bytes in it. In fact, we could go try that if you're interested in that. We could go grab like an old PDF reader and see the worst fuzzer that would still yield results. And I would suspect that it would be basically a one-liner. Tonisk, thank you for following. Baruth, thank you for following as well. I think I missed that follow notification. Gamozo, how do you handle fuzzing software without source and symbols? Say you have a proprietary system and some kernel dumps. How do you go about fuzzing this in an emulator? So that's actually kind of my specialty, is I work with a lot of tough to emulate environments. So typically, if you can get a memory dump, if you can get like a full memory dump, you can get it up in an emulator. So I've written a lot of modifications for QEMU. I've written a lot of modifications for Box. Now you have things like Unicorn that kind of allow you to like program emulators, kind of. They're not great. But there are a bunch of different ways. Like if you can get register state and a memory dump, you should be able to resume execution in an emulator for basically any system. Now, eventually, those things will go and access devices that are special to that device. So if I took a memory dump off of an iPhone, I could easily load that into ARM64 QEMU, and it would allow me to continue execution of the kernel, user space, whatever I dumped off of an iPhone. However, eventually that's going to access a device. Eventually it's going to talk with the radio on the or like the Bluetooth chipset or the Wi-Fi chipset or something like that. And at that point, you no longer can emulate. But in most situations, you can get away with avoiding those devices, or maybe instead of emulating those devices as devices, emulate the devices at an API level. For example, a kernel level device or a kernel driver might not directly interact with a device. It will call a function, which calls a function, which invokes a driver, which goes into a stack, which does some other stuff, and eventually it does raw I/O with this device. But at the end of the day, whatever you're fuzzing, you might not actually need to implement the file system and the NTFS stuff and all this stuff. You might just need to provide a hook on open. And when it goes to call the open routine, you spoof it out with something. So that is something that I kind of specialize in, which is harnessing things that are very difficult to harness. And almost every time it's go to an emulator and start emulating devices or APIs manually. I've gotten a lot of things to run in emulators that definitely I have nothing that allows me to run them on actual hardware. And it's pretty cool. It's a really good feeling. With vectorized emulation, I actually have a mode that I call gauge fuzzing that allows me to just, even if I don't have a snapshot, I can still resume execution at any point in an application. So for example, I could take an elf and I could just resume execution at a given function, but I have all the hooks in place that tell me the validity of registers such that it would panic out if it eventually saw that it accessed a register that I didn't initialize. So like, if I were to take, let's say the iOS kernel, and I were to want, if I wanted to run memcopy in the iOS kernel, I could simply just load up the iOS kernel binary in QEMU, set PC to the start of the function, and then set up the 3 arguments that I need, and now I'm running all of that function's code. And basically making all of that stuff fallible such that if you were to access a register or a global that you haven't initialized yet, it's important to have that information echoed out in a way that you know that you have to implement it. Specifically, I'm wondering if there's some way you would recommend to get coverage information. I can imagine using shitty trampolines on jumps, but I guess some deterministic emulation is probably the way to go. So, getting code coverage is pretty easy in 2 different ways. One, if you actually load it into an emulator, you're just done. If your question is how to get coverage out of an emulator, let me know, and I can answer that question. It's a lot easier. If you're looking to get coverage out of a live device, it's a lot more difficult. Like setting some sort of trampolines on jumps, that's actually really risky because that requires that you understand where all the jumps are, and that's a hard problem. That's a provably impossible problem, is finding all the jumps in an application. And thus it can be really difficult to do things like that. What I would maybe recommend instead is if you can get code execution in an interrupt handler, like a timer interrupt handler, log the PCs every time an interrupt occurs. And maybe if you can get away with it, crank up the interrupt frequency. So what I often do is it's just like profiling based sampling. It's basically, if you can set a timer that triggers every 1,000 times a second, just record PC when it happens. Yeah, of course you're gonna miss coverage and it's gonna be lossy, but it's gonna get you 99.9% of what you need. And that's usually good enough. So that's what I have in my in Fulkervisor. That was one of the first coverage modes I implemented, and it works great. It's timer interrupts are universal. They're on every single device out there. Can you make Mac OS virtualized? Yeah, I don't do much Mac research, so I'm not too familiar specifically on that topic. I do know that Hackintosh exists. I do know that there's a company out there that produces an emulator for iOS devices and for, I think it also works on normal OS X. Parts of OS X are open source as part of the mock kernel, which you can find the source, I think, just on GitHub. I don't think there's enough there that you can build and run it, but there's enough there that you could build portions of it, and you could harness those in something like libfuzzer, where it doesn't need to have the full system. So, yeah, it can be really tough to run OS X because OS X intentionally tries to fingerprint your hardware to see if it's actual Mac hardware, and will basically fail if that doesn't exist. But yeah, Hackintosh is kind of the reference there. Only Hackintosh is the solution? Not necessarily. There are a couple other like more commercial ways of doing it. There are a couple emulators that kind of support it. But it always kind of is in limbo. It's basically whether or not you can emulate the latest OS X depends on if people have within the past year done like the right research to figure out how to get whatever up and running. If you really need to get like an OS X device such that you can actually use an OS X device, the like Mac Minis are actually really cheap. You can get them like off eBay for like $50 to $100, and they usually get updates for a decent amount of years. So usually you can just get something really cheap to have some Apple device. So like, I don't do any OS X research. I've never really done it, but I still have a couple Mac Minis and a few like Mac Pros sitting around, just because every once in a while you have to like use them for something. How do you go about trying to reverse engineer an infected binary? Ooh, that's a little bit difficult. It kind of depends on the level of the infection, or the level of like risk. If you're dealing with like some of the like most cutting edge malware, that becomes really difficult because you have to be concerned about whether or not it can escape the VM or whatever you run it in. But for traditional malware, like malware that basically anyone would get, like a random person would get, yeah, just throw it in IDA, take a look at it. There are a bunch of tools out there. Are so many tools out there that help you unpack binaries that have been packed or deobfuscate things that have been obfuscated. And of course, at the end of the day, you can kind of just throw it in an emulator and poke around with a debugger and kind of see what happens. So yeah, there are kind of like a bunch of different ways that you can go about it. Just be safe. I would never do any research on real targets on an internet-connected machine ever. It's just too risky. So I would just not have an internet connection on whatever machine you're on. If you're lucky enough to have the resources to have an extra computer lying around, I would commission an offline machine that you only do research on and you never connect it to the internet. That would mean that regardless of if it breaks out of a VM or massively corrupts your machine, there's no loss there. So having the internet on devices that you do research on is really, really dangerous, I would say. Sadly, pretty much everyone just does everything on the internet now, but I would recommend not having internet. And I would recommend not just disconnecting the internet from a VM, but going all the way to having the whole computer not have access to internet in any way. All right. So we can take a peek at some of these. So we have these MSVCRT crashes here. They're read faults, which is kind of interesting, but they're in the middle of pages. So I'm not quite sure what these actually are. And then we have a couple crashes. We actually have another one. Oh, that's at the same location. All of those are the same. Bunch of null DRFs that we don't care about, and then a couple here that look interesting. So we're gonna take a look at all of these interesting crashes quick. We're gonna just do a rough pass of what they look like. But y'all might be wondering like why I haven't root caused any of these bugs yet. And quite frankly, it's because none of these bugs look good enough yet. I have a pretty good hunch and idea of the exploitability and the like impact of bugs based on glance value and stack traces. And so far, none of these have really stood out. I haven't seen any that are writing to memory. I haven't seen any that are jumping to an arbitrary location in memory. And I'm kind of waiting to get better bugs before I dive in. Keep in mind, I'm used to much longer term research projects. So it's pretty normal for me to go like weeks without root causing a bug, because usually doing something else is better than root causing a bug that shows up. So we got Katie up and running here. We're gonna get that repro session up. We don't need that. Where was it? Was it this? Was this the one? Yeah, we're using this. And we just need to call calc stepped no pH crashes. I'm gonna pass it in this, and then here we'll pass in, we'll make a copy of calc step no pH. Where's that at? Right here. Good. Calc stepped no pH, and let's take a look at what these crashes look like. Pop in that debugger here, looking good. Logic Bench, thank you for following. Welcome to the party. How's your day going so far? Okay, we're now in the debugger. We're in the same location that we were seeing the faults before. In this case, once again, check for scroll buttons. I have no idea where this address is coming from. If we look at ballpark where we are, how do we compare to the stack? So if we look at R8 minus RSP, we'll see that we are very far from the stack. So it doesn't look like this is a stack access. There are a couple things. So R8 obviously is where we're accessing. And then R13 is kind of close. RBP is kind of close. Let's take a look at those. RBP, okay. Oh, look at that. This looks like a calculator expression. If I do, if we look at RBP, we see a 131.072 log cosine G, that. Let's see if I can get some more out of this string. db this, L 100, description, there, various units, for angle. Okay, so we can take a look at, I don't know if bang address works in this context. Yeah, it says user range. I'm really interested in the protections. I don't think vprot even works at all. Yeah, vprot doesn't work in kernel mode. Kirby ANC, thank you for following. Okay, let's see. Oh, I missed some things to chat. Would be super interesting to see the attempted reversal of PC in game, possibly writing an injector for it too. I did that. I wrote some MapleStory cheats on stream and I got banned for it. Unicode corruption. Yeah, it's hard to say what this is so far. I mean, we're just looking at RBP, which has no relevance. I'm just looking for like what is nearby here. So if we looked at R8 minus RBP, this shows that we're not close to that. So what about R13? I'm trying to figure out like what the nearest thing is. If I do a db on R8 plus or L like 10,000, nothing nearby out back. And there's nothing nearby out front. We're just like completely in the middle of nowhere. I have no idea where this address came from. So it's really hard to say. And then if we look at what we're gonna write into, we're gonna write into RCX plus R8. And if we diff that from the stack, I think we found that this was on the stack, right? Yeah, this is 82 bytes off the stack. So, and then if we look nearby here, it looks like some good room on the stack. We'll try and print out 40. Oh yeah, that's not aligned. We'll align this, and we'll see that pretty nearby there's actually a function pointer. Now this isn't necessarily function pointers that are in our stack. Our stack looks quite different from this, so the distance we are from our stack is pretty far. So it looks like the nearest thing is probably this is the nearest return address. Doesn't really matter. There's going to be a heap cookie anyways, or a stack cookie. So that bug is probably not really useful to us. Start out crash. Let's see if we have anything else interesting. So all of these would be actually, ooh, this one actually looks like an ASCII deref on the bottom 4 bytes. That one is interesting. I want to take a look at this quick. And let me get my rewind script going, because this one actually looks really interesting to me. A decolon slash TKO fuzz, dev TKO fuzz, Franzia, KDNet plugin. What do we call it? KD plugin, KD extension. Dev TKO fuzz Franzia, Windbag plugin. This keyframe.dll. So let's take a look at this one. I'm gonna move some of these windows to a different screen so I don't end up control C'ing them, because sometimes I just control C whatever looks like was doing some scrolling. So we'll delete this, and we'll grab this crash. I just see a 6.2, a 60, and a 6.9, and then the 89 doesn't really make much sense, but these three look a lot like ASCII, and potentially there's some like ASCII being used there. Oops, I need to disconnect that. Okay, restart. Okay. What's this YouTube link? Oh, yep, this is MapleStory cheat stuff. Yeah. That's actually, man, I have a lot of views on that. People loved the MapleStory cheating stuff. I still get emails to this day of people asking for those cheats and information on them. Okay. So now we wait, we see where this crash came from. Doing something with Rust here? Yep. All the code that I write is in Rust these days. I haven't written pretty much any other language for a while. Here we're gonna look at, let's look behind. Let's see where we're getting R8 from. R8 is coming from us. We're gonna actually disassemble function. We are, where are we at? We are here. So we actually don't know where we came from because we are a branch target. We'll rewind one instruction. Let's keep going back until we see where R8 was computed. So it's going back, going back, going back. Here we go. Here we have a null check on R8. So we're checking if R8 is null. This might actually just be an arg directly. Or disassemble function RIP. So yeah, I think R8 is just directly being passed as an argument. So what we want to do is we actually want to go, we want to get out of this function. Okay, so this is who calls it. And at this point, we should see that R8 is completely clobbered. I really need to make like a go back until last start of register. Another all-night session? Not really. I just have like a weird sleep schedule right now, so it doesn't really feel like an all-nighter. I still have a lot of energy right now. Johnnernaut101, thank you for following. What is up? Okay, we're gonna keep going back. Okay, here's an LEA. Oh, beautiful. So if we look at R8 right now, R8 is valid. R8 is pointing to a 305. This looks like some string on the screen. But RBX times 2. Oh. So for some reason, yeah, it's taking a pointer and it's adding this times 2. Now, it's a coincidence that it actually looked like ASCII if we take RBX times 2 and then add that to R8. It's just a complete coincidence that this looks like ASCII at the end, so that was kind of a red herring, but still interesting. I keep pointing to the screen, even though you can't see my physical finger pointing to the screen. I need like an eye tracker so I can eye up the screen. So we have something here. This has a dot. I think 2e is actually a dot. We have a dot. So we have like kind of a decimally encoded thing. If I take a look, I just want to look back a little bit. We got a 2 dot this, and if I did a DU on R8, this will print it as Unicode. So this definitely looks like an expression that is on the screen. So what we want to do is we now want to figure out where the hell the RBX value came from, because that's sub RBX RCX. So let's go back 2 instructions, rewind 2. This is going to be on the sub. So this is going to compute that bad RBX value. In this case, ooh, is that an integer underflow? That, I mean, RBX is definitely about to underflow here. Why is RCX like that? RCX is coming from EAX. It's signed extended EAX, which makes sense. It checks out. And then EAX is coming from RSP, or we're actually doing an idiv on RSI. So if we do a D on RSI plus 18, so it's going to divide EAX, which has been sign extended, which came from RSP plus 30. So DD RSP plus 30, it's taking this value, and then it's dividing it by 7, and then is he using that as an offset? Well, that ain't quite right. We're gonna see where this instruction is. DB this minus win32 calc, or we're in MSVCRT. D. Wait, what are we in? We are in win32 calc. Okay, so we're gonna take this into our iters, and we're gonna add this offset to it. Okay, so this is where we currently are. And basically, this value, so I just want to annotate this a little bit in here. We're going to say at the point of this sub instruction, before instruction, RBX is OX1E, and RCX is this bad boy. Okay. So this is going to do a string concatenation of R8, which is computed based on the source buffer, which comes from RBX times 2. The multiply by 2 is probably a really crude Unicode conversion, so that's just multiplying by 2 from, I'm guessing RBX has a character count. Load string W. And this is coming from RCX. So RCX is completely busted. And RCX is coming from EAX, which is coming from this idiv, which is sourced by RSI plus 18. Let's take a look at RSI. Check for scroll buttons. RSI. This is RCX. It's the first arg to this 2-line display. Let's take a look at where this gets called. Get window long pointer. Fresh list. It's high contrast on. I'm guessing this issue is probably from, and are we in display event? No. Yeah, we are. I just want to check out the shapes of the objects when we go up here. Let's see if we can get up there. We'll just rewind 1,000 instructions, and then we're gonna put a breakpoint on this plus this. We'll continue up to that point. Oops. What's going on here? That started a new case. Okay, display event. Okay. Let's take a look at DPS. Actually, we want to go forward a couple instructions. P, DPS RCX. So we don't quite know what this structure is supposed to look like. And I don't think, yeah, we don't have private symbols. So this structure, L100. Okay, let's see if RDX looks interesting. So this has pi in it. So this looks like some sort of a string. So the second argument to this looks to be, why does this think it's an int? Oh, it's a pointer to an instant 16, and I'm guessing is R8 the length. R8 could be a length in this case. Let's take a look. Let's assume R8 is a length. Let's see where it gets passed to. R8 gets clobbered, goes into EBP, so we know it's a D word. It's stored here. We subtract 2. If it's 0, then we go to get dialog item. That definitely looks like a length field. So I don't know if it's length in characters or in bytes, but given it was compared to 2 up here. Oh, actually, that subs 2. This subs 1. Given this only subtracted 1, it's probably a length in bytes. I guess it could be a length in characters. Let me see. Where was that at? That was an EBP, I think. EBP, where's that used? Doop, doop, doop. Compare it with 2. Compare it with 4. When I see even numbers like that a lot, I always just kind of assume, well, here I see an odd number. Okay, so then it's a character count. If I see odd numbers, it's a character count. There we're subtracting that. Let's see where we use that, though. Pop it at the end. It's used to, like... Oh, you know what? Maybe it isn't a length. I don't think it is a length. Mainly because I think it's actually a mode here. I think it's some sort of a mode control, and it changes kind of the behavior of this function. Because if we look at... If we see a strlen on the second arg, which is going to be an R8, or RCX RDX, there it tests it. It's going to clobber it shortly. Compare dref that. This is comparing jump 0. This is doing strlen right here. So if they're doing strlen, there's no way they're passing in a length. So here we have strlen. This is going to update RDX by 2. So this is doing a character at a time. It's looking for a null character. So for people who aren't familiar with x86 assembly, I'll show you why this is a strlen. I mean, yeah, we don't need this output window. We can go into immersion mode here. There we go. Now we're in immersion mode. Effectively, we know that RDX, which is the second argument in 64-bit Windows calling conventions, we know it points to a string, and we know it points to a UTF-16 string. So each character is 2 bytes. This gets stored in R13 for later use. That allows the compiler to reuse RDX. So what this is going to do is it's going to see if RDX is null. So if it's a null pointer, it's going to go down here. It's going to load this into RBX. It's going to set this error code, and I guarantee you it's going to return to the end of the function. Yeah. So this is basically setting an H result value to this. If we did a quick Google for this code, we'd find it's probably like, yep, parameters incorrect. So basically, if you pass in a null pointer for the string argument, it will return out with parameters incorrect. If we take a look at what it does in the other case of if it's non-null, it's going to go through here. It's going to save this. Wow, really? So, holy shit. Well, that might be the bug. Or one of the bugs. So here it's going to take this value here, which is probably like max length or something. It's going to put this into ECX. And ECX it's going to use as a loop counter. So if we take a look, R8D is a constant value. It's loaded into ECX. So at this point, ECX is constant. It's going to take EDI, which is XORed. So the compiler has zeroed out EDI, and it's basically using this move to zero out EAX. And once we've gotten to that point, EAX, in this case, is not used in this loop, so we're going to ignore it. So we've got EDI, which is 0, so we remember that EDI is 0 from above, and it still is. It's going to compare the dereft value at RDX, which is a pointer to the string. It's going to see if the pointer to the string is equal to 0. And in this case, it's a word comparison since DI is a 16-bit register. So this is saying, is the 16-bit value pointed to by RDX equal to 0? If it is, it goes to this point of the loop. In the other case, which it's not 0, it's going to add RDX2, so it's going to advance it by 2 bytes, which is the amount of bytes that it just checked. It's going to subtract from RCX, it's going to subtract 1, which RCX, if we look above, RCX came from R8D, which is this constant. So if you look at that, it subtracts 1 from that. Then, if this value is non-zero, so basically if the result of this subtraction, so it's going to take, let's say the first iteration of the loop, it'll take C350, subtract 1 from it, and then it will say, is the result of that, which will be C34F, is C34F equal to 0? No, it is not. It is non-zero. Thus, we're going to take the branch, which will loop us back up. So it's going to go through, and it's going to advance through the string until either we hit a null character or we've exhausted this many characters from the string. So this value here will probably have some significance if we pop it up in calculator. If we take a look at this, it's exactly 50,000. So basically, this will go through and it will try and get the length of this string. It will try and find the null terminator up to 50,000 characters. And you can tell a human wrote this, right? Machines don't make decimal values. A human definitely made a decision in the past to set this as the threshold. Once that loop completes, it'll compare RCX with 0. If it's non-zero, it will go down this path. If it is 0, it's going to do invalid parameter. So basically, if RCX ended up hitting 0, which can only happen if this many characters were read, so 50,000 characters, then it's going to say, no, invalid parameter, and that's going to return out. In the other case, which is if this is non-zero, which is the true branch, what we're going to do is we're going to take R8, which if we remember was this 50,000 value. It's going to take R8, and it's going to subtract from 50,000 RCX, which is the count. So at this point, RBX now has the length of the input string in characters. And if we were to look, so what we could do is we could put a breakpoint on this location in our actual application. So we'll put a breakpoint on win32 calc plus this, continue until we hit that. So if we take a look, we know that RDX has been saved, so R13 points to the original string. So R13, this has 314159, it has pi in it, and if we look how many characters it has, so each of these is going to be 16 characters, but since they're double, this is actually 16 up to here, 17, 18 characters, and then the null terminator. So if we look at the math that's about to be performed, we're about to take the value in R8, move it into RBX. Looks good. And then we're going to perform a subtraction of RBX, which is the C350, and we're going to subtract off RCX, which is the remaining part of that. And the result is that we get a 12. And 12 printf 12 hex is equal to 18 decimal, and that is exactly the length of the input string. So that's effectively, this is why, like, doing reversing is important rather than reading, like, books, because I immediately knew, like, what this whole function, or this section of the function was doing by just seeing it. Like, you see it, you see this, you see it compare with 0, you see a couple increments and decrements, and you're just like, it's a Sterling. And this is not something unique to me. So many people have this skill, and a lot of it is just being very comfortable, like, seeing these patterns over and over, because what happens is you reverse this out, like, 100 times when you're learning reversing, and eventually you get sick of it. Like, eventually you're like, shit, I've reversed this out so many times. You just know the shapes. You see tight loops like this. Basically, if I see a tight loop with a compare against 0 and an advancing pointer, I just assume it's a Sterling. That's not always the case. But yeah, once you get used to these sorts of things, it allows you to kind of look at it at a high level. And I can say, like, This is doing some, this is doing strlen. Then down here, this is making a copy of a string. So it's allocating, it's going to allocate room for the string. It's going to copy it in there. It's going to see if the allocation failed. Here, it's going to check if there's a space, probably at the end of the string. It's going to, let's see. Here's switching on, actually, R15. We don't know what R15 is. It's kind of tough because we don't know what, like, the this objects are. I'm guessing this is actually, let's see, dialog item, checking accessibility, font stuff, window text, dynamic font. I think this is literally moving something, like update the two-line display. I think this is literally doing the rendering of something. So we gave it a string that needs to be rendered, and it's gonna update that in the I guess the like the history. The two-line display. I don't necessarily know what the two-line display is, but we could go and try and figure it out. So if we open up WinBag, we're going to just start a calc instance. We're going to attach this calc instance, take a little look-see. Here we go. And we're going to set a breakpoint on basically that same location that we just did. So we'll take... Where was it? Here. We'll set a breakpoint at this location. Continue, and then I think we're going to need to get something in the history view. We actually just hit it. So if we take a look at what string this has, if where is this at? It was in like R9. No. The string is in R13. So here we see it's going to put a 5 in there. So we could change this. We could do like an EB this and set like a 4100, 4200. So an AB, edit byte. And now we can see if that shows up in the display. And there it is. So we have AB has shown up in this like two-line display. So now we know that this is what the application considers the quote-unquote two-line display. Do you have an opinion on Ida's graph layout versus Ghidра's graph layout? Yes. Oh my god, Ghidра's graph layout is unusable. I mean, I haven't used Ghidra in like 5 months, but the last time I used the Ghidra graph layout, it was it was unusable. So I don't know that. The Ida graph layout is like the standard. It's like it's the defining standard for what any reverse engineering tool needs to set as their graph layout. So Binary Ninja has a pretty good graph layout. If you haven't used Binary Ninja, I can just throw calc in here. We'll look at the same function in Binary Ninja so you can kind of see how they compare side by side. Come on, I'm getting UAC'd. Sorry. I know you get a flicker every UAC. It sucks. I guess it's healthy, so you don't end up getting completely dumpstered when you're doing some weird stuff with UAC there. Windows System32 Win32 calc.exe. Whack that into Binja, and let's see if I can get symbols up in here. I actually never really used Binja. I just bought Binja like 2 weeks ago because I needed it for my for some of my own work. I have a way to like view my IL, my Fulk IL in here, which is really nice. And PDB load. Let's see if we can get this PDB in here. Okay, looks like that PDB loaded. All right, so if we go to the same location in here, I don't know if I can do Win32 calc plus 5. Can I do that in this? I don't know if I can. Where did it load this at? Or we can just look for this update two-line display. So get us ballpark. Oops. Invalid expression. Really? Let me open the somewhere there's got to be a list, symbol list. layout, reset window layout. Here we go. So I can search for this. Here's the update 2-line display. And here we can see it lays out slightly differently. And there are different themes that Binja has. I don't actually like the theme that I currently have set here. But kind of side by side, IDA has like a little bit better stack variable naming reconstruction that I've noticed. Binja's getting a lot better over time, but I don't like that Binja doesn't allow you to like pan arbitrarily. That's one thing I really like about IDA. I like looking at whatever's in the center of the screen, and in Binja you can't like center some arbitrary thing because it basically bounds the graph to the extremes of the graph. Yeah, the feature map. Yeah, the feature maps are really cool. You can kind of go through and it will show you like the different, like basically where code versus data is. And it gives you a little bit of an idea of like where entropy kind of in the application is. So this is really cool. I like this a lot. But nevertheless, I'm not too comfortable in Binja yet, so I don't want to spend too much time in there. That's obviously something that I should eventually learn. Hey, 41 viewers. Woo! Hex41. That's a celebratory number right there. All right. So PogChamp indeed. Let's get some A's going for that. Man, I can't wait until I can make some Twitch emotes. That's gonna be fun. I'll definitely get some A's or something. Some good pop, like a pop calc, maybe like the calculator icon. There's a bunch of fun stuff I could do. Real hacker. Oh yeah, we're hacking. We're getting into the mainframe. One second. Hacker typer. Come on. Why is this an insecure page? It's a hacking page. All right, we're in. Oh, groups Alec. Oh, we're doing a K-Malik. Yeah, I'm just going to set up my groups and block size. Let me quickly, yeah. Yeah, we definitely want to export that symbol. We need a way of freeing the groups. I'll put that in really fast. Yep, we need to convert the groups to the user ID. Okay, let's see if we can get that going. Copy from user. Oh, got grabbing stuff from userland. We're hacking. You're literally disgusting. Oh, Skyper15, thank you for following. Welcome to the stream. Just doing some fun, playing around with IDA, doing a little bit of reversing. You know, maybe it's time to settle in and reverse out one of these bugs specifically. Let's do that. I don't know. These crashes are pretty good. I do like the page heap ones a little bit more. Page heap just gives you a little bit better information, so we're gonna spin those up quick. Here we go. We'll kill all the workers, and we'll switch over to using calc stepped, which is the page heap enabled variant, and then here we're just gonna switch back to the page heap CR3, and I think that's all we have to do, and we'll deploy these out to the servers. So if you're new to the stream, we're fuzzing the calculator application, the standard old calculator that comes with Windows, that used to come with Windows. Now it's been replaced with a new fancier calculator. But we're fuzzing it. We're trying to find bugs. We're trying to find different ways that it crashes. Ultimately, we want to find some like exploitable bugs that allow us to get control in calculator. So this is a system level fuzzer that allows us to basically take a, we're running, waiting for these workers to come online, but we're running 320 VMs here. I'm gonna kill these quick and I'll bring them back online. So basically we've spun up 320 Windows VMs, which have the calculator application up and running. And what we're doing is we're running kind of random inputs through there. So if I go into, I can kind of show you approximately what's going on in these 300 VMs, which we can't visualize. So if we look at Twitch fuzz calc, we have this, actually just GUI fuzz probably is fine. Ah, what do you mean? Oh, did we turn that into a library? Yeah, we did. Typical us. Inject ID live repro, cargo run. So effectively what we're doing to calculator is we're just generating a bunch of random key presses and keystrokes and interactions with the hopes that we get a crash. And we get a lot of crashes. So that was an example of a crash on a live system. This is just a null deref, which means it's the processor is trying to read the memory at the 0th address, which is not mapped in. Really common thing to do whenever you see like nulls in C and C++, null derefs are almost bound to always happen. So that's kind of what we're doing right now, but we're doing it on 320 VMs in a server running in the other room, and all the crashes get saved to this directory, which we're kind of watching to see all the different ways things can crash. So I need to take one quick break because I need to stir some rice, put something in the oven, and I'll be back in 2 minutes. I will be right back.
October 21st, 1975. Jesus Christ, you know the fucking day? Oh, yeah. Day of the game. We're sitting in a bar waiting for the game to start. In walks this girl.
All right. Anything fun happen when I was gone? Woo, there's some crashes. Looking good. Whoop. Okay. I had a pro license giveaway at 50 viewers. Woo. Woo. Ah. My 8 grand spleen is exploding. It is so expensive, especially with their new licensing policy. Yeah, it's brutal. It's brutal. I haven't renewed this year. I'm probably gonna do a leap year. You used to be best off renewing every other year. You'd save money, but they actually changed it. So now it's like if you renew every 3 years or more, you save money, which kind of sucks. Is that Linux source code? Yeah, in the hacker typer it is just Linux source, which is really really fun because I recognize like half the code in hacker typer. Okay. Why don't I stream in Scientech? It's just kind of like a dead category. And I want to be a little bit more interactive. Like, the goal of these streams is for people to ask questions about computers or assembly or how things work, reversing security, getting jobs, like all these things. So I think just chatting makes more sense. The hacking and bugs is just a medium for conversation. It's just a little popcorn kernel to explode into a good conversation and questions. Because security is honestly a really hard field to get questions in if you don't know the right people to ask. And luckily, I know a lot of the right people, and I know a lot of the right answers, and I'd love to answer those questions that people have. Recommendation system on Twitch is getting better. Yeah, I've noticed that as well. Don't have to worry about as much when choosing the category. Yeah, totally. Is there a recap somewhere? No, I haven't found a good way to do recap stuff yet. I have to kind of learn how that works. Like, I have Adobe Premiere Pro, but I haven't edited videos since I was like, I don't know, making skate videos when I was 12. and those weren't necessarily the highest quality videos. I can tell you that for sure. It's like literally everything in slow-mo, 5x slow-mo on every trick, and it's like a kickflip. It's like a kickflip that takes 25 seconds to watch. Pretty painful. So, man, I wish I had those videos. That really sucks. Okay, so how do you get your coverage? I think I saw that. Yeah. How did you add coverage? So the coverage that I get, so we've done a couple things during this like stream. So not specifically this stream, but this like theme. So we've been doing calc fuzzing for a while. There are two different ways that I've done coverage in the calc fuzzing stuff. There's one tool that I use called Mesos. And it is meant for Windows binary code coverage. It's pretty simple. All you need is like IDA or Geeja or Binja, and you load up your application, and this will find where all of the blocks are, and it will apply a breakpoint to every single block in the application, and it'll allow you to see when those breakpoints have been hit, and then they get removed once they've been hit. So the coverage is actually really cheap in Mesos. It takes like 1 second to apply all the breakpoints, actually less than that. And here's a link to it just in case you're interested. But yeah, it's a really easy way of gathering coverage on Windows that works on binaries, and it has almost no performance overhead because once the breakpoints are removed, nothing happens when you hit that code again. So we wrote an initial fuzzer using Mesos. In fact, I think I open sourced the fuzzer that we wrote somewhere in here. Calc. GUI fuzz. So I kind of open sourced this. There's no information on how to use it, but it's an application that uses Mesos to do some coverage and feedback and all these things to fuzz GUI applications. Really simple. We developed all this on stream. But since then, we've actually switched over to using a tool called TKO Fuzz, which is not yet public. Plan to open source it eventually, hopefully Q1 next year. I don't know. I'm not setting any deadlines on myself or the team. That's just right for making a less fun dev environment. So basically, TKO Fuzz allows us to scale out. First of all, it allows network fuzzing. So in this case, I'm actually fuzzing on 320 cores on 2 different servers, and these have just connected in, and they're restoring back from a snapshot. And the snapshot is basically a whole VM. So we have a whole VM running calc.exe. We've loaded up calc. It's displayed on the screen. And then we take a snapshot explicitly at the time that snapshot occurred. And that allows us to resume execution right away and start fuzzing. And then once we find a crash or we timeout or something happens that we don't like, we can immediately terminate the fuzz case and go right back into starting a new fuzz case again. And that's what you're seeing kind of on the screen with these prints. This is showing kind of status of all of the workers that are connected in. We have 320 cores up and running. We have the uptime, the number of unique blocks of coverage, which is system-wide, so that includes kernel and userland. We have the number of inputs, so the number of unique fuzz inputs that cause interesting cases to occur. We have the number of fuzz cases, which we're doing about 1 a second right now. Yes, it's really slow, but we're running with 60-second timeouts on these VMs, so I'm pretty happy with that. And then we have the millions of instructions per second. In this case, we're emulating 450 million instructions per second, which is pretty slow, but we're using Box, which is a full system emulator that's meant to be accurate rather than fast. And with all of this, we get full determinism, all of our bugs repro, and that's what is awesome about this tool, is basically that repro ability. Any bug we ever find in here, we can always go back. And further, with this tool, we actually have time travel debugging, so we can go backwards in time. So I can say, I want to rewind 5 instructions, and it goes back 5 instructions. I could rewind 10,000 instructions, and it will keep going back. Obviously, if I have breakpoints, it won't. But I can go back and see wherever I want to be, and maybe I can end up in the kernel. Who knows where I end up? I can go back and forward in time, which is really cool. Actually, just backwards in time right now. Forwards in time, you can just continue execution. Okay, what keyboard are you using? I am using a DOS keyboard from about 2012. I think DOS Keyboard still makes keyboards. I bought one maybe 3 years ago or something like that. Actually, I might have had this keyboard for longer than that. But it's got Cherry MX Blues, just a standard keyboard layout, nothing fancy. I don't like fancy keyboards. I like good switches and a standard PC keyboard layout with a number pad. Any reason why you don't use Ghidra anymore? I remember you tried it extensively when it was first released. I'm just more comfortable in IDA. I've been using IDA for 12 plus years, and I've been using Ghidra for 6 months. Or whenever it came out, maybe 8 months now, and I haven't used it too extensively, so I just prefer IDA. I think the graph layout's better, and that's kind of the way that I normally look at code. If I'm looking at x86, I'm usually looking at it in assembly. I actually don't like to decompile my x86. I can read the assembly usually better than I can read the shitty decompiled outputs. For things like ARM or MIPS or things that are risky, the decompiled output is really nice, so I would probably use Ghidra in those cases, although I have the decompilers for IDA as well. Are you using any third-party Rust crates? So far, I haven't seen any. No, I do not. I don't really ever use third-party code. It's just let's say a personality flaw of mine that I usually like to control pretty much all of the code that I'm running. Allows me to tweak it, allows me to blame myself when bugs happen, and allows me to usually fix issues a little bit faster when I see them. And ultimately, it allows me to write much higher performance code because I'm not relying on someone else's performance for my own. Are there any that help you for this kind of work? I don't know, but I can guarantee you, yes, there are probably many tools out there. There's things like Unicorn. I think Unicorn does have Rust bindings. That allows you to use QEMU kind of programmatically, which is useful for fuzzing and repro and triage and so many different things, which is nice. I missed the name of that tool. How do you make snapshot and revert on crash? Is it one of the tools I wrote? Yes. So this tool, TKO Fuzz, is a tool that this unicorn, malware unicorn, not quite. The unicorn that we're looking for is QEMU unicorn. This will probably get you in the ballpark. Unicornengine.org is what you'll want for that. It is just like a program. It's basically built on top of QEMU, or at least it used to be. I think they're developing more and more away from there. And it just allows you to emulate CPUs. It doesn't really allow you to emulate systems. It's more designed for you give it a bunch of bytes, you set some register states, and then you can continue. what we have here with TKO fuzz is basically Unicorn, but for full systems and hypervisors. So I expect when this goes public, it will be probably just as well known as Unicorn is. So I'm actually really excited about that, and the whole team is. So it's, I don't know, I've never worked on a large tool before. Most of the stuff I work on is only for personal use. This is one of the first tools I've ever developed in my life for other people. Is it like Intel Pin? At a very, 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 very high level, they're similar, but at a low level, they're not even close. They're quite different. All right, so let's take a look at our good old new crashes that have come in. In fact, I think I just, yep. Okay. We've got the out of bounds axes, so we've got the completely jump out of bounds axis, so we know that this is reading out of bounds. This one, and I think if we take a look, we'll probably get to see whether or not these would cause stack corruption, and I think they might. So I just want to hop back in one of these because I want to see what the stack trace looks like again. Okay, so we'll start up KD here. And then we'll pull up this connection here. Oops. Restart the KD session. Switch over to this new crash. And we're going to go through and we're going to repro this, this bug that we found. So this is going to allow us to connect up to a debugger. Have to change the file name here. Calc stepped. So, oh, really? Calc stepped, yep, definitely want that. And then this one we need to change. Changed it in the wrong spot. So this will attach, or this will connect up to a kernel debugger, KD here. And then this is going to allow us to continue, and it will break in once we've hit our crashing condition, which is relatively soon in this fuzz case. Unicorn is a good tool, but obviously with limitations. Yep, yeah, Unicorn's fantastic. I haven't used it much, mainly because I have a lot of tools that are kind of a superset of what Unicorn does, but Unicorn I wish was more widely used, in fact. Even though it is pretty widely used, a lot of fuzzing out there that's done is a lot worse than what could be done. Okay, so in this case, we are in, we'll reload to get some symbols in here. What's the debugger you're using exactly? Is it a plugin for a WinBug with rewind capabilities? Yeah. So it's basically just, this is KD. If you've never actually seen KD, KD is WinBag. So this is basically command line only. It's typically what I use. I usually don't use the GUI for WinBag. I just want the commands. So what we've done is we've loaded up an extra extension here, this keyframe.dll, which has given us some enlightenment so we can, you know, go backwards and forwards in time. So I can go like rewind one instruction in this case, which will go back one instruction, and I can now go forward one instruction, and I'm back to where I was. So yeah, it's just basically KD with rewind capabilities. So this work you're doing, why does it require so many resources when it's just a calculator application? Oh, it definitely doesn't require this many resources. I just have this many resources. You could do this with one core, no problem. We're just throwing our cores at it because we have them. Why not? It's basically free. It's wasted hardware if we're not using it. How does this differ from the time travel stuff they added recently? It's quite a bit different. So the standard time travel debugging that WinBag has is actually, it only supports, well, you can go forwards and backwards in time, but it's not mutable. And when I say not mutable, I mean that you can't go backwards in time, change a register, and then continue to see what happens, where we can do that with this tool. And further, time travel debugging does not support system level fuzzing at all. You can't use it in kernels. You can't use it across system call boundaries. You can only use it for userland applications. So this doesn't have any of those limitations. You can in fact use this for debugging hypervisors. So you can time travel debug between VMs and all kinds of context switches. So this is kind of just a superset for time travel debugging. And it's actually caused, there's some work on time travel debugging going on to get it to work in the kernel. And this project actually has caused that work to basically stop, which sucks because that work should eventually happen. And I'm sure someone's still maybe poking on it here and there. But when they saw this tool, they're like, oh, maybe the problem's already solved. So, yeah. All right, let's take a look at our call stack here. We're in check for scroll buttons. And in this case, we're being passed a string, which could be up to 50,000 characters in length. We're going to check an IDA if that constraint has been limited. So we're going to say that RCX, at this point, we're going to compute in RBX the length of the string. And we're going to do a conditional move. Okay, so that makes sense. This is just basically what this is doing is it's saying if EAX is signed, so basically if it's an error, then we're going to overwrite RBX with RDI, and then we're going to jump out of there. Otherwise, we're going to come through, and RBX is going to be the length of the string in characters. Here it's going to compute the length of the string in characters, including the null byte. It's going to multiply it by 2 in this case, and then it's going to call new on this. So it's basically going to get the length in characters, which are wide characters. It's then going to multiply that by 2 to get the length in bytes. It's going to call an allocation on there, and then it's going to copy, apparently with a 50K length limit, which is kind of weird. So then if we come down here, let's see what it does. So it's going to make a copy of that string. I don't necessarily know why it's making a copy. Let's take a look at the API for this function. I'm guessing it's just a source and destination. In the middle is the length. So the destination is the first one. So this is similar to like a mem copy. So this is going to be copying into RAX or RCX, which is RAX, which is what was just allocated. So it's going to allocate a new string. It's going to then copy into that string. And then if this fails, we're going to return out with an error. Whoa. Whoa. It's going to free that even if it fails. Oh, that makes sense because it already allocated. So it's going to allocate and then it's going to free it. R14 now contains a pointer to our a copy of our buffer, exactly with null terminator included. Why didn't the compiler implement this multiply by 2 with a shift? This one here. It's hard to say in this case. It probably should have. Let's see. I don't think potentially it wants some flags from the multiply. Yeah, it wants the overflow flag on the multiply, which I guess you would get with the carry flag on a shift. Actually, you can't get that overflow on a shift, because if you shift it by, well, shifting it by 1, you can actually get it. So yeah, this should have been a shift. Keep in mind, multiplies are actually really cheap on modern hardware. This will be about 4 to 6 cycles instead of, obviously it's a half a cycle for a shift. So a shift should have been used here. I'm not sure if they're getting anything out of it here. Yeah, I'm not quite sure. It's hard to say. It seems to be a mistake, but there could be something subtle here we're missing. It's not using RDX as the result at all. So I'm not quite sure. So then we have R14 now contains a pointer to our magic string. Here we're going to test RBX if it's 0. RBX was the length of the string in characters. So here we're going to check if the last character is a space. If it is, we're going to subtract 1 from RBX, and then we're going to 0 out the last thing. So we're going to delete up to a single trailing space from our buffer. Then we're going to compare R15. This is like some state stuff, so I don't know what it is yet. But we really just care about here. We're going to go into check for scroll buttons. We're going to pass a this pointer in. We're going to pass our null terminated string into here, which can be up to 50,000 characters. Remember, this can be up to 50,000 characters. We're going to go into check for scroll buttons. And then in here, we're going to subtract 260 on the stack. I'm going to guess that it's probably... Oh, wow. Okay, so in RDX, this has a pointer to our string. We're going to put it into RBP. We're about to clobber RDX, so we don't need to worry about RDX anymore. We're now just tracing RBP. We're going to check if the input pointer was null. If it is, we're going to basically go to a failure case. I guess we're still going to do some stuff there. But if it's not null, we're going to get... here we're going to do another strlen of it, up to 50k. We now have the length in RBX, once again, exactly as before. And where do we actually get into that call? So RBX has the length in characters. We're going to extend point. Okay. I'm trying to find, here's where the WCS cat is. So, ooh. Okay. So RBX contains that. RBX has the length now. Okay. In all cases, RBX has conditional move signed. R15. R15 is probably going to be a null. Yeah, it is. So it's going to zero it out if some check failed, which is if EAX is 0. Basically, if there's an error up here, it will zero out the length. There hasn't been an error yet, so RBX contains the length of our string in characters. Here it's going to do a text extend point. I don't know exactly what that does. But down here is what matters. We're going to take the length of the string, and we're going to subtract off RCX. And then we're going to take R8, which is from RBP plus 2, which is one character into our input. So it's going to add, it's going to seek one character into our input buffer and put that in R8. It's going to then compute RBX times 2. This is going to get the last character. So it's going to concatenate the remaining part of the string. Oh, here it's going to subtract off RCX. And RCX is where the issues occur. So there it's zeroed out because it's a parameter. There it's a parameter. And then here, we're going to sign extend EAX, which is the rectangle's right position. That's kind of tough. Just got on. What bugs have I found so far? I got a lot of bugs. You can just search for star.crash. Here are all the different bugs that we have. So we have we have an out of bounds read here, which we're looking into right now. We're trying to figure out how that out of bounds read works. We've got some, what are these? I don't know if we know what these are yet. We haven't really looked into these yet. We've got a couple null DRFs. We have one that looks like it's just reading an invalid address. This is probably uninitialized memory, or probably a type confusion here. And then we have 2 uninitialized memory reads entirely here in these 2 spots. So these ones are pretty bad. But we don't really know all of the bad bugs yet. So these ones we've never seen before, so we're kind of looking into them. These ones we have hunches on what they are, and these ones we're trying to figure out. So effectively what happens here is it has the length, which is correct, and it subtracts off this RCX value, and RCX is way too big. In this case, RCX is sign extended from EAX, and EAX comes from the right rectangle. Which I think is probably going to get reused. So I'm just going to highlight this so we see where it is. Here we're going to load it. Compare this with EAX. If it's greater than that, go down here. Otherwise, we have a failure case. Rectangle right. It actually is a rectangle. What the hell is it doing? It is getting the right coordinate for a rectangle. I think what it's trying to do is it's trying to cut off the string. So basically, if the string is too long, it's probably trying to cut the string off to the bounds of a rectangle. And for some reason, the rectangle is like massive or negative in this case, probably more likely, which is causing it to copy way more than it needs to. In this case, it's copying to buffer, which is on the stack. And yeah, this is definitely a stack buffer overflow. I'll move EDI this. I guess we don't know if this can overflow or not. We need to see if somehow this gets checked. So RBX subtract RCX. RCX is coming from the rectangle right. Here we're getting the module handle. We're loading a string, which is getting, this is getting like a resource string based on an ID. Getting the right rectangle coordinate. We're getting one character into our string. We are sign extending CDQ, right? Yeah, that's sign extending a double word to a quad word. So it's taking EAX and sign extending it to EAX EDX such that it can do this div. Does the div. We get the size in words. Is that accurate? We're going to div by this, which, if I remember rightly, was 7. And I don't know where that 7 is coming from. We can take a peek at RSI, see where this is used. This is RSI plus 18 hex. At RSI plus 10, gets a window handle from there. We don't actually know what's at RSI plus 18. Could be uninitialized stuff. We have no idea. Who knows? But yeah, effectively, the length of this buffer is getting screwed up, which is causing us to jump way into a length. Oh, I need to check on some food. I will be right back. Just need to check the temp on the food in the oven.
That's really unique, Faye. That a mugshot or your version of Picasso?
What is up? I got my food here. Ready to party. Thank you, ModMust50, for following. Welcome to the party. Okay, so I need to figure out why this RCX value is so negative. Let's try and go back and let's find this instruction before the lid string. Or rewind like 50 instructions. Oh, now we're in load string. Nice, load string's about to return, and now we're here. Man, we called that. We were pretty close with our instruction count there. So, oh my god, this food looks so good. Okay. Oh, it's hot. Fuck. My bad. Okay. So, here I want to see what is in this RSP plus 30. And that is 0. The rectangle right is 0. Is that the problem? Is that? Oh, yeah, not. Is it RSP plus 30? That's what it comes out to be? We step past there, we end up with, yep, 0 in racks. We sign extend EAX into that, so now EAX and EDX are both 0. We div by 7, which will cause us to get a 0. Then we're gonna do a sign extend that, and then we're gonna sub RBX by RCX, which is 0. We're gonna get a pointer to the stack buffer that we're gonna copy to. Then we're gonna get a pointer to the end of the string. Oops. Yeah, this is where it's like completely busted. Why is it copying from the end of the string? Yeah, something's broken there. So it's basically getting a pointer to the end of the string and then it's copying from there, which makes no sense in almost any situation. So I think this sub was supposed to subtract something off. For some reason, the right side of this rectangle was 0. So if we went back up, let's see if we can find where we were. Oh, now we're in the kernel. We'll go back like 10k instructions. We'll put a breakpoint on get client rect. Hopefully we can do this. Come on. There's a chance that this breakpoint didn't resolve. It's not a big deal if it didn't. Okay, yeah. Yeah, the breakpoint didn't resolve for some reason. I'm not 100% sure why. It's kind of strange. Okay. So, get client rect. We want like a breakpoint here. And I think our breakpoints are a little bit broken with our time travel debugging stuff. So we'll rewind 10,000 instructions. Go back a bit more. Might need to go back like a boatload. And we'll put breakpoint on win32 calc plus this. Okay, now we hit this. So this is right after the return of get client rectangle, right? Yep. So if we take a look at the client rectangle, which is at whatever was an RDX, and RDX is at RSP plus 28. So this should have the rectangles. In fact, are these words? I think they are words. Actually, we can do DT rect RSP plus 28. Oh, really? Surely we have a symbol for that. But I think they are MSDN. Oh, actually, wow, I'm surprised that's so high up. 4 longs? Really? Okay. Let's double check. Get client rect is the same one. This returns a rectangle. Okay, yep, that is the one. So this is the rectangle. Apparently the left, top, bottom, or top, right, and bottom. And what this is trying to do is it's trying to get the, oops, we'll go back into the graph view. It's getting the right coordinate of it and trying to subtract that off. Yeah, this is really busted. I don't know how this rectangle is getting set to this size. It's probably because we're setting the size of the field by setting the text on it, and that's causing it to then copy out of bounds into that rectangle. So that's a little bit busted. All right, I'm gonna take a quick 5-minute break to eat, and then I'll be back, and we'll take a look at one of these C0 bugs and see if we can figure out what's going on there.
Lemonade was a popular drink and it still is. I get more props and stunts than Bruce Willis.
All right. Welcome back. So, I only have like another 30 minutes that I'll probably stream here. I do want to get to sleep before 8, which is going to be tough at this point, but, you know, we'll see what we can do. All right, let's take a look at our crashes. Everything looks the same in MSVCRT. We have a bunch of these different read users. Let's go check out what these look like. I don't think these are going to be anything too fancy. We're probably not gonna be happy with these crashes, but never hurts to know what you have in your toolbox of crashes. Here we go. All right, let's get this repro'd. See what we're looking at. Come on. Oh, long repro. There we go. Reload. This one looks interesting. DBRCX. This is actually in kind of a similar spot. So this isn't like RCX plus 2C8. Yeah, it looks out of bounds. I think this one we've determined is likely a type confusion. Where it's probably has like a this pointer to whatever this is, programmer mode, or it probably has a this pointer to like a stats mode, and then it tries to use a programmer mode operation on it. This one actually looks relatively interesting. Let's see what it's about to do. So it's about to deref this, which is invalid, and then we're gonna put that in EAX. We're actually gonna pop this one up in IDA. We'll grab this address, throw it in IDA. Okay, so this is where we currently are. This 2C8, we're dereffing a D word. Whenever I see a D word, I assume that we can't get too much control over this. And it looks like normalize current bit. And this returns... Gets a word length container. So it's just getting a field in here. If it's not signed, we go here. If it is signed, so if the top bit is set, then we're gonna go into here and we're gonna update. Otherwise, we're gonna go here, F1F 3F. This is something with the in calculator. You have like these bits, here. And if we see these numbers, these will line up 63, 31, and 15. And these must be normalizing for these. So 63, 31, 15. There's probably an 8 in here too. Maybe. This one's LEA of RDX plus 6. In this case, RDX is equal to... in this case, EDX is equal to 1, so it adds 6, so this is 7. So while it doesn't look like 7, this is actually loading 7 into R8D, so we have the 7 path, the 15 path for words, the 31 path for D words, and the 63 path for quad words. So it looks like it's grabbing that, and then it's going to basically update this field with the current bit mode. So in this case, it's going to zero it out on an error. In this case, it's going to update it. So this field basically... What's interesting is this is actually about to do a write to that field. So if this field... Shit. We might be able to get a write out of this. If... Well, that's pretty cool. Basically, if the value pointed to by this field, which let's say is a type confusion, or like out of bounds of some relevant amount, then we're going to load it. If that is signed, then it's going to write out a value. So we could potentially be able to write a 7, 15, 31, or 63 as a D word to memory that we're not supposed to write it to. That's pretty interesting. Okay, that's pretty cool. And then in this case, we could write a 0. So if this is indeed a type confusion, let's see if we can get this bug to repro live. If we can get this to repro live, we can try to see if there's any way that we can coerce this into writing a value to a location it's not supposed to, because that could open up a whole can of worms right there. Even if it's not a huge amount of corruption, overwriting something, if anything, is always gonna open up room for more bugs. Were you fuzzing syscalls? Nope, just calc itself. Yep, we're sending random like key presses and random mouse movements to calc. If I understood correctly, TKO Fuzz is a plugin for KD. Nope, TKO Fuzz is a pretty large project on its own. We just use KD because it already exists as a debugger. I mean, technically, for Linux, we'll use GDB with that as well. So we're using KD just because it's friendly with what we with Windows. I mean, KD is the best debugger out there for all targets. In fact, it's just such a good debugger. Okay, so this bug that we're reproing, let's just grab the file name. We're in calc step crashes here. We'll take this stream. We're gonna see if we can live repro this. Source main. We gotta uncomment all of this stuff out. We kind of hacked up this application temporarily to remove, or to try some fuzzing stuff. And in this case, we'll just send the command. I think that's all we need to do. Looks good. Delete the red keys, and we'll do cargo run /dev Franzia runners this, and commands for command in commands. So we'll see if this will repro it live. Come on. Oh, you know what? This is not doing the same operations. We actually need to make a copy of gvim / inject id sequence. I think we probably already have that open. Yeah. So here we need to do this exact same logic. Boop. Okay. So this should be doing the same thing that we're doing up here. Window attached calculator, looks good. Okay. So this now should hopefully do all those events. Let's, this is not working for some reason. Print using command this. Command. Let's see what's going on here. What is 5556? Maybe it's because we're popping up windbag. Let's do it without popping up windbag here. So we'll just comment out these. Start up a calc. I'm gonna resize this a couple times. Getting a little glitchy on me. Okay. So the 5555 commands have some sleeps in there. So I don't know if this bug will repro in this state. It's kind of hard to say. Sometimes it can be very difficult to reproduce bugs. Well, speak of the devil, there it is. The command bang rewind is something I wrote. Yes, the rewind command in KD is an extension I wrote. Okay, here we go. We've got the RCX plus 2C8. Obviously, that's corrupt. RCX itself should be valid. If we look at DPS RCX, we should see the VF table statistics mode, and there we go. We are operating on the statistics mode. This object, but we're in a programmer mode function. So exactly what is happening here is some form of type confusion. And effectively, this type confusion is causing us to write to a field out of bounds of the standard statistics mode structure size. If we do a vprot on, or actually a heap PA on RCX, this will tell us the size of this heap allocation. It's 220 hex bytes. And it was allocated in this change mode layout stats mode. So basically, this is probably switching the calculator into statistics mode. And then what we're doing is somehow we are doing some bit operations on the calculator mode window, which is going 2C8 bytes out of length. So if we were to look at the... actually, we don't know the length of the... If we hop in IDA, we'll be able to probably statically check out what this length is. Layout stats mode. Let's grab the... I'll grab the names window. Throw it over here on the side. Search for layout stats mode. And so layout stats mode, we'll see an allocation right here at the start of this 220. And then that's going to get stored probably in some global somewhere. So, okay. So the next thing we want to look at is if there's a layout programmer mode. Layout programmer mode. This will probably have a very similar shape. And here we'll probably see a new allocation. Come on. Programmer mode. Here we go. Here we have a new of 2E0 bytes. So we know that a new allocation in programmer mode is 2E0. In scientific mode, let's check out what that is. 310 in scientific mode. So in scientific mode, if we do a transition from scientific mode into this crash, we will probably end up writing a value into the scientific mode structure at that offset. So if we look at wherever we're crashing, we're writing at 2C8. So we can write a 0, a 1, a 7, a 15, a 31, or a 63 to the location. Actually, we can't write a 1, but to a location at 2C8 bytes on this structure. We can try and figure out where the structure comes from. But yeah, this is definitely a type confusion bug. And if we look at this, RAX, I just want to see kind of what's accessed in this. Oh, that's going to get saved pretty quickly to here. So we're going to pass this pointer to this scientific mode. So we know that it's allocating enough space on that structure. We know that that is allocating enough space for 310, so it probably does use these fields. Effectively, what we would want to do is we want to go to any function that is in C statistics mode. the odds that we get like any usable bug out of this is really low. But let's take a look. Statistics mode. We've got a destructor. Let's see if this accesses at 2C8. There's a good chance that there's just a string there or something that's not valid. So here's a 208 access. 208. We can also check dynamically by just looking at that structure. Let's try that. We're gonna put a breakpoint on the destructor of the statistics mode stuff, and let's make sure that this is usable. It's probably not. Okay. BC star. Okay, so we're gonna start a normal calculator window. Bring up calc, connect our debugger to it. Here we go. And what we're going to want to do is put a breakpoint on this function here. So we'll put a breakpoint on win32calc plus this offset. And what I should be able to do is when I leave statistics modes, this breakpoint should get hit because it's the destructor for statistics mode. There we go. We hit it. Everything worked exactly as expected. If we hit, let's say, move racks RSP. Okay, so RCX is going to contain the statistics mode structure. So if you look at RCX, we should see a stats mode structure, and this should be 310 bytes. If we look at this address, there we 220 bytes. Is that right? Layout stats. Layout stats mode. Oh, layout stats mode is 220 bytes. Okay, good. We're gonna hop back over into the destructor, and now what we can do is we know that we could. So this one we would write out of bounds of. So in if we go from statistics mode and send that command to cause the type confusion as the programmer mode, we will go out of bounds and we will write into memory in some random allocation. So what we're going to try and do is we're going to try and get this into stats mode. First, I'm going to try and minimize this down. So I'm going to try and do commands.len -10 ... and I'm going to see if we can reproduce this crash by replaying only the last 10 commands that we sent. And we just need to open a calculator window to start the process. Here we go. That did not work. Oh, see the tiny font there? That's kind of interesting. Okay, let's go back 20 commands. Actually, I should just print the commands to the screen because we actually don't know what count we're in. I don't think we need the sleeps for this repro. Okay, so what we're gonna do is we're gonna do this. We're gonna do a .enumerate using command ID this, and then this will be command ID. We'll be able to get another field here. All right. So now we'll get to see the sequence that we're in. I'm gonna get rid of the sleeps. I don't think these sleeps are necessary for this specific repro, and thus this will just speed up the process. We'll see if I'm right. Hey, looks good. Okay, so nice. So we were getting, I'm gonna rerun that. I need to make note of the command ID that we were on. Looks like 37 is the final one that caused the fault. So we know last command sent was 37. So now what we can do is we can try, so 38 will bookend this to include 37. And now what I can do is say, let's go 30 to 38 and see if that gets us the crash. Perfect. Okay, let's see if we can just do 37 to 38. Can we just do a single command? Is this a single command crasher? Beautiful. Yep. So this means that we will be able to switch the modes that we're in. So what we're going to want to do is we're going to want to send this 13D command. So when we attach the calculator, we're just going to hard code that we're going to send primary window dot send message ox13d. So this should reproduce the bug. It's not send message. I think I just call it command. Okay, so when I open calc, it should just crash. Boom, perfect. And this is crashing in that location that we expect. So if we do heap pa rcx, we're on a 220 byte allocation. Yeah, we can just put a breakpoint here. This is definitely gonna cause corruption on the heap. So now we're gonna want to put a breakpoint here. We're gonna start a new calculator instance under WinBag. This is at C Windows. Oops. Damn it. Windows System32 Win32 calc.exe. And yep, we want to turn page heap off. You're gonna get a flicker here when I go into UAC mode. Sorry about that. Gflags I Win32 calc.exe minus HPA. So we're gonna turn off page heap, and we'll have to restart calc. Now we don't have page heap. Gonna put a breakpoint here. I'm just making note of that command. And now we should execute that code. So we're gonna hit this, and if we take a look at heap pa rcx, we'll see that this is in an active heap allocation that was made in this, or has this VF table, I guess. So in statistics mode, we have this. We're accessing 2C8 bytes out of bounds. And if we look at what we're accessing, RCX plus 2C8, this is another allocation that is currently busy in the heap. And what we're about to do is, man, that's so fucking cool. I love bugs, dude. So we're 2C8 bytes. We're gonna step. We loaded EAX. In this case, or we didn't step yet. Now we have EAX contains this value, which is signed. So then we're gonna go down this path, and we are going to overwrite something that we do not control in this function, instead of putting which contains this pattern. And I think this is this memory is just free. Is that a? And then we're gonna do next. And if we look at RCX plus 2C8, we have written over someone else's memory with a 3F, the 64 bits, indicating that, or 63, indicating that we're in 64-bit programmer mode state. So that's pretty cool. So we know exactly what this bug does. It's basically a write, and now is the point where we should start kind of, when we root cause bugs, you should make notes of what you did, because you will always forget. So we'll make bug notes.md. Then in bug notes, we're gonna say programmer mode type confusion. And then we're gonna say in the this function, it is possible to, or let's say this function gets called when what command are we sending? We send a 13D command. This function will unconditionally access and write over a field at this plus OX27C bytes. We had that open in Katie. 2C8 bytes. Blah, blah, blah. So we're going to say this function gets called when a that command, okay, it'll unconditionally access and write over a field at that bytes. The value written can be a 1, 7, or a 0, a 7, 6, a 15, 31, or a 63 at the D word pointed to by this plus OX2C8. This means that when in a different programmer, in a different calculator mode, like stats, OX220 bytes, we can update a field. We can update a field out of bounds. For some other modes, like stats mode, update fields out of bounds. Okay, so here is the full list of modes that we can type confuse with. Okay. We'll just say full list of modes we can type confuse with. And we're going to say layout stats mode is a 220. And this is a... What object is this? Stats mode. C statistics mode. Okay. This C statistics mode, which is OX220 bytes. Writes, let's do the math here. 2C8 minus 220, A8. Writes A8 bytes out of bounds on the heap. Then we have layout standard mode. Standard mode is a where's the new at? Right here, 238 bytes. See standard mode. OX238 bytes. Writes whatever that is. A8 minus 18, which is 90 bytes out. I'm really bad at mental math. On the heap, it's something that I really should practice and stop deferring to calculators, because I could do a lot of these in my head. Okay, layout scientific mode. Scientific mode is 310 bytes, so this actually writes in bounds. C scientific. Oops, I can't spell. We'll just put that, and we'll copy pasta. Where is that at? We don't actually know if it's C scientific mode. Oh, it is. But I was just looking for an excuse so I didn't have to type it. Okay, we've got 310 bytes here. Writes inside the scientific mode structure. Okay, so we know that basically we can write 90 bytes out of bounds on the heap. We can write A8 bytes out of bounds on the heap. And basically, depending on the different heap grooming that we can do, we could potentially find some object or some combination of objects that would cause like a length field or something to be 90 hex bytes after this allocation in memory. Are you doing this professionally or as a hobby? I do this professionally. So, yeah, I've been doing this for about about 8 years professionally. So, I have a real job doing bug hunting. Okay, so these are the different things we can do. We can write inside of this. So what we should do is we should check out what is at this offset in the scientific mode. So this is, and we're gonna double do that. And I'm actually, do I have VS Code? I don't have VS Code. I will say there's one thing that VS Code is phenomenal at, and it is making markdown files. So I probably won't use it for code, but I will definitely use it for markdown. Come on. Probably gonna get UAC'd. Actually, this is a user app. Okay, add the path. We'll add a desktop icon too. Not that I use the desktop, but sometimes that helps the search indexer get a little bit better results in the start menu. So I've been starting to do that. Are we gonna at the Redmond campus? Yeah. Can I show an example of how offsets work? Absolutely. I'm just gonna get this, we're gonna get this code up and running. It's really taken a while for this last few 0%. Come on. Why does every progress bar get stuck here? Okay. Got VS Code. Okay. Oops. I want to close all the, I guess close folder, yeah. Close folder, get that fresh VS Code going. We're gonna open a folder. You know, I've never actually used this menu. I'm so used to just doing this that I don't think I've ever even used that menu. Where are we at? We want to do code on d:/dev or Twitch. There we go. Oh, it's not my path yet. Okay. Annoying. Twitch plus calc. Open this. Got all our projects. If we take a look at bug notes, which we have closed, we can now put the preview mode on, which is nice. And I think I have a spell checker. I do. Okay. Okay, so we got this. Boop, split. Get rid of the side window. Whoops, I split it. There we go. So this function gets called when a 1.3D command. This function will unconditionally access and write over a field at this plus 2C8 bytes. This value can be a 0, 7, 15, 31, 63. The words pointed to by this plus 2C8. This means when in a different calculator mode like stats mode, 220 hex bytes. Let's put that in. We can update a field out of bounds. And here's the full list, and we can actually do the correct table. What is it? Shit. I don't have the markdown for tables memorized. Son of a bitch. Markdown table. This is something that I really need to have memorized. I'm literally looking at the cheat sheet tables. Here we go. Copy pasta. Maybe if I didn't copy pasta that, I would remember it. Let's see if we can type it out now that we've seen it. This is going to be like headers here, I think. C standard mode OX238. I think I need to do this. Was it? Look, some shit. Oh my god, we're doing it. Oh, this is easy. This is easy. Okay, sweet. So this is the calculator mode. And I guess we probably don't, yeah, we probably just need singles in here, I'm guessing. It'd make more sense. Yeah. Okay. Standard mode. size. C standard mode size is 238. We have the. Let's go check what the C programmer mode is. Why not? Just so we have that information. C programmer mode up. We want layout programmer mode 2E0 bytes. So we'll do C programmer mode is 2E0 bytes, and I'm gonna do these in calculator order. Standard scientific. Okay. So we're gonna put in standard scientific OX310, and then C stats mode is an OX220. Okay. Ramification. Did I get that right? Let's see if my spell checker's working. It is. Nice. Okay, and the ramification is this will write that many bytes out of bounds. Then we have in scientific mode, we'll grab this, writes inside the C scientific mode structure. Let's put this in backticks. And C statistics mode writes this. A8, put these in ticks. We can put all the numbers in ticks. Okay, and no corruption, or we'll just say no type confusion in correct state. Okay. I guess I don't need the trailing ones. That's nice. Okay. So we'll just say full list of modes that we can confuse with. Center mode, and these we can backtick as well. Those are like high priority backticks. Okay, so we've got the standard mode, write 90 bytes out of bounds. We've got scientific mode, where we write inside the scientific mode structure. Keep in mind on 32-bit calculator, a lot of these things could be different. So in 32-bit mode, it's possible this could be exploitable, but on 64-bit mode, maybe first of all, we're writing a D word, which kind of sucks. Luckily, we're writing an aligned D word, so we're writing to like the right location in memory. Okay, you want an explanation of offset, so let's hop into that. So now is kind of a good time to look at roughly like what a structure looks like in the like assembly, or I guess not assembly, but like byte level memory view of an application. So we just need to see what kind of symbols we have in like NTDLL. I want to get some like real examples in here. Come on. These might do. Oops. Why is my clipboard not working? We don't have type information. We need something with type information, which... NTDLL star. Okay. I just want like some structure that's public. I'm blanking on like a good one. I can do a reload F and then DT like rect. This should show up. Definitely should be in those. Is it really private? Oh, why am I like mind blanking on anything to type? Now I've like convinced myself to to not think of one. Son of a bitch. Someone give me something in NTDLL or like a structure. Or what do we have full type information on? So Combase. So here are like a bunch of different structures in Combase. Oh my gosh, stop. Those are globals now. Okay, let's get like one of these structures. Oh, well that was a terrible structure because it has one field in it. Oh my god, come on. Why is everything just one field? P-shrink volume information. Let's grab this. Man, that one even sucks. I want like a relatively complex structure. P-image aux symbol. Okay. So basically, this is like what the structure will look like in memory when that gets created. Like if you're writing a C or C++ application, in memory. So this case, this is actually a union. So we have all the different fields of the union, and then if we look at one of the types of the specific ones, wait, really? Oh, this is like templated shit, which is yeah. Okay, need a better example. There's like a good. I think with X, you can get, oh my gosh, why is this like spanning 8 monitors? Whoa. Whoa. Okay. Yeah. I don't know the right way to look at generics. I mean, actually, I should be able to do this. Ah, come on. Clipboard. I don't know if my key is dying. Okay. Do we have like this? Okay. Come on. What is it? C++? File? No? This? Oh my god. I'm failing. So, I'm just trying to think of like a good example of a structure somewhere. What's this? Okay, so that's in, I guess, enum. All right. We'll write a little test application. 64-bit mode. Test. Probably already have a test. Nope. So if we made a struct foobar, and this had an int in it, a, and then we had like a unsigned int 64 b, int c, put a pointer in here, f. Oh man, that Rust. Struct foobar ASDF, and hopefully we can get the debug info out of this. We're just gonna debug break to cause this application to crash. What do you mean by unsigned? Ooh, okay. Perfect. That's a good question. So basically you have signed. Signed values are, so at like in C and C++, all of these fields are basically limited by like their size. So in this case, this is 4 bytes, and int is 4 bytes, and int 64 is going to be 8 bytes, 64 bits. So this is just a 32-bit number, and basically, semicolon after struct, yeah, holy shit, Rust. So signed can have both positive and negative numbers, but it has a smaller range in bits. And the reason for that is, so let's say we put this in dword mode. So this can, or we'll say word mode, so it's a little smaller. And basically, if we put like all the numbers we want in here, we'll go into decimal mode, right? This is like the binary representation of that, in this case, 16-bit or short field. But if I flip this top bit, it'll actually become negative. And basically, when you say that you want a signed number, that means that you want this top bit to have a special meaning that tells you whether the number is positive or negative. And it affects like the other states of the bits with like the 2's complement math. But effectively, you're saying that I want 1 bit of this allocation to be allocated to holding that data. And that means that you sacrifice some of the rest of the bits that you have that can count your number. So in signed mode, you basically lose 1 bit. And that's why like a signed 32-bit number is negative 2 billion to 2 billion. But a unsigned 32-bit number is 4 billion fixed, and it's just 0 to 4 billion. So you basically kind of like change the range of the window that you have. You move it from negative 2 to 2 to just 0 to 4. But it's the same range, so you're kind of like changing how much allowance you have for large numbers. I guess that's kind of a weird way to describe it, but that's how it be. So now I should be able to look at the structure definition for this. Look at dt foo bar, and this is just going to be on test. Reload. Got to build with symbols. ODZIZO. That's going to enable all of the full symbols to get generated. And that also means that we're going to get like this, in WinBag, you get like a split view. So this would show us, if I can get this to latch in, you get to see your code kind of on the side where you are, where you hit, which is always nice. This is like one of the only things that I use in WinBag like to have a window open for, but it's super convenient. So dt test foobar. So this is the way that this structure looks in memory. And basically, the processor wants to align all of the, like, you never want to access a field of a structure unaligned. And thus, we have like a 4-byte thing here, a 32-bit integer, the first field of this structure, or this structure over here. And the next thing in here is a 64-bit number. And the 64-bit number wants to align to an 8-byte boundary. Because if you don't have an 8-byte boundary, then the processor could potentially split a cache line here, and it's an unaligned access. It's just the processor does not like reading things that are on a different alignment. So while this is a 32-bit number here, which is 4 bytes, the next part of the structure ends up on the 8th byte because it put 4 bytes of padding space in there. It's just 4 bytes that don't show up in your structure. They're just kind of hidden, secretly tucked in the closet. There are 4 extra bytes after this field to keep alignment on this. And then we see it again when we go to another 4-byte field. It's able to put it directly after the 8-byte on the 10. And then we have a pointer here, which has to realign once again. So this structure, while it looks like it's 32 bits plus 64 bits plus 32 bits plus 64 bits, it's actually 4 64-bit numbers in memory, effectively. And that is just to keep alignment of all of these fields. So when I'm saying an offset in a structure, I'm saying that the type of the base type of a structure, so in this case, this would be a foobar structure. Let's say foobar was pointed to here, so this is at offset 0. So if you were to take the pointer to foobar, so you're looking at where foobar is in memory, you would see that there is 8 bytes directly at that location that you can read as a 4-byte number or a 32-bit number. And then 8 bytes into it, there would be a field B. So let's see. Do we create a foobar structure? We do. db test ASDF. Okay, let's make this structure actually initialized, and we'll print something from it. Just wow, I can't type C anymore. It's not like the language that I'm used to typing out. Okay, and that's technically not a pointer, but it's C, so it won't complain. But we can just clean this up and say F. So that is something that Rust would complain to you about, that C does not. So you're able to just use like arbitrary format strings, which can be a security issue, because if I said this was a pointer, and I mean, in this case, it doesn't really mean anything, but if I said it's a string, that means this is a pointer to a string, and if this were a number here, like 5, this would end up crashing, because this is going to try and print a string that doesn't exist, right? You're going to crash because this application is going to try to print 5 as a pointer to a string. And if you make mistakes like that in C, C doesn't give a shit, right? C's like, sure, go ahead. Like, no warnings, no errors. Everything about your code is perfectly sound, even though it will crash 100% of the time. Every single time this application runs, it will crash unless you're on a system with the null page mapped in. And it's like, why? It's too hard. It's too hard to get this shit right. Like, I've been writing C for 15 years, and I can't get this shit right half the time. No one can. No one can. It's not like you have to be a good dev or you have to be a bad dev. It doesn't matter. Like, regardless of how good of a developer you are in C and C++, you are going to make memory corruption bugs all over your code. Like, it's just going to happen. It doesn't matter if you're the best programmer in the world, your C code is going to be riddled with memory corruption bugs. It's just like, it's too hard. You can't get this shit right. You can't write that much code and get everything perfectly right. We can't write languages, or we can't write code in this language. We just humanly can't. I didn't even include standard IO. Yeah, it doesn't care on Windows. It will if I go into wall mode, and in fact, it will actually complain. So it doesn't have printf, and Windows has some pretty awesome things. So, let's see. So basically, in warning all, it actually tells you that it's adding these padding bytes after these points in the structure, which is really cool. Obviously, this is not really useful information. It's not really a good warning to have, I think. I mean, obviously we're in warning all mode, but it's like, what are the ramifications of this? And then no prototype. This has to be void to be conforming. And then that doesn't like printf, or actually it does like printf. It's being inlined. And then in Windows' compiler in Visual Studio, you can do analyze, and that one should pick up on hopefully really. Is that gone? Did they get rid of sal annotations?
By the way, I feel bad. I never asked you how your love life is going.
So Windows has something called sal annotations, or Microsoft does, and basically it allows you to so these are sal annotations, which Microsoft has in pretty much all of their code. And this allows you to basically tell the compiler a little bit of information about what is going on with your function. So you're able to tell it like what is in and out, what's a format string, what's not, whatever. And this allows you to, hopefully, should be able to analyze. And I don't know why. It's been so long. Do. What? Oh, did I fix the code? Oh. Thank you. Thank you. There we go. So it correctly gets a warning and basically says, hey, your format string's fucked. Please don't do this. Which is really neat. In fact, it will probably do that. Yeah. If I even don't have any of the warning flags on, these come up, bubble up as warnings in analyze mode. And it's like, yo, dog, your format strings are a little bit hanging. So, oh, it's doing it in that mode. Okay, maybe it's always doing it in this mode with cell annotations. But I won't do this on Linux. This is a feature that's kind of, well, I think like all the compilers now basically have one built-in for explicitly printf. But in Windows, you can make your own cell annotations where you can annotate a function that the compiler is not necessarily aware of. Having like certain properties. So I could say like this takes a format string, this ASDF function, and then we'll just grab the VA list here as well. Actually, we'll just find normal printf and copy that. I think I just gotta whack some dots on there. Printf format string params. I think just printf format string is all I need for this. That was saying it was attached to a parameter. And here we can just say like, well, we don't actually have to print anything. We can just call the function. And blah, 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 not a function. What did I screw up? What did I screw up? Oh boy, wow. Do I not know how to write C anymore? Holy shit. Oh, is it the dots? Probably complaining. What? Oh, I have variable ASDF. Ugh. Thank you. That makes sense. Okay, so I should be able to get this with analyze. Yeah. Yeah. So if you do analyze, so if you annotate your own code with these compilers, you're able to kind of like put that stuff in, which is nice. And it will give you a warning for this, which is pretty neat, given this is your own function that you wrote, and it's not like something that your compiler has special cased. And I think like GCC and Clang now have some annotation stuff like this too, but Windows has been doing this basically since the dawn of time, and this has led me to use the like VS compiler for a lot of my kernels, because I could write like annotated code. So like all of the kernels I've written in C were typically written in Visual Studio, and I just generated exes and then I loaded up the exes. But I annotated all of my functions with correct like sal annotations, and that allowed me to do like analysis on my code, and it made it like a lot easier to catch some of the stupid bugs. And then basically I did this for like 3 years, and then I found Rust, and I'm like, holy shit, I don't need to do this stuff anymore, because the language is just smart enough to know like all of these things and just make you write safe code, and you don't have to like be really strict about what these parameters could be, because it's so strictly typed in Rust. But I don't know. That's my tangent on that. But yeah, basically the layout in memory is just, when I'm talking about offsets, I'm saying that this structure, when laid out in memory, takes up 238 bytes, and that when I write to this location 2C8 bytes, I'm writing outside of the boundaries of the size of this structure, which is causing us to write into something beyond it in memory. So it's not some just normal field. You don't necessarily know what's going to be there. Based on random allocations that happen in the heap, you'll end up with like, you'll end up with different data after here. So I'm saying I can write 90 bytes into something that exists on the heap here. So I could maybe allocate some other type, or I could cause an allocation of some structure that has a weird shape that goes onto the heap that falls, let's say this in memory, let's say we had like this C standard mode structure on the heap, and then we had like a free block on the heap, because right, memory's just this linear block of like contiguous space. So we have this structure, and then we'll put something even in front of it just for grins. We'll say that like someone has a rectangle allocated out on the heap. Now the heap will traditionally try to bin things based on the size of the objects, due to kind of those alignment things and the size of being able to give back objects very quickly. You want to be able to grab and like something out of a pool, and just basically if you were to allocate like OX 80 bytes, and then you would free OX 80 bytes, and then you were to malloc OX 80 again, this would give you a pointer, this would free that pointer, and then this one would give you a pointer again. And what it's going to do is basically it's going to push this address onto a stack, and it's going to pick up the it's just going to pick up the address that was recently pushed, because once it's freed, right, it's saying like, I'm done with this object. It's giving this object back to the allocator, like where you got it from. And then he's just keeping it around in memory for a little bit longer, and he'll give it up to someone else who needs another allocation of 80 hex bytes. So that's basically how allocators work. So when you're doing these heap grooming things, let's say somehow rectangle is the same size as standard mode, because if you were to do this for all object sizes, that would mean that if someone were to allocate 1 byte, and I think I had a typo there, it was supposed to be OX80. I don't know if I deleted a character. But basically, if you made this return back this 80 hex allocation when someone allocated 1 byte, you would have 79 hex or 7F hex bytes remaining that you're just not using in that allocation, which would cause memory usage to go through the roof. So basically, they keep these in different bins. But if these were all the same, and that's like just universal across basically all allocators, it's just like fundamental to them for any level of efficiency. So if this rectangle structure were roughly the same size of this like standard mode object, that means they would maybe be in place in the heap, like in order, and then there would be a couple extra free blocks. So when the allocator needs to go to the kernel to request memory, it's going to request more memory than it needs, because it doesn't want to go back to the kernel anytime soon, because that's an expensive operation. So that's done like relatively rarely. So basically, it's going to allocate a little bit more when like a whole heap allocation occurs. So typically you'll end up with, at the end of the heap, you'll have like the most recently allocated thing. So like someone allocated a rectangle, and then later in time we came through and we allocated a C standard mode. And let's say no allocations have occurred since we have allocated, and no frees have occurred on objects prior to us. So like rectangle has not been freed yet, it's still in use by someone. So this is how the shape of memory could look. And what this means is that someone could come in and allocate something like supercritical data. And that has everything. That has your nudes, and that has your all your launch codes. It has like everything in there. So what you can get is in situations where you end up using a C programmer mode object on this one. So like for some reason, this object, exactly like the bug we're seeing today, and this is not going to line up, but over here it won't line up, but we'll just close that. So if you had some object pointing to this, and for some reason you had this as a C programmer mode. So basically, if you're doing some operation in some function like we are, because we're operating on a C programmer mode function while we have a C standard mode in operation. So like our calculator is in standard mode, but we can send it a command which will cause it to perform an operation on that structure as if this memory is a C programmer mode. And C and C++ just have no restrictions to that. That's just fine and dandy. The language just doesn't give a shit. Like it is so far from knowing what kind of error this is that this isn't even like if you were a high-level language developer, you would just think like, oh yeah, like if you're accessing this as a C programmer mode, it would just be like, no, you can't do that. The type mismatch or like incorrect type, something like that. And in C and C++, it's just like, fuck it. Yep, sure. Yeah, you think that's a C programmer mode? Go ahead and use it. And so this will use the C programmer mode structure, which accesses a field at 2C8 bytes. So for some reason, because remember, if this were in the right state, this C standard mode structure would be a lot larger, or this programmer mode structure would be a lot larger, right? Let's say like on the heap, this would be a much larger structure. So this would be able to access, let's say here, which is the 2C8 bytes. So this is like the 2C8 byte access. So if it were in programmer mode, if this were actually a programmer mode thing, it's accessing some field that's in bounds of its structure, and it's great. However, if it's in standard mode and it uses this object in this state, it's now accessing 2C8 bytes out of bounds, and this out of bounds location is like just in whatever is on the heap right after it. And that could be a freed block, that could be some actively allocated block with critical data, that could be pointers to functions, that could be so many different things. And basically, by the application performing this, it allows us to overwrite things in a structure that we do not control. And like, thus, we don't own that structure. We don't have, we're not the ones like maintaining that structure, and we're just stomping over it. Like someone's just coming by and fucking up this structure and not telling the person who owns the data. So everything just kind of gets fucked up in this situation. And that is what a type confusion bug is. And that's what we have here in calc. So that's my mini rant. What is the 13D command? I don't actually know. So that's just gonna like do some random operation on the calculator. We could try and figure out what that object is. Let me get this cleaned up here. Okay, that looks good. So, isn't it switched to hex? I haven't looked here. Oops. This is the one we want. Or I guess we have this one on live repro. Okay. Okay. That didn't crash because it was in programmer mode, right? Since this was in programmer mode, it's like, yeah, just fine. So it's like refreshing this. Whatever it is, it's causing like this programmer mode thing to get redrawn. So it's probably some command to like redraw and refresh all of these numbers. But if we switch modes, now it goes out of bounds, but this isn't crashing because we don't have page heap on, right? So this is just fine. It's letting me overwrite memory that I don't control in random structures on the heap. And it's just fine with that. Until here, where we ended up getting a crash where we're accessing a pointer to something that is 23C followed by 00003F. And it's like, well, that's a fucked up pointer. That is not a valid pointer. And, well, who could possibly generate a 3F? Well, I don't know. Maybe this programmer mode. So we're able to generate a 6.3. And if we look at what a 6.3 is in hex, if I can load another calculator, 6.3 is a 3F. So what we're doing is we're writing the 6.3 over something in the heap that is after us eventually. And for a while, nothing was crashing. Everything was fine. Everything was good because we hadn't overwritten anything that was critical. Like, we were just overwriting things in structures that didn't seem to matter. But then one of these structures came by, this C glow button. And C glow button was the poor victim of today. C glow button was just minding their own business in the heap after this structure. And C programming mode just got up in there and fucked up his shit. And look what happened. There you go. That's an explanation of exactly what happens when you have type confusion. And so this is why it crashed in such a weird location, because this would be a pain in the ass to debug. You'd be like, what the fuck is going on here? Like, okay, shit, the glow button's getting deleted and it's crashing, but what happened? And nothing in this call stack has anything to do with the programmer mode. Nothing in here is telling you that programmer mode fucked up your shit and made your stuff crash, even though your code, your glow button code, didn't do anything wrong. And you would be sitting here all day long trying to figure out what the fuck's going on in glow button before you realize that some other thing just stomped over your memory. And these bugs are a pain in the ass to debug. And what's really difficult is going back to these, to like when you have a crash, right? So what we did is we used page heap, which made it crash a little bit sooner, which made it easier for us to realize that we were writing out of bounds on a structure. And then we looked at the type of the structure. We saw that we were in like a standard mode structure, and we were writing stuff over it in programmer mode. And to us, it was pretty obvious that that was some sort of like a type confusion bug. But if you didn't have page heap enabled or something like ASAN or one of these like memory protection things, instead the developer would end up seeing this shit, and they would have no idea what's going on, because it is so confusing. Like, it's so hard to debug that you're getting overwritten with a 3F. Like, maybe the only thing that would trip you off here is like, oh, 3F, isn't that 63? Don't we display 63 on the calculator? Like, trying to debug this would be really hard. And effectively, that is what, like, bug triage is. Bug triage is like being a really good debugger. Like, you get crashes. When the crashes come along, you, like, hook up all of your debugging tools, your disassembly tools, and you try and figure out what that application is doing, such that you can make the conclusions that we just did, right? Like, we know exactly what the developer fucked up, and we now can think of that as like, okay, we just know the ramifications. Like, this developer thought this was safe to access this as a different object, and they just did that for like a long time. But sorry, there's like someone driving by, like the water district. So basically, like, we now know effectively what this bug is, and now we could use this bug to try to manipulate the data in some way that we could get control. So like, let's say this was a length field for some object, and it was tracking the length of like some critical data that's on your machine, and perhaps you could overwrite that with a if you could overwrite it with a 3F. So maybe the data, like the critical data, is like 4 bytes or something like that, or some structure on the heap or something. And basically, if you could overwrite the length, maybe you could have it echoed back to you. Maybe you could have the length of that data that's read back to you, so you could see what data has been like, sorry, keep driving by. Okay, there's like there's like this little access road to this water tower, and I never see people on it, and I think that's the first time I've seen someone drive on that road. I'm like, that's so weird. I guess they're actually just doing like service on it. I didn't know they did that. But yeah, effectively, what you'd be able to do, like maliciously, is maybe find like the length of something and overwrite the length with a 3F when maybe the length is supposed to be a 4. That could maybe cause it to copy 3F bytes into a structure that doesn't have room. And now you've turned this like random write of a 3F somewhere in your application. You've now turned that into a way of writing something anywhere in your application, because you convince something to write 3F bytes somewhere for you, and then that thing overwrites something that you want it to, and that causes like you to overwrite the "am I locked out of my computer" bit, and then you write over that with zeros, and then you're not locked out of your computer. So that's kind of like memory safety bugs in general, and specifically type confusion, with a perfect example of an actual type confusion in calc. So Rust would be a good way forward for this, although I think Rust is a little bit too difficult to use for the average developer. It's just a little bit complicated compared to something like Go that's a little bit easier. I don't like Go at all. I would never fucking use Go. But I don't think Rust is really the language that people should be hanging out in my opinion. It's a hard language. It's more of a systems language. They're making it better with some like async things, but it's a pretty low-level language at the end of the day. There are a lot of things that you can do in like Java and C# and things trivially that you can't do in Rust. But as a like systems programming thing, to like manipulate data at a binary level and to make like OSs and things, it's fucking awesome. It's just like C++ where you use all of the C++ 2019 features and all of the auto pointers and everything everywhere perfectly without mistake. And it's like, holy shit, this is awesome. You're just writing C and C++ code, and you have no safety issues, and you don't have to worry about freeing things because the compiler knows how long things need to stay alive until it's safe to free those up for other people to use. And like in C, you have to put those explicitly. You have to like tell the compiler, or basically the system, hey, I'm done with this object, like at the right time, every time. And if you fuck up that decision once, everything's busted. What about panics? I don't really care about panics. Like, there's really no risk of panics. Like, that could be a denial of service, but like, if you're running a server that basically needs to stay up forever, spin up a thread, put a panic handler on it, and then you can just let that trash. Obviously you don't want it to, like, panics, you don't want to have panics in your code. They're always going to hurt, like, your behaviors. But if you're running network code and shit, you can just put stuff in their own threads with panic handlers. So but yeah, that's basically looking into a bug in Windows Calculator and exactly what it is. So, and kind of like the steps and processes of that. But I'm going to get some sleep because I am now tired. But thank you guys for watching. Hope you had fun.